You're ready to start learning to program Allen Bradley PLCs. You found the right place. Now let's talk about a few things that will help you be successful before we get started. First, this is nearly a 10-hour long video, so you're not going to hit the play button on it and 10 hours later know how to program PLCs. You're going to need to use that pause button, and you're going to need to go back quite often. That's what I want you to do, is watch some of the video and then practice what was said. And keep practicing that before you move on. Speaking of practicing, you're going to need some hardware eventually. We would love for it to be one of our PLC trainers, but it does not have to be. There is also a simulator. And what I'll say about the simulator is that'll get you through the first hour or so of this video. Enough to know if you really want to learn to program PLCs. But after that, you are going to need some hardware. We'll talk about that later. So let's go ahead and hit that first step, which will be downloading the free version of Allen Bradley's Connected Components Workbench for the Micro800 PLC. For this video, we are going to be using our Micro850 PLC trainer, but everything we're going through in this will work with the Micro820 PLC trainer also, or any Micro800 PLC that you might have around. One thing to keep an eye on is our newer PLC trainers, they use a 2080 L50E 20 QBB, and our older ones use the 2080 LC50 20 QBB. This is a newer PLC, lets us do some more advanced control over Ethernet, and so we did switch our trainers to it. So that may be the one hitch to look out for while you're doing this. But let's start off with what software do we need, and that's going to be called Connected Components Workbench, and it will be free. So I'm just going to open up a new tab, and I'm going to search for Rockwell, if I can spell Rockwell right, software. And you're going to see the Rockwell software portal come up, and we have some videos talking about it. But let's just go for software download. We're going to Google that. And we are going to be going to Rockwell Automation's Download Center, which is probably the first one. Now, you're going to see in a second, we actually end up in the product compatibility and Download Center. But let's just start here. And then, we're going to find product downloads. And when we click it, that actually takes us to the product compatibility and download center, or a lot of people say the PCDC, because it seems like everybody has to have an acronym. But right here in the search bar, I'm just going to type Connected Components Workbench, and you're going to get two options mainly. We have Connected Components Workbench, and we have Connected Components Workbench Developer Edition. Developer Edition does cost money, and if you're doing jobs out in the field, I do recommend that you get it, mainly because you're going to get 8 to 5 support from Rockwell Automation with that, which can be very important if you're out in the field and you have a problem. But the free one is Connected Components Workbench. And on the right side, I'm going to select products, and that's going to give us to right here. And then we're just going to click versions. That way we can see the different versions that are out there. And what I'll tell you is just download the latest version. In fact, I'm not even sure if I'm running, I know I'm not running 22. We'll look in a second. I'll show you where to look. But I'm probably running 20 or 21. But whatever the latest is, just go and hit the download button. And you'll have to log in. And there is no charge to create a login account. Just go ahead and put your email in and sign up with the Create Account button. But I've already done that step, and we already have Connected Components Workbench installed. And, what version am I running? To know that, we'll go to Help and About Connected Components Workbench. And I am running version 21. So 21, and I do have Developer Edition, but there is nothing that we're going to need for this series that actually requires Developer Edition. All right, so the next challenge really is getting online with your PLC, and I just can't stress to you enough just how important it is that we understand the difference between upload and download. So I know if you're watching this and I tell you to download Connected Components Workbench, we're taking that file from the internet and we're putting it on our PLC. We're bringing the file to our PC. PLCs are the opposite, and I don't care how you remember that. You've got to remember that. We download to the PLC, we upload from the PLC. So reading the warnings, reading what the prompts actually say, and honestly, the to and the from word, they may be the most important words in all the prompts. Just be looking for those. But first, let's go ahead and we're going to try to connect this PLC and upload the program out of it. And we're going to need to know the IP address. Now, the Micro850 does have a USB connector on it, and it also does have serial. But I will say that probably 95% of the time, maybe more, you'll actually be connecting over Ethernet. So that's the way we're going to work with here. And it's also the one that I see the most trouble with. So we are going to typically, if you're in Studio 5000 or any of those, usually we go to communications, and then right here would be where our software, our Who Active would be. And I'm really hoping Rockwell will add that just for familiarity. Now, what we're looking for in connecting components is actually this Discover button. And right now it's under File and then Discover. Kind of hoping they'll go Communications and Discover, maybe even rename it Who Active. That would make life really easy on us that are going between softwares. So we're going to go Discover, and then I am connecting over Ethernet. And, okay, I should have cleared my drivers out before this live stream because that's way more than you folks want to look at. I'm going to remove offline device. And okay, right now we have 3 devices out there, and this one is this is our Micro850, even though it is named Micro820. And then we have a PowerFlex 525, and we have an HMI. Now, these are very standard items if you get one of our trainers. The only difference is because I have a lot of different trainers in here, your default PLC IP address is going to be 192.168.110. Your default drive IP address is 192.168.112. And your default HMI address is 192.168.111. And if you have our motion control option, then its IP address is going to be 192.168.113. All right, let's talk through what does this mean that we're on 44? And let's talk through some of the problems that you're going to run into when you try to go online. And so to do this, we're going to go to our Start menu and type ncpa.cpl. Type the whole thing, and that will actually open up our network really quickly. Gets us to our network connections. Also, we could go to here and get our control panel. And usually you see a little globe right now. It says no internet access. We can also right-click it, open network settings, and then we can go change adapter options. That'll also get us to the same spot. Whoops, didn't mean to close that. Let's see. And you'll probably have multiple adapters. I have this stripped down where we only have one, but try to think through which one you're actually going on. Is it Wi-Fi? Is it wireless? And yeah, select the one that you're going over. And then we're going to go to Properties. And then we're going to go to Internet Protocol version 4. And this has your IP address configuration in it. Now, chances are yours, if you've never done anything with yours for it, will say obtain IP address automatically. And what that does is if we're, say, at Starbucks and we're using their Wi-Fi, that's how magically we're able to get on the internet. Now, if we're on an industrial control system, we usually don't have that option. We don't have a DHCP server to actually tell us, hey, here's where, here's the IP address to be. So we're going to need to put it in there. And I'm going to enter the wrong IP address just so we can see the issues that we would have and think about how to work through them. I'm going to enter 192.168.0.103. And I'm going to leave it the default subnet of 255.255.255.0. And I'm going to click OK to that. And we'll close that. And now, if I go to my Ethernet, notice that I don't have anything. Now, one thing to make sure this is browsing, make sure that you see this animation happening here. In other words, if I click down here on USB, see the animation is down here now. That means it's updating this USB list. That's not actually updating this Ethernet. And I'll try to make sure we stress that in just a second. But if your boxes are marching, if we see this little animation and you don't see your PLC, then don't go on the Connected Components Workbench or Studio 5000 or any of those. We have a networking issue. And if we feel we're not connecting over Ethernet to our PLC, we're going to go to our Start menu and we are going to type Command and find the command prompt. And this is an old DOS-looking screen, but this will give us what we need. And you only really need to know 2 commands in it as far as connecting to your PLC. So first of all, we want to ping our PLC. And I hope one thing that you folks understand by the end of this live stream is how important it is that you know the IP addresses of all your devices out there. And also, I see a comment often that I really do disagree with. So if you've ever been experienced with older PLCs, the MicroLogics, the Slick 500s, even older Control Logics, they couldn't actually store their descriptions on the PLC. So you had to have an offline copy of the file. It was very important if you wanted to connect to it. Now, with modern PLCs, they do store descriptions, which really is all the words that tells us all the crazy stuff is that we're getting ready to learn about. Now, what I hear a lot of people say is, well, with modern PLCs, you don't even need to have offline copies of the file because all the descriptions are stored. I firmly disagree with that statement for 2 reasons. First of all, we need backups because if this PLC dies, what good's it do that whether it had descriptions or not, we just lost our program. So we need to have a backup. But there's another very important piece of information that we're going to get by having an offline copy of the file. So I'm going to go back over to Connected Components Workbench, and I'm just going to open up any file just so you can see it. I'm just going to click this one. So this is a PLC that I have previously been connected to. And most importantly, if I double click on the Micro850 at the top of the left pane, then right here, here's the previous IP address of that PLC. So this PLC was 41. Now, in our case, I'm acting like we don't have it. We don't know it. And so I had no PLC to double click on. And that's why it's going to be really important that you know that. And yeah, the default of your trainer is 192, 168, 110. If you cannot discover it, then it's not in reach right now, but we have our PLC tool SIM IPE, and it can discover these IP addresses for you. And I'll put a link at the end of this video to this being discovered by it. And also schools, that probably is something that you want to have at least one of, because I'm going to show you in a little bit how easy it is for one of your students to accidentally download without an IP address to this. But all right, we know that our IP address of this PLC was 192.168.144. So I'm going to type PING and then space. And the space is the biggest thing when you folks send me screen captures that is showing it not working that you forget. But it's PING space 192.168.144. And here's the thing, and you guys, and when I'm talking about this, remember, this is not a networking class. This is, can I get connected to my PLC next week? And so all I care about here is, did I get a reply from who I pinged? So I don't care that it said transmit failed or anything else. We're going to show a good ping in a second. But as long as this does not say it replied from this IP address right here, then we don't need to go on. So this is saying, okay, can I talk to that device out there? And if you can't, then the second thing you need to know in the command prompt is IP config. And just to make it extra confusing, I know I stressed the space on the ping. The second big thing I see folks do is put a space in IP config. It is actually one word. And it's going to give the IP address of our PC. Now, If you go and talk to an IT department and tell them that you know about networking because you watched one of Tim's videos, you're going to be in trouble. This is not about networking. This is, can I plug into the machine that is in front of me and get connected? And what Tim's networking rules say is the first 3 octets, and that's group of numbers here, must be the same. And more importantly, this last one has to be unique. So I'm trying to talk to 192.168.1, and I am 192.168.0. Now, what that means is we're on 2 different networks, and it's never going to be able to talk. Now, more importantly, is this last one here needs to be unique. And I will show you how easy it is to mess that up. And honestly, I've never tried this with a Micro850. We do this as a regular exercise in our main class, in our in-person class, but it's with the compact logics. We may have a unique learning opportunity. But so we know now that we need to change this 3rd octet or group of numbers to a 1. Now, this is a change you need to make on your PC. We never want to change the IP address of our PLC unless somebody has really told us to or we put some thought into it. Because there will be other devices, such as in our case, our drive and HMI talking to this, and we could break those. So to do that, we're going to go back to our start menu and we're going to type ncpa.cpl. That opens us right up to it. And I am going to double click it, or you can right click it and go to properties. And then we want to go to Internet Protocol version 4. Now, there is also a version 6 down here. We're not using that as far as industrial automation yet. And you can either double click it or go to properties. And then I'm going to change that to a 1. That way we can see what it should look like. So, and also you notice I'm hitting the up and down arrow here. You can actually scroll through your history of commands by using your up and down arrow on your keyboard. And so I'm going to hit enter on that. And this is a good reply. Now, here's the thing, and again, this is not a networking class. My main thing is, did I get a reply from the IP address that I tried to ping? I don't care about TTLs. I don't care about bytes. I don't care about response times. Be really careful whether this reply is coming from who you're pinging, because you can get replies from other devices, being your PC, other routers, and other things. That means that maybe you can talk, maybe you can't talk. But all right, so we can talk, but let's talk about what I see. The big mistake I see people making, I think it's a rite of passage. We've all done it at one time. As we call and we ask, what's the IP address of that PLC? And somebody tells me it's 192.168.144. And not thinking, I go and I enter 192.168.144. And I'm going to click OK to that. And yeah, now we're going to go try to ping. Oh, okay. Well, guys, this one, very interestingly, and I told you we may get an unplanned learning opportunity. This does not work like the compact logics I just learned. Because what I heard this drive fault this moment I did that. So we're going to get a really bad unplanned learning opportunity here that hopefully I can fix by cycling power. But let's continue on. Let's see if we don't notice that, because if I zoom in here, you also see now I have red lights on our Micro850. And what's happened is I have created a duplicate IP address. So if we go back to our command prompt, and here's why I like these steps, because even though we've made a major mistake, we're probably getting called out because something was broke to start with. So we don't necessarily feel like it's something we did. And I'll go ahead and share the most embarrassing one where I did this exact thing. I plugged into one of the Grace port, one of those nice convenient ports on the side of a control panel. I shut the whole line down the moment I plugged into that. I mean, I had like 150 folks staring at me. And I was like, well, it wouldn't be. Well, sure enough, it was me. But let's think through it. Let's see how this works, because honestly, I've never actually done it this week. So the first thing we want to do is try our ping. And we get a very nice reply. And next, if we can, excuse me, let's go back. Let's start back at square one because, guys, we're in unfamiliar territory now. I'm going to go File, Discover, and let's just see how this does. We're going to go to Ethernet. And okay, we see 46, we see 47. Interesting. We do not see 45 or 44. So we would go to the command prompt now and we would ping it. And yeah, our ping is good. Now, if you come to my class, this is why, everybody, have you been to my class yet? Know it. I stress that you need to do step 3 next. And step 3 is the IP config. And now that I do the IP config, I see that my IP address is 192.168.144. I'm trying to ping 192.168.144. And back to Tim's networking rules, in order for us to communicate, these first 3 have to be the same. And more importantly, this is why it's important, this last has to be unique. So since I entered 44 on my computer, and the Micro850 was already at 44. When I did that, I took this PLC offline. Now, this is interesting, and this is a difference. This is a clear difference between how the Micro850 works compared to how the control logics and compact logics work. Is apparently this does not report. Let me explain a little bit of how this happened, because I wasn't expecting this time. And when you change your IP address on your PC, Windows does go out there and make sure that the IP address is not used. And if it is used, it usually reverts to DHCP. And since we don't have a server, normally you end up with like this IP address that says something like 169.254. And that's really where I thought we were going. But Windows, it went out and asked, is anything using that IP? And apparently the Micro850 did not respond when it asked that. And so, yeah, the moment we've done this, we're not making projects anymore. And this is a major deal. And I think we don't realize how big of a deal this is when we do it the first time or early in our career. But let's talk about downtime while we're here. Since apparently I've already taken the PLC down and we hadn't got started with this, is small business downtime, like a little larger than Amber and I. I mean, we'll say in the 10 to 20 employee range, your downtime is around $150 to $450 a minute, which means at the time that this has happened, you can almost buy a trainer. A medium-sized business, their downtime's $20,000 a minute. So we have to really think about this because, now we got 2 devices down. And honestly, I'm not even sure why this thing's down. We're in totally vague territory now. But all right, we're going to go ahead and fix this. Is I'm going to go back to my network configuration, and we're going to put this back at 103 because that's where we were. And I do not feel this Micro850 will resume communications, but let's find out. So now I'm going to try to ping the Micro850. And as I suspected, it does not. Now, I'm really baffled about this PowerFlex not being in the Ethernet list now. But we'll figure that out on the way. Oh, okay, good. We did get some replies. This is what I hope kind of happens. And this is what I mean by I could care less anything it says here as much as did I get a reply from the IP address I pinged. So I pinged 192.168.144, and I got a reply from 192.168.1.103. And at this point in time, you would not realize that's your IP address. Okay, so I am curious, though. I want to ping the PowerFlex. Okay, the PowerFlex pings just fine, and that's just awesome. So now let's find out if the way that we do it, the compact logics works, or if we're in total new learning opportunity. So the compact logics will actually recheck its network when it sees the Ethernet cable or the connection established. So I'm going to unplug the compact logics, and I'm going to plug it right back in. Okay, and it appears it does the same. So let's see if we can ping it now. What? Didn't realize on the wrong screen. There we go. So now I'm going to try to ping 44 again. Okay, and it does ping just fine. And actually, I'm going to, okay, I do get what's happening here. And this is actually a flaw in Factory Talk Links that I have never been able to nail down the timing of. In fact, during our training class weeks, this seems to happen like twice and at random different times. But we were able to ping it. And I stressed to you that your boxes need to be marching here. And I'm not seeing my PLC. And this is where a little bit of insanity clicks in. All I'm doing is click up here on the word Factory Talk Links. That gets those boxes to quit dancing there. Now I'm going to click right back on the word Ethernet. And, well, there we go. And magically, they both come back. All right. So that was a little bit of a detour. But, yeah, that really is making sure mainly that these first three numbers here, they have to be the same. And your last has to be unique as far as your PC to the PLC. And now, if you don't have that last one unique, then you just took your plant down. All right, let me catch up in the chat for a second, and then we'll move on to exactly what upload and download means. John Bravo, good to see you out there. Wyatt, good to see you again. Wyatt is a former student. Actually, Wyatt has been to both our Part 1 and Part 2 class. Jeremy Schmitz, glad you got here. Gil, hello to you too. Jaspered, hi. Yes, see, I had an engineer do this when it was live. I did it. I'm guilty. And it was one of those, it's like all I did was plug an Ethernet cable in. I didn't know this would happen. And yeah, I did. I mean, I got, you get 150 folks standing around. That's a lot of downtime. It didn't take long. Yeah. In fact, probably for the next 2 years when I walk in there, they'd be like, yep, there's that guy again. Don't let him plug in. So I'm going to select my PLC. Now notice, all I've done is do discover device. Mainly because I don't have a file open. And I'm going to click OK. And after I do that, notice it's creating the project and everything. And one thing you have to be patient during this. I hope in future versions they will add a status bar down here. But right now, as long as this bar is blue down here, that means connected components is still either uploading or downloading typically. You have to wait until this thing turns orange. And so I'm kind of hoping they'll put a status bar, or at least over here, say, don't touch anything or quit clicking. Because if you click too many times, it seems like all of a sudden we're having to repeat this. We got the prompt now. So we can upload the project and the controller to overwrite the current project content, or we can download the current project to the controller. And I stress in my class these three words so much because we're so used to downloading from something. Download current project to the controller. That means that we are going to take whatever's in our PC. We're overriding whatever is in the PLC. There's no undo button if you hit the download button. At that time, this is done. And what we want to do in this case is we're going to upload the program from it. So I'm going to upload. And okay, we can upload, and that'll just upload it with empty values, or not empty, because 0 is a number, with all zeros, or we can upload with logical values. And that's going to upload it, and it's going to get all the current values in this. But okay, so this pulled the program that was in the PLC to our connected components. And yeah, this is, well, actually, honestly, folks, I'm not even sure what program's in. Okay, this is a hybrid. This is a mixture of our getting started program and a program I was doing for Festo Didactic also. We're playing with their Mech Lab trainers right now. But okay, so we just want to have that. I've saved it. And now I'm going to go File, Close. And this is going to get us back where we started, square one. And now we're going to go File, New. This is how we're going to create a new program. And, whoops, did I click File New or did I click File Open? I think I clicked Open. Okay. And Project 23 is going to be fine. I would not name yours Project 23, but I'm doing this one just for this live stream, and I will delete it afterwards. So I'm going to hit Create. And then we need to go find our PLC, or we can select existing. Now, if we hit select existing, then that's going to open up our browse window. But I want to do this from the catalog because what if you're not looking at your PLC at that moment? So under controllers, I have a Micro850. If you're using our Micro820 trainers, you would go here. The Micro820 trainer is a 2080 LC20 20 QBB. And Micro850, if you purchased our trainer in the last maybe a year, I think it's ticking up on a year, then you're going to have the L50E. Before that, it was the LC50. And if it was the earlier one, it is a 2080 LC50 24 QBB. If it's a newer one, it's the 2080 L50E 24 QBB. Must select it and click Add to Project. All right, now let's go ahead and talk through some pitfalls before we even get too far along with this. I really struggle with symbols, so I had to mouse over this, but this is your download symbol. This is your upload symbol. We download to the PLC, we upload from the PLC, and I may repeat that another 20 times in this live stream, but be really careful of this. Or we can hit where it says disconnected. This is actually a button. It has a drop down. You could select connect, or you can simply click here, and that'll take you there also. Now, since we just created a brand new program, it does not have a path. You see here under connection path, it is blank right now. And I'm going to click my arrow by Ethernet, and we are going to download this to 192.168.144. And our default, usually it's 192.168.110. I'm going to click OK. And we're going to take these prompts really slow because right now I'm showing you something, especially instructors, is something you have to watch out for. So first of all, read these words. Download current project to the controller. That means we're going to take what's on our connecting components and put it into the PLC. And that is what we want to do. And then again, we can download it. We can download with project values. With rare exception, usually download with project values is the better one to do. That way, if we had any particular settings that we had changed from 0, those will go in there too. So I'm going to click that. And instructors, this is the prompt that 100% kills. Well, it'll kill you next week, but also instructors will even think that you'll think you have a bad PLC. It says downloading current Ethernet settings will result in disconnection from controller. Continue with downloading of the Ethernet settings. So that whole thing where we just learned about those IP addresses and figuring out this number, what we're getting ready to do is we're getting ready to download a program that doesn't have an IP address assigned. And in the connected components workbench's case, that means it defaults to DHCP when you do this. Now, if you're doing Studio 5000, I think this is something they do way the heck better, is you can even change the IP address really using that download from Studio 5000. It is a whole different deal. But let's talk through this prompt just in case you see it. 100%, unless you're sure that they actually put the right IP address, you want to have them click No to continue in downloading of Ethernet settings. Now, this is going to keep the download going. There's no way of getting out of our download process at this point, but we're going to click No. That's going to keep it at the old Ethernet settings. And then, and here's why I stress this so much, is typically this is the prompt that they're getting. Is usually they want to put it in run mode. And then if we click yes, which we want to click yes to this, normally that means yes to change those Ethernet settings on the previous screen. We're going to click yes to that though. And now we need to go fix those settings. If we accidentally do that, what we want to have the student do is go to the Micro850 at the top of the left pane and give it a double click. And then we want to go to Ethernet. And right here, what we did is we downloaded a program that says obtain IP address automatically from DHCP. And it warns us here, the settings in the project and controller are different. And if so, to fix this, all we're going to do is click the update from controller button. And that fills in our settings, and now we're ready to go. All right, now let's talk about how we should have done that. So we're going to go File, close. And I'm going to make another new file. And I'm going to controllers, Micro850, L50E, and I have a 2080 L50E 24QVB. Select, add to project. What I should have done is right away, in fact, it's already on it now, but let me close it just so we can actually see how it would have been the first time. I want to double click on the Micro850 in the top of the left pane, and we're going to select Ethernet. What I should have done is entered it right here. I want to configure IP address and settings, and I want it to be 192.168.1, and in this case, it's 44. Yours is going to be on 10. And then the default subnet of 255.255.255.255.0 will be fine. And because I'm doing some routing videos right after this, I am going to set a gateway address on mine. You don't have to. It's 192.168.1.1. One other thing I want to go ahead and bring attention to, because I know a lot of you use other trainers with my lessons, and that's cool. But yeah, there is one training company out there that their instructions say, leave it on DHCP, wait a minute, and then go browse it and find the IP address, because it'll have like a 169.254 number after that. That is not how you do IP addresses on an industrial network. And if you happen to be the company out there that has that in their instructions, can you please just take that out so I don't have to talk to any of your people about that again. But yeah, so we want to assign an IP address to this. And there's another thing that we should do is we also have our plugin modules. And semi-refreshingly, you don't have to configure these plugin modules, but in order to use them, we do have to add them. So I have a 2080 IF2 and a 2080 OF2, and these are on your Micro850 trainer by default. Your Micro820 trainer does not have those because it has the built-in 4 0 to 10 volt analog inputs, and it has 1 0 to 10 analog output. So we are going to go ahead and configure those. And to do that, we're going to right-click the plugin module. And this is an analog module. Really, I love how they really do have this simplified through here and make it really easy. I have a 2080 IF2. That's going to be my first module. And in the second one, right-click, analog, 2080 OF2. Now, we are going to use these in our next Micro800 live stream, where we're going to talk about analog. But for this one, we won't use them, but I want you to know how to configure them. And then, instead of us going ahead and downloading this time we are going to create a program. So we're going to right-click Programs, Add, and notice we have 3 languages here. We have structured text, ladder diagram, and function block. And no, one of them is not better than the other. They all have their purpose. And in the end, you need to understand all 3 of them. But if you're in the United States, I will say that maybe 98, 99% of what you will run into will be ladder logic. And nowhere in that sentence did I say ladder logic is better than the other 2. But my goal is to get you up to speed as fast as possible so that you have marketable job skills. And so, yes, we are going to start with ladder logic. And yes, later on, we do have videos on structured text and function block diagram. But we're going to select the ladder diagram. And then we are going to open up Prog 1. And we are going to put in what they're calling a direct contact examine if closed. And if you've watched many of my videos, then you know I call this a go look for 1. But don't worry, we're going to go through it and explain why. And then we're going to bring down this one, which is a direct call output energize. Right above it, we have a blank spot. And here we can go find our addresses. Now, let's talk about our I/O. This trainer right here is actually my video trainer. So its I/O is already hardwired. I didn't actually test it before this, so we were doing an encoder video. So I hope it does work. If not, we'll have another learning opportunity. That's cool. but it is wired exactly per our getting started guide. So if I go ahead and bring my Chrome browser up and go to twcontrols.com, and then behind that, and this is in your training guide, we're going to type getting started, all one word. And that brings you to this page right here that gives you some really quick getting started guides on how to get your trainer unpacked and how to get the most out of it. And most importantly, then we have our sample programs, which just tells you what's pre-installed, and we have the wiring enough to get started diagram for your PLC trainer. And if you click it, then this tells you how to wire your trainer up. This page 2 here is the factory I/O wiring. Actually, I skipped over page 1, but it gives you a quick explanation about how to read this. And then there's our compact Logix wiring. Here's our Micro850 wiring, which is what I'm using. And there's the Micro820 wiring. And for the Micro850 inputs, 4 through 8 are going to be buttons 1 through switch 1, and outputs 0 through 3 are lights 1 through 4. And that's all we're going to use in this series. So go get this diagram and do your wiring. And there will be several resources in a playlist at the end of this to help you troubleshoot if it doesn't work. And because we do need to understand a little bit about syncing and sourcing. Also, some of you are going to notice your lights glow. We'll talk through that and several other troubleshooting items. So once you have those wired, then that means, in fact, let me just look at mine. All right. In fact, we should go ahead and test our wiring. We should go ahead and test our wiring. So actually, before we do this, let's just take this line back out. Just delete it. So we have an empty ladder routine, and we're going to download this program. Now, last time I told you could just hit here. It says click to connect, and you get the prompts for upload and download. We can also simply click the download button right here. All right, so we are going to open up Ethernet, and we are going to click 44, hit the download button, and I want to download with project values. I'm trying to think of a time you wouldn't want to do that. I'm sure there is, but for the most part, I usually download with project values just so I get all the settings that I may have changed in the offline program. And all right, this is the normal prompt you should get. Download is complete, change back to remote run. And here's where if the Ethernet settings didn't match, it's so natural to hit this yes button that we end up with PLCs that don't have the right Ethernet settings on, but I'm going to click yes to that. And then on the left pane, we're going to go to our global variables. Oops, got to wait on that orange bar. There we go. Global variables. And the I/O addressing of Connected Components Workbench is different than Studio 5000. So in Studio 5000, if it's touching the PLC, it will begin with local. And if it's not touching the PLC, it will not begin with local. In the Micro800's case, it's going to begin with _IO. That means it is some type of IO. And then we have EM. That means the embedded modules. That means the inputs across the top or the outputs across the bottom. That does not include our plug-in modules. Then we have DO for digital output and DI for digital input. And I hear they fixed this in 22. But also watch out. You notice the digital outputs are above the digital inputs. Just be aware of that. That's tripped me up a couple times. And if we go on down a little bit, we see IO and then P1, that's going to be plug-in module 1, analog input 00, and plug-in module 2, P2, analog output. All right. But let's go ahead and test our inputs and outputs. So when I press the green button, then look, I was even ready for it up here. I don't know why that always trips me up or why they're in that order. Digital input number 4 turns on. When I press button 2, the yellow button, number 5 comes on. When I press when I press input 3, number 6 comes on. And when I press number 4, number 7 comes on. Switch 1, is number 8. And then we want to test our outputs, and we can test our outputs without any code. So all I'm going to do is check this box by a logical value. That's going to put a 1 in that box. And when I do, I get a green light. When I do an output 1, I get a yellow light. Output 2, I get a red light. And 3, I get a blue light. So make sure your wiring works before you move forward. And then, since I have Developer Edition, I could do a run mode change, but I'm not going to. I'm going to hit the button here where it says connected to disconnect. It's going to take me back offline, and then we're going to go back to where we were. So I'm going to bring down this instruction, the direct contact, examine if closed. But if you come to Tim's class, or hopefully by the end of this video, you will be calling this a go look for a 1. And then this one here is an output energize. And then we're going to bring a new rung down. That's the H looking symbol on the left. Also be really careful because honestly, I think mine are out of order. You can accidentally drag these. Oops, separate knowledge, I'll get somewhere crazy. But notice, oh yeah, where did I just drop that? I did. Okay, because yeah, my output energize is in the wrong place. But okay, so then we're going to bring this one down. They call it a reverse contact examine if open. I call it a go look for a 0. And we'll bring another output energize down. Now, one thing that is really cool once you know that you can do it is if, let's say I needed this to be a go look for a 0, if you highlight it and you hit the space bar, you can actually toggle through the different items it can be. I do want that as that one though. And same on these, you can. Or, since I have this highlighted here, right now it says direct contact. You can hit the drop down here. That does the same thing. Okay, so for this one, I want the green button. Now, right now, I got to know which one of these is the green button. And so what we want to do is we want to put some descriptions on these to make life a little bit easier. So we're going to double click on our global variables in the left pane. And so input number 4 is our green button. So in the alias, I'm going to call this the green button. Now notice we can't put spaces, which is really awesome. I don't know why we can't put spaces in Studio 5000. I think they can work that out. But one thing to be aware of is an alias in Connected Components Workbench is not the same as an alias in Studio 5000. It's more of a description that we can also manage to go find in our browser when we're going to look for tags. So this description here is a little bit deceptive. In fact, I'm curious. Let me come back to the theme. I'm going to really squirrel off. So input 5 is going to be the yellow button. Input 6 is going to be the red button. Input 7 is going to be the blue button. Input 8 is going to be switch 1. And then on our outputs, output 0 is going to be our green light. Output 1 is going to be our yellow light. Output 2 is going to be our red light. Output 3 is going to be our blue light. And now if we go back over here and we hit our drop down, I can start typing green. And there's my green button and my green light. That way I don't have to necessarily remember these. I still think you need to be very familiar with them because what I see a lot of you do, especially you that are going to use the simulation software for this, and arguably up until this point you can use the simulation software. I see a lot of times if you're more of just in the simulation, you've never actually seen any hardware, I see you struggle to actually associate this wire right here is the green button. So aliases always say are a double-edged sword. They can help us programming wise, but they can arguably make our lives really miserable if we're troubleshooting the electrical part. And let's face it, once the program's programmed, it works. We're going to be in the electrical part. We got to be able to connect to that. But yeah, so then I'm going to put the green button here. And over here, I'm going to put the green light. And on the second line here, I'm going to put the green button again. But over here, I'm going to put the yellow light. And let's go ahead and download this program. Even as simple as it is, we can learn a ton with this. In fact, if you will understand these 3 instructions, I'll say that you probably can get through 70% of the PLC programs that are out there. So I am going to download this program. We should get a yellow light here. We do have a yellow light. Awesome. Okay. So one thing to be aware of, let me get there and say, one thing I don't like, in fact, I should have had Studio 5000 open for this. I don't think it's really obvious that you're in run mode. So if we double click on the Micro850 at the top of the left pane, and right here you can tell whether you're in run, remote, or program. And then if we're in the remote mode, are we in a remote run? Or are we in a remote program? So right now we are in remote run and our PLC is running. Oops, didn't mean to pin that. Okay, so now we're going to go back to Prog 1, which if you get lost, it's Micro850 Programs, Prog 1. That's where we're working at here. And let's see, let me get my bearings straight. Okay, so this instruction, according to Tim, is a go look for 1. And where is it going to look? At IOEMDI04, or now we have it labeled as the green button. And if we double click on it while we're online, there's that note, there it goes. Then that brings up the controller, or not controller, and this is called the variable monitoring. And so if I press the green button, we get a checkbox there. Now, if we're in Studio 5000, this actually does put a 1 in there. So the one variation from this is a checkbox is a 1 in the box. No checkbox is a 0 in the box. So this instruction goes and looks for a 1. We're at IOEMDI04, which is right here. If it has a 1, it is going to be true. If it does not have a 1, it's going to be false. And right now, it doesn't. It is false. And so here we have an output energize. A false output energize is going to go right as 0. Where to? IOEMD0. Okay, now, arguably, I could probably get this scroll to where we could see both of these at the same time. But right now, what I really want to see is I want to see this green button, green light, and yellow light values all at the same time. So what I'm going to do is I'm going to right click on any of them. And I am going to add to spy list. And that's going to give me a little spy list thing up here. And I'm going to actually dock it right down here. And I don't need it that tall, though, so I'm going to bring it down a little bit. So now I can see IO, EMDI4, green, and logical value. And yeah, I mean, I get it, connected components, workbench, but why can't you just make this a 1 and 0, just like the rest of everything else? But now I press that, and we can see that live value. And so now I am going to right-click the green light, add it to my spy list, and I'm going to right-click the yellow light and add it to my spy list. That way we see all of them at the same time. So right now our green button is not pressed, so it has a 0 in it. This looks for a 1. It has a 0, so it is false. It passes false conditions on to this output energize, and a false output energize go right to 0 to the green light. And right now our light is off because it has a 0. I'm going to press my green button, and this instruction goes and looks for a 1 at IOEMDI04, which is our green button. It now has a 1, so it is true. And a true output energize goes and writes a 1. Where to? IOEMDO00, which is our yellow light. So we can see the light versus the button. And there we go. And so now our green light is on. I let off my buttons. This one's going to do the opposite. This goes and looks for a 0. We're at IOEMDI04. Do I have one? Yeah. Since we don't have a checkbox, it is a 0. So it is true. It looked for a 0. It saw 1. It's true. And a true output energize goes and writes a 1. Where to? IOEMDO01, or our yellow light. I press my green button. This instruction is going and looking for a 0. Had IOEMDI04. Now it does not have one. So it is now false. It looked for a 0. It saw a 1. It's false. And it passes false conditions on to an output energize. And an false output energize goes and writes a 0. Where to? IOEMDO01. And so our yellow light goes off. Let's see really quickly in the chat because I just saw it pop up there. Sam, yes, this will be available for later, and there will be some other videos at the end of this to help you out. All right, let's talk about a couple things about this. First of all, I mean, I am serious. Probably if you will just take what I just said and go with it, you can probably get through 70% of the PLC programs out there. What are we, an hour into this? So, I mean, you're 70% of the way there. Now, the next 10%, you'll probably get through to the end of this live stream. The next 10% after that, it might take a year, and the next 10% might take 10 years. So it still is a long haul, but these first few, really, this gets you through a lot. But let's just see how that actually looks here. Let me zoom on in here, and yeah, bring that down. And so if right now I am not pressing the green button, and remember, that's why right now the yellow button is on. I press it, and it turns on. Now, there's several major mistakes that you can make about now. And I really, I know I get some instructors that get really hostile with me about this part. The worst thing you can do right now is call this a normally open contact and this a normally closed contact and this a coil. And honestly, if I can keep you folks away from those three terms, I can almost always have you grasping PLC programming by 10 a.m. on Monday morning in my class. So, I mean, that is the difference. But if I have one person that just won't shake, call them a normally open, normally closed, I know it's going to be a rough week. And I know, I mean, really, they will put the class behind. Because here's the thing, is normally open and normally closed, those are electrical contact. We're not doing electricity here. This is PLC programming. Now, this language is called ladder logic, and I get it if we were talking the history of the PLC that it is based on relays, but it is not relays. This is not relay logic, folks. This is ladder logic programming. Not worrying. And it does make a difference, and this will make you grasp it faster. All right, but while we're here, let's talk through a couple things. First of all, let's talk about the scan cycle, because I kind of skipped over that, because I think once we get here and we get some stuff going on, we can start really talking about some items. So PLCs, they're going to, if we're in the Micro850, they're going to run each program and in order that they are over here. So we could have multiple programs and we'll learn about it maybe this video, if not next video. But what they're going to do is when it goes to run the program, it's going to run one, and it's going to start with the left instruction, and it's going to go look for a 1 or go look for a 0 or do whatever it's got to do, and it's going to go to the next instruction. If there are multiple instructions here, it would go through all of them, and then it's going to do whatever it does over here, and it's going to go to run 2, and it's going to do the same thing, and then it's going to go up, and it's going to do a little overhead. I'm just going to point up here because usually I'm pointing at my whiteboard now. And then it's going to repeat the process. And this is going to happen incredibly fast. And so if we actually go to our Micro850 variables, which you can get to by double-clicking on the global variables on the left pane, then we can actually find that down here. And so it's, there's its scan count. Oops. I don't know why my scroll bar all of a sudden was not working. But where is it at down here? Oh, there it is. So our maximum scan was 2 milliseconds. Now, this one is so insignificant right now that it's not even registered. You saw it just register 1 millisecond. We're below 1 millisecond with our scan time right now. So as this program grows, that scan will be greater. But for the most part, for this video, we can just call that incredibly fast. Okay, so that gets us through really our basic bit instructions. This is probably a good point to hit the pause button on this and really practice what we just did. These 3 instructions can seem really simple, but understanding them truly, not just saying, well, Tim said to go look for a 1, go look for a 0, but I think it's normally open, normally closed. I mean, really embracing those go look for 1s, go look for 0s, go write a 1, go write a 0 is the difference between almost grasping it enough to keep treading water, but never really getting it. After that, let's talk about timers and counters. And yeah, so we're starting connecting components workbench. One thing, I did just install version 22. The last video was in 23. I don't see any major differences, but there is a little bit of color difference, and there is one thing missing, kind of, but it's not even enough to talk about today. So we're just going to start with a new project. And I'm going to hit create. Actually, I should give it a name. So I'm just going to call this my counter and timer. And then we're going to add our PLC. And so under controllers, I'm going to go to Micro800. And I have an L50E. This is going to be a 2080 L50E 24QBB. And I'm going to hit the select and add to project. Very important. And I'm not going to do it just so we can have a reminder of this, but very important. The first thing you need to do, because this is one thing I don't like about connected components, is when you create a new project, it goes to obtain IP address automatic. You need to hit the configure button. And then if we were using our default PLC trainer, it would be 192.168.1.10. And it would have a subnet of 255.255.255.0. Now, I'm going to actually act like I didn't do that. Actually, let me go ahead and blank that completely out, because there's one, and I know I stressed it in the last live stream, but this gets me every time, so it's worth stressing again. I want to put it back like it was and act like I didn't know to do that. And next, we're going to create a program. So we're going to right-click Programs, Add, and we're going to be doing a ladder diagram. And then we'll double click on Prog 1 on the left side. And we're going to bring down a go look for 1 direct contact. And I am going to look at my green button. Now, one thing I did forget to mention is this is wired per our Getting Started guide. And down in the description, I forgot about the description. This seems to happen every time. Down in the description, you will find a link to our courses. Just go to the Connecting Components Workbench course, and you'll see the Wiring Enough to Get Started diagram. And also, there is a link to the PLC Professor's 3 books. And I highly recommend going ahead and clicking on those and purchasing his books. But in our case, input 4 is going to be our green button. So I'm going to put _IO. That gets me to my IO. This is our embedded module, so _EM, and then DI for digital input, and then number 4. And we need to go and put a description on that. Let's go ahead and put a description on all of those. So they'll be the exact same as the last live stream. So we're going to use the alias column. Input 4 will be the green button. 5 is the yellow button. 6 is the red button. 7 is the blue button, and 8 is switch 1. And that is our Wiring Enough to Get Started wiring. And then we'll go ahead and grab our outputs while we're at it. I want to go ahead and compliment one thing on version 33 that I never could figure out why they couldn't do in the original or the earlier connecting components. Notice they're in alphabetical order now. I never understood why the digital outputs were above the digital inputs, but every time I would put, in fact, probably every video you have of me, I go use an output 4 for the green button and the yellow button, and then we have to go back and correct it. So that is one nice thing. I'm sorry, I think it said 23. This is version 22. But yeah, it doesn't matter whichever version you're in. As long as you get the right ones, it'll work fine. So output 0 is going to be the green light.
Output 1 is going to be the yellow light. Output 2 is going to be the red light. And output 3 is going to be the blue light. And then we'll go back to our ladder diagram, and we're going to bring down an instruction block. And we'll double click on the instruction block, and we're just going to type the letter T, O, and N. That brings up our TON, which is probably the most common timer that you see in RS Logic 500 or Studio 5000. And so we're going to start with that one. And we're going to need a preset time. I'm going to be able to play with that probably. So I am going to go ahead and double click on the bottom section of this. That's going to bring up where we can create one. I'm going to call this our timer preset. And the data type of time is correct. And what I like to do, and it's funny, I just had this conversation with another manufacturer, not Allen Bradley, talking about how to do lessons, is what I'm showing you to do here is really how you can probably figure out, we'll say on a deeper level, how any instruction works. That, along with those books from the PLC professor, will really get you going. Is what I'm going to do is I'm going to bring another rung down, and we're going to put a go look for one, examine on. And notice, actually, I should have renamed this. I always forget to do this. Is right now the name of this tag is TON_1. That's a really bad name. And it created a local variable called TON the first time. And that's really scary because I just saw OBS reconnection successful. So hopefully that wasn't a big hiccup. If it was, throw in the chat that I need to back up. I didn't realize it until it told me that. Okay, but if we open this up, then we have an N, a PT, a Q, an ET, a P date, and a reg. And I really firmly feel that Connected Components Workbench does a better job at timers than Studio 5000 and RS Logix 500. And mainly because they get one or preset. We'll talk about it in a second. But I really have a hard time sometimes convincing users that there is no magic in the TON instruction that is tracking the time. It's all in these tags. And in Studio 5000, in fact, let me just check because I have this open because I wanted to show the counter in a little bit. But let's go ahead and right-click controller tags, new tag, and I'm just going to call this my first _ timer. And we'll make its data type timer. When we look in it, we have an accumulated, done, EN, preset, and a TT. And everybody's always kind of like, yeah, I guess the TON magically times it. But I have an older video where I show there's actually an extra word of data in here. Or actually, it's part of, you see you have 3 booleans. Well, there is, it is actually a double integer, and there's, 29 out of the bits, and that's how it's tracking the time. And I think really, Connected Components did us a real justice by letting us see how they're tracking the time. I think that I've found that people grasp this a lot quicker. But okay, that was enough of a rabbit trail on that. Let's get back over here. What I want to do is I want to bring all this info down so we can kind of see how it works on the lights. It kind of lets you kind of get, the hands-on piece of this instead of being all in the PC. So I'm going to type first _ timer. And then, we are going to hit period. That brings up all the options, and we have a Q. So I'm going to select the Q, and we're going to put an output energized, direct contact, and we're going to put this to the green light. Now, since I put descriptions in, I can just type green, and there's my green light. Okay, now, first question that I really blew over last time is I'm going to copy this, and I'm actually just going to paste it back in place. Is I blew over that there is also a Q parentheses Q parentheses. I don't know why this is here, but if you select it, and you see it looks like it's selected, once you actually click off of it, it goes to first timer Q. So I don't know why there are 2 of them there, but now you know there are 2 of them there. And so the other bit is the reg, and it's going to do the same thing. If I select the reg, I get the first timer reg. If I select the first timer reg without an E and in parentheses reg with an E, it takes me back to that. And we're going to put that on our yellow light. And we also had our elapsed time here. And just so we can see that we could do something different, let's bring another new rump down. And let's bring an instruction block down and double click on it. And we're going to use a greater than. Now, this is one thing, if you're used to RS Logic's 500 or Studio 5000, this is a little bit of a struggle. It's even a bigger struggle if we could talk about 36 and 5000, but I really struggle with shapes and symbols. And so if you're like me, this really is hard to understand what this is. You have a theme button up here. And so just so we see what the theme does, we're going to hit the drop down and select logics. And just pay attention to this this greater than, or this Pac-Man symbol to the left when I hit this. That switches us over. We go right back here, and now it says a GRT. So the logics puts these instructions into what we've been used to seeing in RS Logic's 500 and Studio 5000. I've been working really hard trying to get used to this style, which is the IEC 61131 standard. And so I am going to stick with it just to work on my practicing of that also. And now we're going to bring a direct contact down. And so for I1 of our greater than, I'm going to go and get the first timer dot ET. And then for the less than, I'm going to put in a value of 5. Just so we can see we don't actually have to put tags. We could just put a number here. And we're going to make that turn on our red light. So this is going to be the start, our first timer. So we're going to go ahead and download this. And let me go ahead and clear out my path. So it'll be oops, nope, it's already clear. That's right. This is a new program. And so right here is the download button. And I'm going to click it. Unable to get to, oh, well, there you go. We'll learn about the build button too. Expecting time data to, oh yes, okay. Now this, I just told you that I really like the timers in here, but here's an old habit. I put 5 in, which really, that would have been horrible in any, on any planet. Because 5 would be 5 milliseconds in Studio 5000, and it would depend on the particular RS Logic's 500, but it would not be 5 seconds. This, if we were in Studio 5000, would have needed to be 5,000 per 5,000 milliseconds. But that doesn't work in Studio 5000, I mean, in our Connected Components workbench, and this is probably my favorite thing about Connected Components. I think this is something I wish they would bring over to Studio 5000, is to put a timer in, or a timer value. I'm going to put T, number sign, and then if I want a 5-second timer, I put 5S in. That is 5 seconds. Now, if I want 5,000 milliseconds, I'm going to put 5,000, and I put MS. And when I hit the enter key, notice it takes it and makes it 5,000 milliseconds. Or I can put in, oops, actually, that doesn't feel right. We hit the build button on that. All right, go on. Is it milliseconds I can do? Let's make sure it does not have an issue. All right, build succeed. Yes, you can put milliseconds. But if I want a 1-minute timer, instead of putting 60 seconds or 60,000 milliseconds, I can put 1M, and that's going to be a 1-minute time. Or if I want an hour, there's 1 hour of a timer. And in this case, I did just want 5 seconds. So we're going to put 5 seconds in, and that should get us going. Now with the download button. And remember, I still have this error, but I want to still walk through this. Hopefully I don't accidentally hit the wrong button sitting here talking to you. I'm going to try to pay attention because this bites me so many times, but we'll get to use my IP Explorer if I mess this up. Now, if you're using our trainer, the IP address is going to be 192.168.110. I'm actually running on this trainer right now, 44. And I'm going to download, and obviously typically you download with project values. I probably should do a separate video sometime on what exactly that means. And okay, we are so used to the next prompt that, and I do it probably half the time, is usually this is asking, do you want to put the controller back in run mode? And I click yes. But this is not doing that. This is downloading with Ethernet settings will result in disconnection for controller. Do you want to continue? If you click yes to this, you will lose connection to this controller. And since I left it at the default of DHCP, you're going to need a way to assign an IP address to it. So I'm going to click no just so we can see how we can get out of this if we do this wrong. So what that did is that downloaded the program except this IP address right here. Now we get the default prompt of download is complete, change back to run mode. And that's the one it's in the same spot. I get it has different words, but I don't read the words. We usually end up messing that up. All right. And then let me show you how to fix that if you accidentally did that though. Now what I'm going to do is I'm going to go back to this Micro850 tab. And we have a button here, update from controller. And I click the update button, and that switches it to reading the configure from IP and doing that. So it'll be fixed for next time. But let's talk about how this works now. So one, I need to put a preset on here. Remind me, I probably will forget, because here's another thing we need to learn, is when we go offline, we're going to lose this preset. And if somebody will throw it in the chat about the time I'm going offline to talk about the TOF, that, hey, we need to talk about this preset. But all right, now I have a preset of 10, elapsed time of 0, and we have a green button, and we should have a green light and a yellow light and a red light. And I like doing it this way. That way, one, you can kind of hit a button, you can kind of see exactly what's going on. But I'm going to press the green button, and immediately we see our elapsed time starting to go up. And we saw there that just passed on, and that was really fast. Well, I will have to do this again. I probably should have done this for 20 seconds. But all right, one thing about version 23, 22, I don't know why I keep saying 23, that I really, really like is, and I wish they would pare it down a little more, is there was so many different colors. In fact, do I still have? Yeah, here we go. Because I was looking for something. This is actually, you notice we're going through almost the same thing that we were then. What is true? What is false? We have blue over here. We have red over here. We have so many colors that I really struggled with this. And I get you can change any color, but I try to leave everything at the default that you'll see when you get your software going. And so I do believe this is slightly better. I kind of would still love to see them make this a little grayer or, something. But now we press the green button. Let's just pay attention to this blue line as immediately this goes to green. Green means that it is true. And after 10 seconds, we'll see this line go green. So I do believe that's a little nice touch. If they could get rid of like every bit of the rest of the color, that I think they would be really starting to get somewhere with this. But all right, let's talk about the Q bit next. So I press the green button, and the Q bit is a 0. And when it gets to 10 seconds, you will see the Q bit go to a 1. So on a TON, the Q means that the instructions preceding the TON are true, and the elapsed time, or ET, is greater than or equal to the preset. And we have a green light on. Now light off of it, green light goes out. Next, we have the reg, and the reg is a 0 when the instructions preceding the TON are false. I press the green button, and the reg immediately goes to a 1. And after 10 seconds, it will stay a 1. So reg means simply that the instructions preceding the TON are true. And somebody did ask, well, what does reg stand for? And actually, if you double click on reg, then they do have some default comments out here. And on some of them, they're good, some of them, they're bad. But this is a rising edge, although I'm not sure I really agree with being described as a rising edge because it's not rising now. But anyway, this means the instructions preceding are true. And in Studio 5000, we would have called this the EN bit. Also, I forgot to say that the Q bit is what we would have called the done bit in both Studio 5000 and RS Logix 500. Next, we have a greater than, and I mainly like to throw this one in there so we realize that we can do stuff besides just looking at Qs and regs. So I let off the green button. That takes our TON to false, which I like to talk about because even in my class, I ask people all the time, so what does that mean a false TON does? And I will say that 9 times out of 10, they always say nothing. And 0 is such a powerful number. If I could say Curiosity's out there, he's probably like, yeah, I remember all the stress of 0. But yeah, a false TON will write a 0 to everything, but it's preset value. And so when I let off the button, that set the elapsed time to 0. 0 is not greater than 5 seconds, so it will be false and our red light is out. I press and hold my green button, and my time starts going up. And as soon as you see this pass 5S, then the red light comes on. So now let's talk about the TOF, because it's the other half of let's talk about one more thing. Because there is one thing missing compared to Studio 5000. In Studio 5000, we also have a TT, or a timer timing bit. Now, while we don't have that in Connected Components Workbench, we can make, so I'm going to disconnect. And yes, I'm going to take care, actually, I'm not going to do the preset this time. And next time I will. That way you can see, I want you to see why I'm going to do what I'm going to do. Is we're going to disconnect. And we're going to bring another neuron down. And yeah, the timer timing is not in Connected Components Workbench, but we do actually have it. Because in Studio 5000, the timer timing is true whenever the first timer is enabled and the preset is less than the and the accumulated value is less than the preset.
Yeah.
It is not done. And that's what we're going to do. So we are going to bring down, go look for a 1, examine on, and we're going to look at this first timer Q bit. So go find your first timer and the Q, and then we'll go look for a 0, reverse contact, and we'll go find the first timer. And this time, I got this backwards. This is the .Q, because that's the done bit. This is the reg, which is the enable. And just so we can see what will happen, we'll bring down, and we'll use the blue light for this one. And okay, now pay attention to the preset. I had it at 10 seconds. When I went offline, though, it's gone back to the default value. So when I hit the download button here, I'm going to download with project values. Actually, this will be good. Now, let's stay on task. I have a hard time staying on task. Sometimes also I'm like, oh, well, yeah, you guys should learn about this too. But yes, stick with it here is, now we'll put it back and run. And notice our preset went back to 0. So next time I'll show you how you can fix that. But for this time, I'm just going to double click on it. And I am going to change its value back to 10 seconds. And all right, so really the blue light will be on whenever you see this elapsed value going up. So I'm going to press the green button. And immediately the blue light does come on. And after 10 seconds, you'll see the blue light go out. So there's how you can get your timer timing if you need it. Okay, let's disconnect from this. And first, let's talk about, let me reconnect. And let's talk a little, because I'm online over here. So in Studio 5000, if I hit the save button, I get this prompt here. Online values may have changed since last upload. To ensure current values that are saved, you should upload them. And it asks you if you want to do it. And we hit yes to this. That uploaded all those values. And now in here, if I hit the save button, it doesn't do anything. It's still just saving the structure. It's not saving these values. And I really feel there just should be a upload tag value or variable value in here. but there isn't that I know of. So what I know to do is I'm going to disconnect, and then I right-click the Micro850 and I upload. It asks me, do you want to upload with logical values? I click upload with logical values. And this is actually uploading the entire program, which is still, if it's a very involved program, I mean, that can be time consuming. That's one thing I just feel there should be an easier way to do that nobody's been able to show me yet. But now, if we go offline and we go and look at that timer preset, that has the project value of 10 seconds over here. So now what we want to do, we're going to change this to a TOF time. And to do that, we're just going to double click on it. And we want the timer off delay. So I'm going to select it. But I want it to be the same thing it was before. So I'm going to type first underscore, whoops, that was terrible, timer. What do I, oh, it's not going to let me do that. Okay, well, first timer wasn't a great word anyway. So we're going to call this our TOF timer. And we'll still use the same timer preset. And now we need our TOF timer. And we want the dot Q again. And then in this case, it'll be the TOF dot. And last time it was the reds. Now we have the feds. Now, same thing. If I select feds without an E and in parentheses spelled correctly, it comes up with feds. I really don't know why there are two copies of that there. Maybe somebody can tell me one day. But all right, we're going to do mainly that right there. And actually, we're going to grab these. Actually, let's leave the TT alone on this one. That way we can just talk about it. All right. And that should be it. So we're going to download this program. And yeah, let's watch the timer preset when we download this time. Well, depends on how many times I get an error come up. What did I do? Oh, yeah. Got to change that one too. TOF. And we want the elapsed time. Go ahead and download that. And I don't even know if I brought it up, but you notice last time we did not get the prompt about the Ethernet address because it was in there now. And we just get prompt to go back to run mode. Now we have a timer preset of 10 seconds that got downloaded with it. And that's mainly because of, whoops. So I don't know why it doesn't show up when you're online. But yeah, it's that column right there. If you go offline, it'll show it to you. But yeah, since we had a physical value that we uploaded, it'll put it in there now. And all right, let's talk about the TOF then. So I press the green button and my timer does not time. I let off of it and then it starts timing. So a TOF timer will time when it is false. Now, one myth that a lot of people have about both Studio 5000, RS Logix 500, and Connecting Components Workbench is they think that these time down. The timer is still going to time up. It's mainly it times when it's false instead of when it's true. All right, then we have the Q bit. So I'm going to press and hold the green button. And notice my Q bit is true. And it'll stay true as long as the instructions preceding the TOF are true. I let off of it, and it stays true as long as this is timing. And when it gets to 10 seconds, the Q bit goes out and the green light goes off. So this is still the enable bit. I'm sorry, this is the done bit in Studio 5000 and RS Logix 500. So then we have the feds bit. And so I press and hold, and immediately it goes to a 1. I let off of the green button and immediately goes to a 0. So this is the EN inside of the this is the EN, or simply means the instructions preceding the TOF are false. Now the TT would be when the instructions pursued. Let's make we go through that one time so we can talk about why. Okay, so right now the fedge is false. The fedge is a 1. So the timer, it's going to start timing when the fetch is a 0 and the Cupid is a 1, that one is a little bit different. And actually, we have to spend a lot of time, usually in our class weeks, kind of talking about that. Because, the timer timing and the done do work different in the TOF and the TOM. But, I will say that you'll probably see 99 TONs for every TOF you see. So these always are kind of stumbling blocks when you run into them in programs, but they're good to practice on. All right, we're going to do one more of the timers. We're going to go ahead and disconnect again. And we're going to double click on it. And we are going to get the RTO timer because that's the other big one that you'll see used. And I would love it if it would just let me come back to first timer, I still got to change everything else. So now we're just going to make this our RTO timer. And your programs, please make your descriptions better than that. Make it whatever it's timing here. All right, we are going to use the timer okay, first of all, this has a built-in reset. I almost forgot about that. So we have to reset this externally. So we're going to bring a new rung down. I'm going to bring it right down that RTO. Actually, no, I don't even need to do that. Let's do it, Yeah, I should. Let me just talk through it. So notice in our timer over here, there is no reset. So in Studio 5000, you actually would have a separate reset instruction here. And we do have it in Connected Components Workbench, but if I was to bring down an RTO instruction in this, there is no reset. So a real nice feature is they have the reset built right in here. So I'm going to use the yellow button to reset this. So I'm just going to type yellow, and there's our yellow button. So then our preset time, that is our timer preset. And now we need to go through and fix these. So this was the queue. It's going to stay the queue. In fact, let's look and see what we have. So RTO, timer, dot. And so we have a queue, we have an iFetch, and an iReg. And we're going to put them all in. So there's the queue, RTO, dot, iReg. And I think you'll probably you can put this on something else. I'm just going to reuse this one there. Yeah, we're just going to reuse this one. Just delete that out because it's going to work exactly the same as it's worked on the last two. And we'll go get the RTO dot iReg. And we'll go ahead and download this. All right, and since we did that with the project values, there you go. We have our 10 seconds still in. And this time, I don't want you to press and hold the green button. I just want you to press and release the green button. And notice our timer went up to 453 milliseconds. Now, the cool part about the RTO timer is when I press the green button again, I'm just going to press it for approximately the same amount. It picks where it last timed and continues timing. Now, I really don't like that they call this a retentive timer on because all data in this PLC is retentive, but mainly it has to do with what does it do when it's false. And this is why I stress this so much on the TON. When a TON is false, it's going to write a 0 to everything but the preset. When an RTO is false, it does nothing. And if nothing writes to something, it'll stay where it was. So I press the green button, line off of it, and press it again, light off of it. Now, notice the iReg is happening down here. So this is your timer enabled. And then the Q button, the Q, I'm at 8.5 seconds. I press and hold it for a second and a half, and the Q will go to a 1, and my green light turns on. Also notice now the fetch is turning on and off. And it seems like this is the one that someone asked about, and I was like, I really don't know. So let's double click on the queue. And let's look over. Actually, I double clicked on the queue, but I actually wanted the iReg and iFetch. So these bottom ones here, I believe is this the one that, no, okay, this one does have a description. What didn't it? And I was like, I really don't know for sure. In rising edge, in falling edge, but that's not what it does. That's where I'm not really sure. But okay, there's actually more words here. Let's see what all these other words are. Oh, they got a lot more words. Bring it on over. Probably should have just opened up the variables at this point. Okay, so we're on this one. True when n is a 1, and that is the reg. And so this is the one I know. The reg is the one that is the enable. Now the fetch, though, true when the en is a 0, false when it's 1. But is that right? So right now I'd agree with it. Maybe it is. And yeah, I think somebody asked why or something. I was like, I really don't know. But okay, the last thing is we have a reset, and it is on the yellow button. So I press the yellow button. That goes back to a 0. And let me look at it again. Yeah, I guess that is it. I guess, somebody was asking, well, why do they have these if they just alternate? I don't know why. But the iReg is the enable in Studio 5000 and RS Logic 5000. And same deal. If you're enabled, actually in the RTO, if you're enabled and the Q bit is a 0, that is your TT. And yeah, there is no iReg in Studio 5000 or RS Logic 500, so don't worry about that one, I guess, if you're trying to do a conversion. All right, so really, those are the timers. There are a couple more, but these are the ones that you'll most commonly see. And I want to get on to the counters before we all get tired, because the counters, there is, I don't want to call it an issue, but there is a major difference we need to understand. And so we're really quickly going to do the count up and count down counters. And then we're going to mainly work on the C. Or actually, something, let's try to combine. No, let's do them one at a time. So let's go offline. And in this case, we'll just go ahead and we'll continue our door. We're going to double click on the RTO. And I want you to type CTU. That's going to bring our count up counter up. We're going to change it to that. All right, now it has a reset also, which coincidentally we already had it at the yellow button, so we're going to leave it at the yellow button. All right, now we have a counter preset we need now. So I'm going to type counter preset, and it needs to be a double integer instead of a time value, so it's good. And then let's go find this one's value. So we're going to go find the CTU 01 dot. And we got a serval here we need to look at. We got a Q. We're going to go ahead and use the Q again. And again, I don't know why there's a Q and a Q parentheses, Q parentheses. If you select this one, it takes you right back to the other one. And then the CTU dot, we want the CU. And, just so we can say we did it, let's go ahead and let's delete this back out. And let's bring another instruction block down. And we're going to put that greater than back in. And if our CTU dot CV is greater than 2, let's turn on the red light. Okay, go ahead and download this. I will download our project values. We have a count up, count down. We're going to make our preset at 5. And all right, first of all, we see we have a green button, which goes to the CU. And notice we have a PCU down here. So I press and hold the green button. I got one count here. And also, I have a CU bit. Now, I love highlighting things like the CU bit because, again, a lot of people think the CTU is magical. But this thing is scanning pretty fast. I don't know what its scan time is. I'm not going to go look at it right now. But it's in the millisecond, if not microsecond range. So when this became true, it counted up by 1. Now, it's going to come around, 5 milliseconds later. It's got to remember that it already counted. And that's what the CU does, is it writes a 1 to the CU. That way it knows, hey, I don't need to count you again. So I let off of it. CU goes to a 0. I press it again. We get a 2 here. CU goes up again. And right now I have a great, oops. I don't know if a not equal to here. Oopsies. That's all right. Well, we get to see how a not equal to works. Is right now, 2 is not equal to 2, or it is equal to 2. So this is false. I press it again. That gives us a 3 and our red light comes on. So there you go. Just learned about a new instruction. 4, 5. And here is where it gets different than Studio 5000. In fact, talking about Timothy Gates' books, this is one thing I love about his books. Is yes, if you happen to have a book, I'm on page 200. He has a lot of views, or Well, yeah, this is really great. But he has a lot of good notes for RS Logix users. And mainly down there, he says with the Micro800 controller, you have a CTU, a CTD, and a CTUD instruction. If you want to increment and decrement a value, use the CTUD, lights timer. And then he goes on to say, CTD instruction, it counts down from the preset like a preset of 0 will not yield anything because there's nothing to count down from. And he goes on to talk about that. Where is it exactly? Because I know he says it. I probably highlighted this. I should highlight this. See, there's only one counter down a type. When you execute the 3 instructions, not an up, not a down. Now, the false to true transition of the CTU and increments the accumulated value after it equals the preset. It doesn't work that way in connect components. So when I press this button here, it's not counting up anymore. And this is a big difference from Studio 5000. That's why I have this open over here. Let's go ahead and look at it in Studio so we see the difference. So I'm going to, I don't have any, I do have wires on it, but this is one of our stations the technicians use, and it's about 40 feet away. So I'm going to right-click the green button, and we have toggle bit down here. What this is going to do is it's going to put in this 1 in this box that is have arbitrarily there. And we get a count up of 1, and we right-click, toggle bit off, right-click again, and we can toggle on. We get a count of 2. Now, when I do that, notice we have a Control T, and I'm going to use Control T the rest of it, just so I can do it a little smoother. It is now on, gives me 3, off, on gives me 4, off, on gives me 5, off. Now, if I hit it again, it keeps counting on, up. And that does not work that way in connected components workbench. Now, beyond that, the Q means that the elapsed time or the count value is greater than or equal to the preset. We already talked about the CU bit. And then also, besides my oops there, we can see we can look at values and compare. All right, really quickly, let's do the CTD and the CTUD, because I think y'all probably get the part about the counters, but then we're going to talk about how we can, or one option for fixing it. So I'm going to just double click here. We're going to change this to a CTD instruction, and that means we'll change this to a CTD instruction. Oops. That's what I get for trying to shortcut. Well, that's just terrible. CTD instruction, and we'll change you to a CTD instruction. Okay, well, there you go. I'm trying to shortcut. There is no CU bit. We're going to have a CD bit. And then we want the CTD. All right, I think I got it. So we're going to hit the download button. See, while we're downloading that, Michael Spillman, I'm just beginning my mechatronics degree. You're a great teacher, Tim. I'm so excited to find your channel a few months ago. Well, I am glad you did, and I'm glad you liked and subscribed this. Everybody else, have you already liked and subscribed? I almost never shout that out. I probably should more often, but, we put out 2 videos a week. And right now we're rolling through a very comprehensive series on executing an automation project from concept to reality. I mean, from building the mechanical frame to building the control panel, selecting components. And I've made it real life. Like the startup did not go great. So I actually recorded a lot of the mistakes I made in the startup. And so a lot of good information there. I hope you all like it. All right. But yeah, so we have a CTD. And actually, this is the sentence I was reading. So I was like, that isn't what I read earlier. But okay. If we press the green button, notice nothing happened. Besides, obviously, you saw it go true, but we didn't get a count down or anything. You need a counter preset value here. And I'm going to make it 5 again. And then in this case, I'm going to use the reset button to load that value in to my CV. And now if I press the green button, it's going to count down. I press it again. It's going to count down. Press it again. It's going to count down. Press it one more time. Whoops. Can't count. We're going to press it one more time. That gets us 0. Now, watch, I'm pressing it again. We get a 1 on the CD, but we do not count down. And this is different than Studio 5000. So over here, if I press my yellow button, it goes down. Yellow button again goes down. I'm pressing a bunch of times because I had it way up there. And mainly we're at 2, 1, 0, and it will count negative. And so in Studio 5000, a counter will count all the way to its positive, maximum positive number, which is in the 2 billionth range, and it will count negative to the maximum negative number. And that does not hold true in the... All right, so now let's talk about the CTUD, because it is kind of a convenient counter. Is if we disconnect here, we double click, and we're going to get the CTUD. And in this case, we have a green button. That's going to be our count up. I'm going to use the yellow button this time for the count down, which means I'm going to use my red button, kind of reset. And we're going to use a blue button for this load. And then we have a preset value, and that will be our counter preset. And then we have Cernival on this one to work with. So let's go ahead and find our CTUD. And first, we're going to grab our CU bit just so we can look at it. And then we'll grab our CTUD. And let's grab our CD bit, because this is a combination of the count up and count down. But let's go ahead and have a look at it. I think we see that this will work the same, so I'm going to reuse this one. Spring will go look for a 1 down. And go back into the CTUD one. And let's grab, we have a QU, and then let's right-click that rung and copy, and right-click that rung and paste. And let's grab the QD, and same thing, I can't explain to you why there is these extra copies of it, but yeah, all I can tell you is when you select it, it goes back to what it was. All right, that gives us enough, I think, to see what we need to see, so we're going to go ahead and download this. And right now, our QU is a 0, our QD is a 1. And if I press the green button, my count goes up. Also, notice my QD went to a 0. I press my green button again. It counts up again. I'm going to press and hold it this time so we see that is the CU bit. That's all it remembers it counted. We press and hold it again. That gives us 4. We press it one more time. That gives us 5. And when we do that, we get the QU bit. The QU bit means that your count value is equal to your preset value. And if we press the green button again, we see that our CU is true, but we do not get an additional count. It only counts up to its preset value, and then it stops. I press my yellow button, it goes down. And immediately my QU goes back to a 0. And I'm going to press it down to 1. And our QD is still a 0. And I press it one more time. The QD goes to a 1. And the QD means that your count value equals 0. Now I press it one more time and I get nothing. And so this is a huge issue. Is what a lot of people are telling me. They're trying to convert their Studio 5000 or their Micrologix programs, and this isn't working. And so what we're going to do, and I hope this works, and here's where, sometimes you guys are going to have to level graces. I've never actually done this before. So we are going to attempt to make a count up down counter. And I'm going to make it a count up down counter just so we have one package together, because I feel that's missing from Studio 5000. Let me take them out. It's missing from their ladder logic. And we're going to try to integrate it really nicely. Make a user-defined function block. User-defined function block, a new structure, and go through some things. We're going to do it slowly so that we can understand why we're doing the things we're doing. And let's see how this goes. So what we're going to do is let's go ahead and go offline. And it's going to be easier to start fresh. So let's just right click. Oops, can't select all there. Okay, well, let's just hit the delete key until we have nothing in there. And we're going to go ahead and bring down a go look for a 1. And we're going to put the green button back here. And what we're going to do is we're going to add to a count value instead of using the counter. So we're going to double click here. And we're going to go for the plus sign. Now, if you're in Studio 5000 and you're really not familiar with them, we switch over to Logix View. Here's another good example. That's the add instruction. I'm really working hard trying to get used to using the default view, kind of going back to what Logan was saying there. So I am going to stick over here for this. And so what I'm going to do is I am going to make a tag called counter ACC. Whoops. Now counter ACC. And I'm going to make it a data type of a double integer, a DINT, which is actually the count. It's actually the accumulated data type of a counter. And just so we can see that, let's double click here. Oops. Oh, and I deleted that out. I should have shown that before I did. Let's go ahead and put a counter in there so we see it. I'm just going to put real counter. And we're going to make it a data type of, CTQ, just so we can see. We hit our arrow by there you go. I'm old school. I'm using the A. Well, no, I'm going to do that because this is about how to replace a Studio 5000 counter, but they called it the CV, and Studio was the ACC, but it's a double integer. That's where I got that value from. So we're going to take the counter ACC and I'm going to add 1 to it. And I'm just going to copy this counter ACC and put it right here. Okay, now, everybody, I know some of you getting ready to throw in the chat, hey, Tim, that's not going to work. I know it's not going to work. I just want us to see a couple things. I want us to understand why we're doing the things we're going to do. I'm going to go ahead and bring another new rung down because we also want to be able to count down. And I am going to use the yellow button. And we are going to put a subtract instruction in. And we're going to use this same count ACC. I'm just going to copy it. And we're going to paste there. We're going to paste there. And every time we are going to subtract by 1. And a lot of you get to this stuff right here. And you're like, I don't know why my stuff isn't working well. So let's go ahead and put this in so we can talk about what's happening. There, and we wanted a nice counter, and I pressed the green button, and immediately I ended up with nearly 20,000 counts. And the issue is this PLC is, in fact, we should look at that scan time. Let me see if by some miracle I can find it really fast. If anybody knows it, throw it in the chat. I know I usually scroll and find it, but it ought to, honestly, it ought to be somewhere. Isn't it this one? They call it the cycle time. All right, there you go. So we're sub-millisecond on this cycle time, and I think I could actually change this format somewhere and figure it out. But every millisecond, this program was looking for one at the green button. So as long as I held it, this was true, and it kept adding more to it. Now, there are 2 ways we can fix this, and let's go and do it both ways. So let's go ahead and disconnect, because what we want to do is make it where this is only true 1 time each time we do something. So first of all, we have a different instruction to do this, and we also could do it with some simple logic. So this top one, I'm going to use some simple logic. Is what I can do is I can add an output energize, and I'm going to name this my counter. Counter. Now you got to figure out, I got to sound out all my spelling. CU. And we'll create that. Okay. And then we're going to make this a branch here. And I should have done it to start with, but yep, now we'll drag that into the lower branch. And so now this will be true the first time. Well, we only want it to count when this is a 0. So if I go look for a 0 reverse contact here, and I find my counter CU, that's going to make this true one time. Okay, another way you can do it is what in Studio 5000 we would call a one-shot, but it works a little differently in connecting components. This is another one of those instructions that is a little different. In fact, let me just pull up our student guide because that's probably the fastest way for me to get there. And we go down to page 10. So we look in Studio 5000, rung 10 here. This is how you would do a one-shot in it and in RS Logix 5000 is you would have your go look for a 1 for whatever it is, and then you would have just a storage bit, just a bit for it to remember with, and that would make this execute one time. In connected components, we actually have a built-in instruction where it can look at a bit and only let it through one time. And it needs a P in the middle of this to do that. So if I go over to my properties while I have this highlighted, we have a modifier here. And you hit the drop down. There's the direct contact. This is a reverse contact, or go look for a 0. And we want a pulse rising edge contact. Now, another way to do it, I wish I could shout out the person who taught me this, but I can't think of their name right now, is while you have it highlighted, if you hit the space bar, that actually cycles through the different things. So we want this P instruction. Now, if you're coming from Studio 5000, you're probably like, I've never seen a P in front of it in the middle of that go look for one in my life. We switch over to Logix view and go back in. This is the ONS instruction. Now, this ONS does not work the same, though, as you'd have to have a separate storage bit in it. It's all built into this thing. So just be aware that this is kind of how it would look there. Stick in the default view. And so if I've done this right, these should do the exact same thing. So I'm going to hit the download button. And now, if I press and hold my green button, oops, got ahead of myself. Gotta wait for the little thing to quit spinning. Close you back out of the way. And now if I press and hold my green button, it counts one time. I let off of it, then I press it again, it counts one time. And similarly on rung 2, if I press and hold my yellow button, it subtracts one time. And I let off of it, it subtracts again. Now the advantage of this is now I press it again, I can count into the negative. And there is no preset, so this thing will count until we get to 2,147,483,647, if you want to know the exact number. So next we need a done bit. Because really in our other one we had a done bit. So yeah, let's go ahead and go back offline. And let's go and bring a new rung down. And whoops. Oh man, now I'm doing it. And bring down an instruction block. And the done bit is if the accumulated value is greater than or equal to the preset. Well, here is your greater than or equal to compare instruction. And so we want to compare whether this count.acc is greater than or equal to a counter preset. Counter P-R-E. Oops. Didn't want to, I want to stick with the Studio 5000. I could use this one, but just so we're I can get it in there. There we go. R-E. There we go. It is just new Congo. It is not letting me cooperate. There we go. We're just going to change that one. There we go. counter, RE. There we go. Just so it's the same. RE is the right data type. And then we'll put an output energize on counter DN. And that is a Boolean tag. And the one other thing we would need to do is reset our counter. So we are going to use the yellow button. I'm sorry, I'm already using the yellow button. We're going to use the red button. And we don't have a reset for this, but we can move a 0 to it. It'll be the exact same thing. So we'll just bring down an instruction block and bring an MOV in. And we are going to move a value of 0, because we can just put numbers there, to our counter.acc. And let's go ahead and download this. Okay. Okay. And so now, the main ones we're going to focus on is rung 3, because that would be our done. It says our done is true right now. And that is because our preset is 0. So let's put our preset back at 5. And that makes our done a 0 because our cumulative value is not greater than or equal to our preset. I press my green button. That counts up. I press it again. Counts up again. Bring it up to 4. And our done is a 0. I press it one more time. Our done is a 1. And now I can press it again. And it can count above the done. And we can use our yellow button. And we can still count into the negative. And then our red button now is our reset. And I press my red button. That takes our count value back to 0. Because really the counter preset writes a 0 to everything. But the counter reset writes a 0 to everything but the preset. All right, the next real problem with doing what I'm doing here is, I got an ACC here. I got a preset here. And if we look at our variables, they're just all stuck out here. Whereas in the real counter, everything was nice and tidy. We had a CU, a reset, a PV. It's all, we got one thing here. So this is going to be scattered all over the place. And to resolve this, we're going to make a custom structure right here. Now, honestly, as I'm sitting here thinking about this, I really think I could probably take a CTUD and do this. But, one, I wanted just to learn about a structure. And also, if you're coming from Studio 5000, you want to right click and you want to monitor this and open your arrow. And this is the structure that you're hoping to see. And so, yeah, we want to put this exact structure in. Oops, got the button checked. There you go. There's the structure that you feel that you should have right now. So I want to put it just like this. So let's go ahead and double click on our structure. And we'll go ahead and go to the bottom. I'm sorry, I said structure. Oh, no, I am structural. Oh, I'm online. Got to go back offline. And now if I open up structures, I'm going to make a Studio 5000 count. I'll just call it, Studio 5000 count. Too long. Probably shouldn't be that long, but okay. So by that, we're going to have an arrow beside of it. And so now we just want to put them in the order we want them here. So we have a pre, an ACC, CU, CD, DN, OV, and a UN. So I'm going to type PRE, ACC, CU, CD, DN. So what's next? I can't remember. Yeah, DN, OV, and UN. DN, OV, UN. And the preset and the accumulated value, we look over here, they're going to both be double integers. Everything else will be Boolean. So I now can make this a dent. And I can make this a dent. And now, if I go to my local variables, I can make a tag and call it. Actually, let's take that in order. Oh no, let's do whatever. Where are we doing this? No, this is good. So I'm going to call this I hate to call it homemade counter. We're going to call it our studio counter. And its data type will be a Studio 5000 counter. And now if we open it up, we have the exact same structure that we're used to over in Studio 5000 and also in RS Logix 500. It'd be the same structure. Now, one thing I didn't talk about is the OV and UN. I have videos on that, but mainly the OV means that you counted to the maximum positive number and it rolled over. And when it does, it actually is the maximum negative number. The UN's the opposite. You counted down to the maximum negative number and it went up to the maximum positive number. But all right, that gets us into a structure. Now, let's go ahead and take our time. We're going to clean up what we have here. We still got one more step to go, but let's clean this up now. So now this can be my Studio 5000 count, or Studio Counter.cu. This is my Studio Counter.cd. Now, I didn't actually use this method down here. We're going to use this now. So let's go ahead and bring us a branch down. And we'll put an output energize in. And, oops, I just did that wrong anyway. That's the CU. And here we'll put the Studio Counter.cd. And in front of it, we're going to put a go look for one examine on the Studio 5000 Counter.cd. And that gets that the exact same as the other one. We're going to take this pulse back off. But all right, so we have CU. So now we have the Studio 5000 Counter.acc. And so we'll copy that. And we'll paste there. And we'll paste there. We'll paste there. And actually, it's down here too. So we're going to paste there. And in our reset. So that gets that. Now, notice we're getting this truncation going on. I'm going to fix that for you in just a second. We're going to go ahead and get the PRE. Let's see, what else did I need? Oh, and the done. Yeah, I think I covered it all. If not, we'll find out in a second. But all right, notice on these, this has gotten truncated. This is probably my pet peeve about connected components is it doesn't auto resize these columns. And so you're left with it. And unfortunately, because it's not intuitive, I see all types of insane short words for this instead of actually naming it something descriptive because people are like, well, I got to be able to read it. And so what we want to do is we want to right-click this white area over to the right of our ladder and go to properties right here. There's other ways to get there, but this seems to be the most consistent way. And we have a cell height and a cell width. And so if I change the cell width to 35, notice it widens every single cell up. I wish there was an auto size on every one, but there's not. But now we can read Studio Counter everywhere. So if you're having that trouble, just widen those out. Or maybe somebody will teach me how to do an auto resize one day. Okay. But that should do it. So let's go and download this and see how it works. And let's see. Well, let's download it. What does Logan say? See, should it show up like that if you're creating a function block? Like create a block, declare a block, then your variable will show up like you want. Well, and that's what I was saying. I think probably I could fudge that, but really this piece right here is for the people that are coming from RS Logix 500. or Studio 5000, and they're really looking for that ACC, that PRE. They're looking for that type of nomenclature. So really, I'm just kind of rolling, how do we make this probably should have been on its own live stream. This is kind of, how do you make a Studio 5000 counter in Connected Components Workbench? All right, but we are in, and we're going to go ahead and change our preset because I didn't think to actually make it a preset initially. Put it at 5. Oh, but look at there, right away. In fact, let's just roll this right in this. Here's my CU bit, and it's to the green. I press my green button, I get a checkbox in the CU, and my ACC goes to 1. I let off of it, goes back to a 0. I press it again, it goes to a 2. I press my yellow button, which is the CD. You go, oh. Well, we have a learning opportunity, folks. That did not work the way it was supposed to. Did you not? Oops. I have a go look for a 1 here. That should be a go look for a 0. All right, now, I haven't done let's go ahead, because I haven't tested this yet. I hear that the run mode change is maybe slightly better in this one. I have not actually tried it. Now, this is not available with the free version of Connected Components, and I try not to use any of the free, non-free features, because I know a lot of you are downloading the free version. Let's go and try it, though. So I'm going to try to make a run mode change. I'm going to click the run mode change button. Okay, that was slightly less painful than usual. I can highlight this, and I need to press the space bar. That gets me to go look for a 0. And then we have a test change button. All right, well, this is actually moving slightly faster than it used to. Now, I only have a 4-run program, so I can't really give it a lot of compliments, but that was actually better. I don't know what they changed, or if it, somebody just said it. I have not read any release notes that says there was any improvement, but that was better. Okay, well, we have a reset button. Sounds like we need to test it since we're at 27,000. So I press my red button. Let's go and get that, let's go and get these values back up there. There we go. So I press my reset button, which is a red button, and my accumulated value does go to 0. That's exciting. Now I press my CD, and it subtracts just by 1 this time. I press it again, does it again. All right, and I'm going to bring it up to 4. And mainly I'll look at the done bit now. And when I press it again, the done goes to a 1. I press it again, I can go to 5, and it's still a 1. Press my yellow button, it goes back to 5. Press it again, it goes to 0. So this does function like a Studio 5000 counter, except I did not build in the OV or the UN. And as an extra challenge, you guys can go ahead and do that. This may be a good example. If somebody really wants to, you could probably submit this to the Rockwell sample code up, but I bet some people would like it. All right, but next issue we have is, typically you have a nice tidy counter instruction, or even in CCW would have a CTUD, and now I got 4 rungs. So what I'm going to do is I want to package what we just did up into a user-defined function block. So I'm going to right-click user-defined function block, add ladder diagram, and we're going to call this our Studio Counter. Okay, yeah, that makes sense. It cannot have the same name as the data type. Let's call this our Studio. I'm just going to call it a CTUD. There we go. That'll be our instruction name for it. And first, we have some local variables, and we have to pass some data back and forth. Now, one catch I already know, so I'll explain why I'm doing what I'm doing in just a second. I'm going to make this my enable in, or enable underscore in, and I'm going to make another one my enable underscore out. And I'm going to designate this as an input. I'm going to designate this as an output. And this is completely for, we'll call it cosmetics. These two won't do anything. After that, we need to figure out what all do we need to bring in to do this. So we see we need an ACC, we need a PRE, we have a CU. We got a couple things to bring in. So let's just start typing those out. So we're going to do PRE, and that's something we're bringing into our custom data type. So it's going to be a variable input. Nope. Why is it not letting me add another rung now? All right, what did I do? Right click, add variable. Okay, there we go. Oh, well, I don't know what was happening there. Let's try it again. PRE. Let me just type them out first. Not liking that. It's not telling me anything. All right. Well, let's just close that and open it right back up. See if I just messed something up. Oh, there it is. I don't know what was going on there. That was weird. ACC. And then we are going to need a CU bit. Actually, you know something? We're going to need two of them because we need an input and an output out of this. So CU enable. We'll need a CD enable. And we're going to need our basic CU bit. We're going to need a CD bit. We're going to need a DN bit. And just so they're there, I'm going to put the OV bit. Oops, that's a V. And the UN. We're going to put those in. And mainly our preset needs to be a dent. And our ACC needs to be a dent. And okay, our preset, that's where, I don't know what went wrong there. Should have been just select variable input. Well, that worked perfectly that time. I don't know what was wrong last time, but okay. This will be a variable output because we're going to get the ACC out of it. CU enable will be a variable input. And you know something? I better just move the order and I didn't notice it. And the CD enable will be an output. Oops, you're an output. There we go. Okay, variable output. All right, no, that's an input. All right, start to pay it on you. Okay, CU is going to be an output. This is going to be an output. All right, the done is going to be an output. These are things we're getting out of it. The OV will be an output. And the UN will be output. So really, we're bringing in a preset. We're letting it know, is it enabled up? Is it enabled down? And then everything else we're getting out of it, and almost forgot. That'd be nice if we got a reset built into this. So we're going to put a reset in here. And that will also be an input. All right, I think that does this. So now let's open up our logic. Now notice I'm on the Studio CTUD. What I'm going to do is I'm going to take what we figured out here. I am going to select all and cut that. Whoops, can't do that apparently. Right click. Well, why is it not letting me? All right, let's do the shift way. Right click. I don't know. Cut. That was weird. All right, guys. Well, we're having some weird stuff happening now, but that's all right. And we're going to paste it in. And oops, I got an extra line there. All right, now we got to work through what all should be what in here because this is a little different. We're actually going to be using these local variables that we just created. That's what we're going to use on this. So our green button is now going to be the CU enable because it's count up enable. Our yellow button will be the CD enable. CD. Well, why is it not there? Oh, that's weird. Well, let me just try copy view. CU enable. Control C. Well, we just having some weirdness happening now. There, it works. I hope I don't have to find them. All right, now this is just the CU bit. CU. And this will be the CU. And then this will be the CD. This will be the CD. And uh-oh. I didn't mean to do that whenever I just did that. CD. CD. All right, this is the ACC. We're going to use that a bunch, so might as well just copy, paste, paste, paste. Oops, Probably did something wrong there. C, U, enter. And yeah, we need it there. And we need it there. Okay, and then we need our preset, P, R, E. And we need our reset. Okay, oops, nope. And we need our DN. So all we've done is made all this kind of built in. You know, on my computer suddenly, Chuck. We'll make it through here. We're almost done here. All right. So what we've done is we've packaged this into the Studio CTUD instruction. And so now if I close this out, oops, yes, we definitely want to save changes to that. And then we're going to go over to our program, which is now blank, and drag down an instruction block and start typing Studio. And you're going to see the Studio CTUD user-defined instruction that we just created. And all right, here's another good example. There's one thing I wish they would improve in connected components is this auto size. See, we've got some clutter or whatever you call it, not clutter, but see how they're overlapping here? It's the same deal. So let's right click the white area to the right of our rung, go to properties, and along with the cell width, which we just changed, we have a cell height. And so I'm going to make that 30. And that makes, of course, it does it everywhere. That's the downside. But at least get that where that's not all crowded up there. Okay. And I did something wrong. Why is the CD enable on that side? All right. You know, I knew I was struggling with something there. CD, variable input. All right. Whoopsies. This is supposed to be an input. Here we go. And I think you had to close it and reopen it to actually have that happen. Yes. Open it back up. Uh-oh. Wait. We got to close. We did close. Well, let's just delete it. Try again. Bring you in. Type Studio. There we go. That looks better. So we have a preset, account up enable, account down enable. Now, arguably, these should be in a different order, but honestly, the only way I know to fix an order is to right-click and cut, then right-click and paste. That brings it back down to the bottom. And then, I think same thing. You have to delete it. So it's kind of cumbersome. You probably need to do a little planning, or somebody needs to teach me a little more about how to do user-defined function blocks. But there we go. That's kind of what you would see in a count up down counter. And same thing on this. Actually, they're in the right order over here. So our count up enable is our green button. Our count down enable is our yellow button. Our preset. Oops, where's my reset? All right, oops. All right, well, we may have to figure out how to do this refresh or something. Is there a mess of it? Nope. All right, I forgot the reset. Is that what's happening here? RES? Okay, if you just select a var, it's just an internal variable. It's not actually coming in or out of this thing. It's just a storage block for it. The reset needed to be an input. Now, here's where I guess I need to learn how to actually change this. Let me try right-click, cut, right-click, paste. Oh, there we go. Okay, so right-click, cut, right-click, paste. They're on right back in until somebody teaches me how to reset. So our preset is going to be our studio counter.pre. Our reset is going to be our red button. Then our accumulated value will be our studio counter.acc. Our CU will be our studio counter.cu. And this will be our studio counter.cd. And this will be our studio counter.dn. And while they're not functional, I am going to go ahead and put these in. This is our studio counter.ov. Oops, there it is, OV. and studio counter.un. Hey, now I have never actually done this before today, so I have no idea if this is going to work or not, but let's go ahead and try it.
It's just not. What did that you ball? It. Hey, what? Beef. Okay. Okay. Whoops. I just pinned that. I accidentally do that about half the time. Not sure what advantage that gives you, but okay. All right. So I should be able to press. Oh, yeah, green button. I'm not sure why my descriptions aren't showing up. I press my green button. And my cumulative value goes up. That's exciting. I press it again. Cumulative value goes up again, and I'm seeing the CU bit. Oops, my counter done's not correct. Oh, yes, it is, because I did not put a preset in. And so if I put a preset back of 5, we should see the done checkbox go out right there. Excellent, it does. And so I press it. There gives me 3, 4. And when I get 5, that gives me my done. And I can press my yellow button. That takes me back down to 4. 3, 2, 1. And mainly -1. So that gets me counting negative. And that gets me counting positive past my done. Now, there is one challenge that if somebody really wanted to tackle this and package it up, because really that would be the next thing, is somebody needs to package this up and share it. That way people can just download a studio count up down instruction. Is if I put my cumulative value at 2,147,483,646, which is 1 off the maximum number. Why did I not take that? 2,147,483,646. Enter. There it goes. All right. Why is it not letting me take that? Okay, well. Oh, all right. This would need a little work, but hey, apparently the manual entry, why is the manual entry not work? Oh, I'm just curious. So that gets me in here. So I'll put it in here. 2,147,483,646. Well, if you want to enter anything. Well, no, there it goes. Oh, because, and honestly, I didn't even think about that. If I had planned this well, you didn't need to break any of that stuff out. Oh, all right. We may do one more generation of this before the end of this live stream. 2,147,483,646, enter. And it does take it there. I didn't even think about that. I forgot I created the data structure, and oh yeah, I didn't even need to create this other thing. Oh, well, we're going to clean this up in a second, but let me show you the one issue that this OV should be solving, and it needs fixed, is that gives me a sub, and now watch what happens. I press it one more time. That takes me to a negative 2,147,483,000, and actually that says 648. And the OV should come on there. But I just realized, let's clean this up a little bit. I didn't need to do quite a bit of that. In fact, I guess I didn't realize I did not need to create that structure and all. If I go to local variables, I can get to those others. So we need to CU enable. We need to CD enable. Actually, arguably don't even need a preset. Let's try that. Now, I may be getting ready to completely break this thing. We want a place for them to put the reset. And let's see. Yeah, we really, if we're going to make it. Oh, actually, you know what it is? Actually, let's undo. What did I just do? Oh, yeah. Let's put that back. I see what
I see what I should have done a little bit different. Preset is an input. And we go back here. What it is these don't need values. It didn't need this. Just take these out. In fact, we need to delete Studio 5000 counter. I see. We need the yellow button. Oh, we need the reset. Yeah, that's all we needed. And let's go delete. In fact, let's go delete some of this stuff. Let's not get too far. We just want to delete this structure. We probably didn't need that. And now we go back here. Double click on you. We're going to call you we'll just call you. That's not a bad name for what you are. All right. Why do you not like that? I think you do like that. You just screaming at me for no good reason. Let's see. All right. Did do something wrong. Oh, I put it in the wrong place. Yeah. This is the reset. All right. So we'll just take you out. All right. Let's download this just so we can see this. This actually is probably similar to what, Studio 5000 would have. Okay, let's see how this works, because I think this probably is what a lot of you are looking for when you're trying to convert a Studio 5000 or RS Logix 500 program. Is now I should be able to double click here. Oops, I didn't want to peek into it though. I just want to, a variable monitor. Variable. Well, I know it's there, so let's go here. Studio 5000 CTUD. And all right, right now we have a done bit because we don't have a preset. Okay, you see, I would need to rearrange these. Oh, that's right. You needed the preset value to be out. Okay, I'm going to fudge that. We would need to fix this, but I'm just going to go into here. I'm going to edit it. Oh, no, won't let me do it here either. Okay, we will go ahead and let's go ahead and make a run mode change. And we did need that preset. So, I don't know why. Why is that? Should have been able to get by that. Just so we can see how it worked, because, yeah, somebody else can take this and run with it. We're just going to put the counter priority right here. Because, yeah, I think somebody could take this and probably package it up nicely. All right, so yeah, and my computer is starting to choke. So yeah, because even the online edit is slower now. But okay, I don't know. Maybe somebody told me it was faster now. They may be right. Honestly, I rarely use a run mode change because it is tremendously slower than Studio 5000's run mode change. But all right, we have a preset now, and we should be able to put a 5 into it. I'd have to figure out how to get that poked out, but then we should be able to go to our local variables and open up this counter. And our done bit is now false. I press and hold the green button. All right, you better see you. Let off. Press again. All right, that is working. And on 5, we get a done. And we can count past it. We can count it in the negative. All right, I'm really not sure. I don't know, that was a good experiment. I don't know if that actually did a lot. I don't know if that's how I would do it or if I would just, honestly, I would either use the add out, but I think probably someone, and maybe it's there. Is it already there? Well, let's go ahead and look. It ain't going to take, we're already at, I don't even know how far we're in. What are we at? We're nearing 2 hours. So yeah, we're all about out of steam, but let's look at that. Let's go to Rockwell sample code. If I get in here and I find this thing's already here, I'll be like, well, actually, I'll be happy. But here's where somebody needs to submit this if it does not exist. I don't even know what I'm looking for, though. I want a counter. And then I think I can thin it down to which platform. Can I do that? Micro800. Oh, that's for the high-speed counter. High-speed counter. Oh, that's all does the word counter. Let's go for CTU. Nope, it's not there. Yeah, but so what somebody needs to do, And I would. If you do it, I'll even give you a plug and brag about what you end up with is somebody needs to finish. Oh, there you go. It's Micro800. So diagnostic counter, high-speed counter. Oops, and yeah, don't want to download it. Somebody needs to submit this to Rockwell sample code. And that would be beneficial, I think. I think there's a lot of people out there that are running into this because really in Studio and Logix, I mean, half the time you leave the presets as 0 because really we're trying to count and use values and nobody realizes it. Or, they have a set point, but they allow it to go beyond their set point. And those are two big issues that a lot of you have talked about and trying to figure out how to resolve.
Now that you have a grasp of the bit instructions and the timers and counters, you can do quite a bit of machine sequencing, and that's what we're going to do next. But before we do, let's talk a little bit about those of you who are using the simulators. This probably is that point that you need to make a decision. So if you're like, yeah, I'm really loving this and I definitely want to continue, it's probably time to invest in some hardware. And we would love for it to be one of our trainers. It doesn't have to be, though. If you can pick up some buttons, some lights, and a PLC, then that will be enough. But I need you to start understanding, one, the wiring, because the wiring is where you'll run into more issues than actually the programming, but also just how this wire relates to this PLC, just kind of starting to build out what a full machine looks like. So if you're using a simulator and you need some help selecting a trainer, feel free to reach out to me. But now let's go ahead and learn about some machine sequencing methods. Okay, and in this case, we're going to use just a really basic counter. So first I'm going to drag down an instruction block. And then if we just start typing CT, you're going to see the counters that come up. You have a count up counter, a count down counter, then we have the up down counter. We're going to use the CTU up counter. And I'm actually, let's leave this exactly as it is. And then we're going to need some conditions to make it count. So I'm going to bring down a rung. And our first condition was that button 3 would make it index if it was in step 1, or in this case, step 0. So we're going to go to our IO tab. And then we're going to... I wish somebody explained to me. I'm not sure why the outputs come before the inputs, but I always almost do that. And actually, it's input 4. So input 4 is connected to button 1. Actually, let's go ahead and label these while we're here. So this is our green button. This is our yellow buttons. Red button. And finally, our blue button. Okay, so we're going to use the green button here. Now, we only want, one thing we got to think about is what is the first step of a counter? Counters do start at step or accumulated value of 0. So we will have a step 0. There's nothing wrong with that. But we only want this button to work when we're in step 0. So we're going to bring another instruction block down in front of it. And we're going to be looking for an equal statement. Now, we talked about it in a few videos because if you're in Studio 5000, you're going to want to type EQU and you're going to get nothing. And that's because right now I am in the standard, and they call it the standard theme. We'll look in a second. But mainly, in this case, we've got to hunt and find the equal sign. Or I guess, can you hit equals? Yeah, we can hit the equals symbol and we bring these up. Now, if you're more used to Studio 5000, yes, the default theme up here, we're going to switch to the Logix theme. And then we'll go back in. And now if we double click on this, we can type EQU, which is what we're used to seeing in Studio 5000. And we can bring that in. All right, so now, what do we need to put here? Well, this is one of the differences in Connected Components workbenches. We don't really have a .acc file per se. We have you assign it things. So right here, what I'm going to put is, I'm going to make this sequence number. So I'm going to double click here. And we're going to create a global variable called sequence.
let's see, am I going to create a new program each time? Yeah, we will. So we're just going to call this sequence number, and it will be a dent. And so this is now going to be the accumulated value of this counter. So what I'm going to do now is I'm going to copy that. Let me right-click that and copy. That way you can see what I did. And we're going to paste it right here. And I want to say if the sequence number is 0, and why is that not showing up as green button? Oh, that's right, because I just installed version 13. And can somebody in chat tell me really quickly, where is that you make descriptions show up? Is it over here? I know it's somewhere. Is it labeled? It doesn't feel right. Let's try it anyway. That is not it. My descriptions aren't showing up, and there is a button that I have to change somewhere. Because mainly, yeah, I need to see that this is the green button. See, I can mouse over it, and I can see the comment. I don't know why they do this by default. Hey, is this one it? There you go. Okay, so where am I actually? Let's make sure we understand how to do that. Is what it is right now, if I mouse over this, I can see that I have the green button, but I can't just browse it. There are some quirks about connecting components workbench, and I really don't know why they did them. But if I right-click anywhere but an instruction, and I go to properties, oops, no, where did I need to right-click? I was just there. There it goes. And I go down here to variable information. See, right now it's name and alias. Is it name and wiring? Man, I still can't figure it out. All right, somebody's going to have to help me. I'm not remembering how to get my stuff viewing really fast. Or do I have to close it after I do that? Feels like this is not exactly it. Wait here. What do they call this? Comment. Somewhere you can put the comments on. Because I haven't, a Studio 5, in my other version of Studio 5000, I have that already set up. Name and wiring. Name and alias. Yeah. Well, that's going to make it difficult. Display comment. Oh, it's on true. Why is it not showing it then? Throw that on. Close it and open it back up. Well, in the theme, I usually have it. Even in the Logix theme, I usually show the comments. Now, I just installed version 13, but no, the theme doesn't seem to do it. All right, now. That's usually where it should. Because I do know by default it doesn't show it, which was kind of always strange. Display, wrong settings. Well, let me go ahead and I have Studio 5. We can switch gears pretty fast on this. I have the Connected Components workbench also on the base computer. Let me just look it up. Yeah, I'm not remembering the other options. Ladder diagram. All right, well, this is the same stuff you can get to over there. Name and alias, name and wiring. Where are the comments? Well, we're just going to have to press on here in a second. Hold on just a second. Let me check it over here. What I'm doing, I'll get it up here where you can see. So we're running an image here that I just installed version 13 on. So let me switch it over, and this is my base computer, which I use usually to figure out if there are problems. But let's see what it looks like here. Oh, we got some smart guys in chat. Nobody knows how to do this? Great. I know it's something simple. I just can't think of what it is, apparently. Let's see. Let's just bring something down. And we go to a global tag. Wait a second. I usually put the info right here. I've got it in the wrong spot. It's the 8. I usually put like green button here. Did I put it over there? Oh, it did. No, here. So this is a little bit different. Connected components workbench. I really don't know, what comments exactly are for. Because aliases are more of your comments or descriptions. There we go. Now we have a green button. So let me go back and take these out. And move these over here. Yeah. Well, Rod, what were you so slow on that for? You're right. I usually do too. I just, when I was sitting here talking, I sat there and put them in the comment column. All right. And while we're here, these are our lights. So this will be light 1. What's cool is in an alias situation, you can have spaces or anything in connecting components. So they really do work. Just like, well, actually, they're a good mix. This is a good, let me put these in. Light 2, light 3, light 4. All right, and mainly here, we want the green button. What's cool about this is, let's just copy and paste that real quick, is I can type in _IO, and I could go through all that and find that. But in this case, I can type yellow light. Yellow button. And there it is. So the alias is, in this case, it is kind of an alias because you can type them in, whereas descriptions in Studio 5000, you can't. Let's see, right, there's a visual. There is a tag visual when you right-click the tag. Well, not sure what that means, right? But, okay, this gets us back going. Sorry for that delay, but all right. So in this case, if our sequence number is 0 and we press the green button, then we're going to count up our counter. So that takes care of getting us through the first step. And now what we're going to do is, we're going to put a branch in the right place. And then we're going to copy, oh, that's right. Drag that there, drag this there. And then we're going to copy this equals down here. And actually, we can just copy this green button down here as well. Drag it over. And in this case, now if we're in sequence number 1 and we press the yellow button, then we want it to count. Because that's what I said, right? Let's go back to our Studio 5000. Let me make sure, counter, yellow button. Okay, now in this case, the red button, we want to have to hold it for 1 second before it goes on. I don't know, I just thought it would be nice to add a little something to it. So we're going to add another branch. And then we'll copy the equals. And in this case, yellow. There's some craziness going on there. What did I do? Probably my copy and pasting. It looks fine. Well, here I go doing a live stream right after I update the version 13. I guess I got a little bit of tweaking to do. But okay, that is the yellow button. But all right. So in this case, though, we want a timer here. Now, here's where I actually, in this case, I would probably put it on an additional rung. So if our sequence equals 2, right click on the object, go to properties. Oh, that's right. And I was messing around with all this stuff and I ended up changing a bunch of stuff, didn't I? Thank you. All right. I understand what you're saying now, Rod. And thank you, David. Thank you for getting me straight there. Okay. So in this case, if we're on sequence number 2 and we have the red button, not the same thing there. Wait, there is a global place to do this. Where is it? And click in the right spot. There we go. We want that to be name and alias. And now I think just every time after this now, it'll show name and alias each time. All right, so we got that. And now we want a timer. So we are just going to use a TON. Now, this is if you're in the Logix theme, you can type TON. And in this case, this is kind of one of the cool things about Connected Components Workbench is the way they use timers is one, I could put a variable in here, or I can simply put T #1F. And that's going to be a 1-second timer. Now, I can also put in T #1000 MS, and that would be the exact same 1-second timer. So I really do like the way they do the timers. And then up here, we're going to look for the Q bit in this case. The Q bit is very similar to the done bit. So TON, Q bit. Now here's something I see, I was waiting for the right spot, is I see this done often. As first I can add a description to this. So that's one thing I could do is I could make this a little more descriptive because right now, what is TON_1.Q? It's not really clear. A lot of people don't know is it defaults to these names, but you can change them. So if I double click right here, right there is the instance name. So I can put red button delay. Okay. And now it's one thing I don't like is it doesn't automatically change it here. Now we've got to go and type red button delay. Oops, didn't get it right. Red button delay.Q. But this is much clearer now. Why do I have a triangle there? Oh, well, I'm glad you did learn that, Rod. Yeah. Where am I? Why do I have a triangle here? Does anybody know? T, what am I missing? T #1S. That sure looks right. Let me just hit the build button on this. Why does that? Maybe I'm missing something. Oh, no, everything's fine. I'm not sure why it's showing a triangle here. Referring to undefined variable. No. Yeah, it is an undefined variable because we just wrote that out. So, okay, maybe they'll come back to haunt us. I'm not sure. Now, here's one thing I would do here is, while this will work functionally fine, I actually probably would add this red button right here. Just for clarity. I don't know. I could go either way on that. This does nothing, has zero functionality because obviously the red button needs to be true for this timer to start. But if I was looking at it troubleshooting and I'm looking for an input, it might make it a little clearer that the red button's what I'm waiting on instead of having to chase this down. But okay, so that takes care of that one. And then finally, we're going to have a blue one. So we're going to add another branch. Oops, come on now. Why can I not? There we go. Below. And we're going to copy the equals one more time. And this time we're going to be looking for 3. And actually, yeah, we are going to do it this way. And this time we'll look for the blue button. All right, so that takes care of that. And now what we need to do, so that is going to index through these. In fact, yeah, let's go ahead and finish our outputs and then talk about how this works. So basically, if we're in sequence 0, I want the green light to be on. 1, I want the yellow light to be on. 2, I want the red light to be on. I think I got one of those off. Green, yellow, red, and blue. So those are what we'll want. So I'm going to go down here, this output one. And we're going to, if the sequence number equals 0, we're going to output light number 1. All right, we should be able to just copy and paste that. And so in this case, if it's number 1, then we're going to go to light 2. And if we go to number 2, light 3, and finally 3, and number 4. Okay, now this is partially going to work, but let's go ahead and download this and talk about exactly what's going on here. While we're downloading, if you could take a moment to hit that like button and subscribe to our channel button, Probably need to stop and drink some water on this. And subscribe to our channel, then it really helps us out a lot. All right, so Rod, what do you think about it on AB compared to non-AB on CodeSys? Do you think they're similar enough? I hear opinions both ways on that. There is not a free version of Studio 5000 emulates. Actually, I would recommend the Connected Components Workbench that we're using right now because it does have a free emulator right here. So since this gets done downloading, I can quickly show. Now, one thing I've noticed about the emulator is, let me change back to run mode. One thing I've noticed about this emulator is it doesn't play well with Studio 5000 or something, and I'm not sure what. But right there's the emulate button, and here is kind of a miniature Micro800 PLC. So you can hit the power on button, and I'm going to get an error on this. And this is because I am online with Studio 5000, and I've noticed that some issue I get. But yeah, if I close Studio 5000, the emulator would work, and you can download to it, and yeah, we could sit here and just hit these to simulate inputs. So that would be my recommendation in place of Studio 5000 emulate. But all right, so we have a green light on now. So if this is right, when I press the green light, we should get the yellow light on. And okay, looks like we have a learning opportunity because it does not work. So let's go into our program and figure out what is going on. And let's see, sequence, let's get back over here. All right, online, looks right. Come over here. And we press the green light. It's true. So I did not put in a preset right here. And it's not gonna, so yeah, let me just go offline. And I'm not going to worry about figuring out the exact step. In fact, I'm just going to put 100 in here. That's fine. I'll put 1,000 in there. That's because we're going to reset it externally. In fact, that's why I wanted to download this so we could see, some options on that. So to download this again. No, it was in run mode. Oh, it's not now, but was it? Are you right? Was I not in run mode there? No, I was in run mode. But no, the issue was the set point was 0. Pretty sure. Well, let's find out here. So we pop over here and I hit the green button. All right, now the yellow button the yellow light illuminates. So now if I hit the yellow one, the red should illuminate. Now the red button, if I hit it, is not going to illuminate. So we can sit here and hit this and it's not going to happen because we have that timer on there. So I hit it for 1 second and we're going to get the green. Now, when I hit the green button, you're going to see the green light go out. And that's the next thing we need to work on is now if we go over to our program, we are in sequence number 4. Well, we only had steps 0 through 3. So 4 is not an actual sequence number. So at this point, if you were actually on a machine, you could either cycle stop it so that maybe an operator has to walk back up and do it again. Or in my case, I'm going to make it start all over. So I'm going to go offline here. And I am going to add another rung. And then we are going to put this equal statement. So I'm just going to right click, copy it. And I'm going to paste it here in rung 3. And if it equals 4, actually, in here, while I don't believe there's any way it could happen, this shouldn't be an equal statement. This should be a greater than or equal. So a GEQ. Now, it should never be able to get above it, but that's a good thing to do, I think. So I can't think of why you wouldn't want to do that right now. And so when it is, we are going to reset that counter. Now, resets work differently in Connected Components Workbench. If we were in Studio 5000, then we could simply use an RES instruction right here and reset our counter. But in Connected Components Workbench, the reset is actually part of the base instruction. So in this case, we're going to need to a tag here for this. So I'm going to call this reset sequence. Oops, sorry, I got to create that. And now I can take that same reset sequence, copy it, and then right here, we're going to use an output energize to that reset sequence. And we can take this out. And so let's download that. All right, so now it's showing a green light. And I press the green button. We go to a yellow light. I press the yellow button. We go to our red light. I press the red button. Oops, got to press it for 1 second now. So I press and hold that. We get a blue light. And then finally, when I press the green button now, it's going to go back to green. And we can sit here and do this all we want. All right. And so now, let's look at this in the program, make sure we understand exactly what's going on. So we have a counter here, and these are the conditions that we will count up with. So right now, sequence number has to equal 0. So in this case, sequence number is equal to 0, and we can see that because it's red on the right side of it. This case, it would need to be 1. This case, it would need to be, 2 and 3. So these 3 lower branches are all false. This is the only true branch we have, so we press the green button, and you never actually see it go true there, do you? You saw that really this turned red, and all of a sudden this was blue. That's because the scan cycle for that one split, maybe 2-3 millisecond scan, I'm not even sure what the scanning time of this is, that was true. But our PC is not going to update that fast. So now we're in step 1. So we can see that by the red here, and it's going to look for the yellow to be true. So this sequence number here is the same as this sequence number here, 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 and here. They're all the same tagged. So I press the yellow button, and that shifts it down to here. Now here, if I hit through, well, if I can do it quick enough, yeah, so you can see the red button indicating, but since I'm not holding it for a full second, it's never going to go through. It's waiting on that delay. So we're going to hold that, and now it shifts to the next one. It's looking for the blue, and we go back to the beginning. And this is pretty much what we saw in my first RS Logix 500 program, is me sequencing this way. But now let's talk about a variable of this that we can do, because what my issue with this is, and really I saw it in that program, but I couldn't come up with exactly how to fix it quickly during the last live stream, is this is almost readable here. I mean, you can see even here, we got slightly scroll down, but what if we had 20 sequences here? Can you imagine the scrolling? And, as you're scrolling, you're navigating, it can get to be a really big headache. Let me catch up a little bit on the chat. I don't have a WhatsApp group. I'm surprised there isn't one out there, but yeah, no, we don't have that. Let's see, Rod, on the emulate issue, I have used the HMI to simulate a piece of hardware or control sensor. Yeah, I actually need to do a video on that because that's a really neat feature. Let's see, yeah, it does require a little bit, but yeah, I should put that on there because you can do some pretty neat things there as far as learning. Now, still, in the end, I want to grab a hold of some wires that just, I think you learn a lot faster. But hey, if you don't have any, or you need to simulate something, and when you're on an airplane or somewhere else, that's a great alternative. Well, not the HMI, but yeah, the simulator, it does have some advantages. But okay, on this can get to scrolling a whole lot if it grew much. Also, I don't like that this timer is stuck down here. And I did this one first exactly like this because this is similar to what I see, and it's similar to what I did in my first one. But something that a lot of people don't know you can do, and I hope this works in connected components because I did not actually test it yet, is you can have multiple counters to the same instruction. Now, this should work with connected components. I can't see why it wouldn't, but if we look at our second Studio 5000 example, I've done this. So here are the branches, exactly the same as we have in connected components in one counter. But I can break this up. See, this is sequence counter. This is sequence counter. Actually, counters plural because this is a different one. Sequence counters plural. Sequence counters plural. Sequence counter plural. So I have 3 count-up counters going to the same tag. And I think this makes it easier to read if you're troubleshooting. It's really, okay, sequence step 0, 1, 2. And most importantly, I can combine this timer now into this really nicely so that when I'm on step 2 and I'm trying to figure out what is wrong, it's going to be really clear that either it's waiting on this or it's waiting on this. I'm not going to have to scroll or search or anything like that to go find it. So we're just going to modify our connected components workbench program now to be like that. And this shouldn't be difficult. We should be able to, well, we got some obstacles here. As first, when we did the TON, you notice I renamed this. Well, I haven't done this one yet. And here's where, it's going to become much more important, is I can double click here now. Oh, I got to go offline. Yeah, and I could do run mode edits, but I know a lot of you are using the free version, so that's not an option. So I'm just going to go offline to do all my edits that way. But if I double click on this, and then the instance down here, I can name this my sequence counter. And yeah, this does work. I'm not sure why we're cheating this occasionally, but it works fine. This is version 13, and this is my first video with version 13, so there may be a few things that I'm not aware of on it. All right, so now our counter is called sequence counter. Now I'm going to highlight this rung, and I'm going to right-click it, and I am going to copy this rung, and I'm going to right-click, and I'm going to paste once, paste twice, and we're going to paste a third time, giving us 4 copies of that same rung. And even now, it's really difficult to figure out where you're at because this is slightly large for this, with the font size and everything I'm using. That bottom one's getting truncated. But okay, notice when you create those like that, oh man, why did somebody tell me I spelled counter wrong? Oh, well, you guys got to keep an eye on me. We're going to fix that. We're going to go down here to the first one, which is actually at the bottom now. And we're going to rename it to sequence counter. But now I can go up to this next one. See, even as I scroll, it's a little difficult to find it. And I'm going to make that instance the exact same. I'm going to make this one counter. And then I'm going to change this instance to counter. And finally, this one to counter. So this is going to make them all address the exact same thing. And now what I'm going to do is, okay, this first one is going to be for my green button or sequence number 0 green button. So I'm going to highlight here and I'm going to delete that. Delete. Oops. Control Z. Did something wrong there. Highlight there and hit the delete. Highlight there and hit the delete. So that now is sequence 1 or sequence 0. So now the next rung, I'm going to delete this one. And then I'll highlight number 2, delete, number 3, delete. And then this one, it's going to be number 2, delete, delete, delete. And then on this one, it will be the final one. So delete, delete, delete. All right. Now, we have this TON, which I didn't like, stranded down here anyway. So I'm going to copy it now. I'll just right-click, make sure I right-click that way. Y'all see exactly what I do. Now we go up here to sequence number 2, and here's where we're looking at that. I'm going to put a branch in here. I'm going to drag this in. I'm going to drag this in. And I'm going to put that TON right here. I just think that's going to make it read so much better and make it where we can, I think it will make our troubleshooting a lot better. So now we can delete this. And if I've done all this right, this should work exactly the same way. So sequence 0, green button, counts. Sequence 1, yellow button, counts. Sequence 2, red button, after a certain amount of time, counts. And finally, the blue button counts in sequence 3. And then sequence 4, greater than or equal to, should reset the sequence. Here's where it's always scary doing a live stream and doing this without any testing is I feel this should work, so let's give it a shot and find out. Well, look at there, unable to download due to build errors. Red button delay queue, undeclared identifier. Oh, okay. Well, there you go again. When it copied and pasted, and maybe does anybody know, is there a way to turn this off? Because this does get annoying. This is you're copying and pasting. This is always wanting to increment, which I guess they're doing so you don't end up with a bunch of duplicates. But it's a real headache. If I hit the build button, let's make sure there's no issues now. And we look good, so we're going to download that. Michael's all our statistics still looking good over there. Well, go. Yeah, I do need to. While we're waiting on this to download, I do need to give thanks to Michael, my son. He actually makes all this live stream stuff work, and that's all I can call it is the live stream stuff because he's just a genius at it. So thank you, Michael, for doing that. And let's see, we're going to switch back to run here. And David, am I a master electrician? So interestingly, yes, I am. I'm a master electrician that has actually never used my license, though. We're a UL 5088 panel builder. So I did end up becoming a master electrician, but I have never actually, I farm out all of really the power end of our control panels typically. Because, I'm just not a great conduit bender. I mean, just put it out there. Everybody's got things they're good at. Conduit bending is not mine. Okay, so let's see how this works. It should work exactly the same. So I press the green button, yellow light comes on. I press the yellow button, the red light comes on. Now I can sit there and kind of peck on this and nothing happens. But I press and hold that, and you're ever going to get a blue light. And we press it again, and we're going to do that again now because I didn't realize it was not on full screen. But yeah, green button shifts it to the yellow. Yellow button shifts it to the red. That doesn't work. We've got to have that for 1 second. Goes to green, goes to blue, whatever that color is. And then we hit it again and it goes to the green. So this code right here does exactly the same as our previous code. But I think this is much easier to troubleshoot later on. And here's where I was going to create a new program every time. And this is why, and I will do that from now on, is I would love to go back and look. Well, I did create all the Studio 5000. So we can't see it here. Is if we look at this one, this is the way it was written. But if we had 20 different conditions or 20 steps, it would get really to be a pain scrolling this and coming back up and figuring this counter out. Whereas really breaking this up into the individual ones, it definitely makes it easier. All right, Alex asked an excellent question, and I was sitting here thinking, I was like, I did not address the elephant in the room early on in this stream. Is what is your opinion on the SQI and SQO instructions in Studio 5000 for sequencing? Well, Alex, if you have been in our last live stream, I actually went through that one, and I had a perfectly written SQI and SQO instruction, and 20 years later, I couldn't even figure out how to follow it. I mean, it is the most powerful set of instructions for programming machine steps. It might be the worst nightmare scenario for troubleshooting machine steps. Well, no, I mean, a horribly written program would definitely be worse. But here is one. It's just, let me make sure I'm on the right one. Let's see. Make sure it. Yeah, so my first Studio 5000 program talks about that. So, opinion. All right, let's just put SQI and SQO instruction problems. There you go. Check that one out sometime. It'll give you my opinion on it. But no, it has tremendous flexibility. And actually, I should address that a little bit more. Is I see mainly mainly students. Instructors come to me too, but students come to me and they're like, hey, I need to figure out how to program this with an SQI and an SQO. And I go through and I told them, no, this is not how you do this. You don't want to do it. Here's how you want to do it. And he's like, well, this is my homework assignment. And that's the biggest place I see the SQI and SQO use is chapter 18 of the PLC programming book had the SQI and SQO instruction. And the instructors try to teach it. And man, I mean, instructors do contact me. So like, I can't figure this out. And usually I can talk them out and talk them off the ledge and be like, you don't want to do this. Teach the students this way. But yeah, overall, I don't like them. And as I went through there and talked about is mainly that is not universal. So it won't work in connecting components. It won't work in an Automation Direct. It won't work in a Siemens. It won't work in a Mitsubishi. Really, the sequencing methods we're going through today, I can't imagine them not working in almost every PLC out there. And that's why I think mainly I chose these particular ones. But all right, let's go on to the next one. And we will create a new program for this one. We'll do some copy and pasting, hopefully to smooth this up a little bit. But, well, no, probably not. But okay, let's go offline with this one. And we're going to create a new Connected Components workbench. And while we're waiting on this to load up, because it is a little bit slow to load, please take a moment to hit that like button and subscribe to our channel. Also, we do a newsletter, at least one newsletter a week. Most of them are letting you know what the latest and greatest instructions that we have out there are. But if you go to any of our, really any of TW Controls, any of its pages, and just scroll all the way to the bottom, you're going to see where you can subscribe to our newsletter. Also, occasionally have a promotional coupon like we're having in chat today, which if you didn't know it, there is, everybody who's participating in chat is put in the running for a 10% off coupon at TW Controls or PLC Tools. Okay, why are we still loading up? What did I do? That seems like a long, long time. Oh, wait. Yeah, no. Oh, there we go. We are loaded up. We're ready to go. All right, so again, we're going to create a new program. And this one is going to be Sequence Seal. Yeah. And we're going to go to Controllers, Micro800, and we're going to select the 2080 LC20 20QBB. And we're going to add it to our project. Let's see. William asks, have you done anything with the PowerFlex 755 with an encoder and motion commands? No, I haven't. And this probably comes down to opportunity. I don't work with a lot of PowerFlex 700s in general. Most of mine, we work with a ton of the PowerFlex 525s. We go through them like they're candy. But I don't get into a lot of PowerFlex 700 applications. So, no, I doubt that'll happen. Now, we have done some motion control on these, and we're going to do a few more because it can do some limited motion, nothing like the 700. But we'll probably do some more of those. But, yeah, a lot of our videos, as we've talked about many times, there's no real revenue source from our videos. So, it's more, we have a control panel that's being built and happens to have the components. That's how most of these videos get made. So unless somebody that has us build something with a PowerFlex 755, it probably won't happen. But all right, we're in Connecting Components Workbench. And all right, now I started the last one a little different because we were in the default theme here. And I want to make sure we didn't get lost there. As this is how the default theme works. And if we switch over to the Logic's theme, it kind of lays out more like Studio 5000 does. And so in this case, our main task is where we're actually going to create our programs. So we're going to right-click Main Task. And we're going to create a new ladder diagram program. And let's go ahead and rename that. And we'll just call this our outputs. Although really we probably could cram some, I don't know. You should have probably some organization. So yeah, we're going to do that. And we're going to add another one. And this one we're going to rename to our sequence. And actually, same deal as last time. You can drag these around. Oops, I can drag program 1 up. And there you go. Now it's above. I never played with this. Can I rename program? Oh, yeah, look at there. So I could also rename this to sequence. I don't know why I would need to. Also, it kind of makes it look like you could add multiple routines here, but you can't. If I added another, oh my goodness, that has changed. Oh, wow. Well, I believe that's new for version 13. I'm not sure here. But I tell you what, we're if we're not all fried later, we may play with that. Let's stick with the way this one was done, which means we had program 1, program 2. I believe that's a new feature for version 13. I used to, or maybe yeah. Wow. So there you go. I'm going to put that on the list to make videos on is how that works. And it may be that it does nothing different, but okay, let's not get too far off. In this one, we're going to be doing the seal in. And of all of them, this is my least favorite probably. Actually, this is my least favorite between this and the latch unlatch. So now these work. So I can't put them completely down, but I would not do the seal in or the latch unlatch in this case. And we'll talk more about the reasons a little later in it. But let's just get this in there first. So in this case, we have a sequence seal in, and we're kind of working down through here, and we're sealing it in till the end. And this is kind of our basic start-stop circuit. Kevin asked, what are your thoughts on structured text? I like it because it's easy to copy code between platforms. And, you know, this is actually my most common battle. Now, before I go any further with anything I'm saying, I actually love structured text. I love function blocks, and I love ladder. And the program I was going to go over before everybody asked for us to go through these from the ground up was one of my programs I recently wrote in Connected Components that used all of them. Now, my argument against what you just said about structured text is, yeah, it's easy to copy and paste, but in the end, I am an old school maintenance technician. That's what I did before I started TW Controls, is I worked maintenance. So my mind always is, how do I troubleshoot it later on? And I think that's where structured text falls down as far as working with field devices. Now, flat out, you cannot do math or anything like that any more efficient than structured text. And let's face it, a compute statement and ladder, isn't that structured text? So already there's a lot of sprinkling of structured text, but where I draw the line usually with structured text is when we're actually dealing with physical inputs and outputs. I think at that point you need to transition to something else just to make it a little easier to troubleshoot. But okay, so let's get back here. And really, this isn't that much different than what we've done before. As first, let's go and, in this case, it's controller variables. Let's put in some description or some aliases. Oh, I'd forgotten about this. So this is a little quirky about version 13. Is if you have, because you notice I'm in the Logix theme here. I'm also in the Logix theme here, but actually I have closed it now. Okay. But it doesn't, I've noticed it doesn't automatically change this interface sometimes, but okay. Output 0 is going to be light 1, and then output 1, it's going to be a light 2, then light 3, then light 4. And then down here, input number 4. I don't know why I'm not labeling those as colors up there, but that's what I did in the previous one. So in this case, it's going to be the green light, and then the yellow light, red light, and the blue light. Pretty much the exact same thing as we did last time. And then we are going to need to create a tag. Oops. Should have done that while I was over there. let's go back over here. We're going to create a tag down here, and this is going to be our sequence. And it is going to be, oops, why isn't I letting? Oh, yeah. That's one thing I stumped in another live stream that we were doing is you cannot name a tag the same thing as a routine is named, which kind of can throw you because there shouldn't be any reason for that. But okay, sequence seal end. That's what we'll call it. And this will be a dent. And now we'll go, and in this case, we're going to be doing it just like we did here. So first, we're going to be looking for the sequence seal in not to be done. Actually, I should have done a little different. Oh, no, I did this one. Let's just go through it. So over here, we're going to use a reverse contact or an examinative open. And we're going to go and find sequence seal in. Now, what a lot of people don't know is at the end of this, I can just put .0, and that's going to look at bit 0 of the sequence seal in. And then I'm going to look for this green button. So green. Did I really put light on that? That is input 4. Okay. I was sitting here just talking away, and why didn't somebody correct me again? Yeah, guys, you can correct me. I won't get offended. These are all buttons. These aren't lights. Button. 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 And button. Okay, the green button is what we need. That's right, and it doesn't immediately update. I have noticed that. We just go off of it, go back on. I think you can also close the tab and open it back up. A green button, and now we're going to put an output energize here. And actually, let me just escape out of this because we're going to copy this. And we're going to put it right there. And now what we're going to do is going to put a branch around this. Now, this may look confusing right now, but we're going to go through it when it's done and explain exactly how it works. All right, does that look pretty much the same as that? Yes, it does. So we got that one done. All right, now we're going to copy and paste this down. And, whoops, actually I shouldn't have done that but once because we have to make a modification to this first one. Is now, it's going to be that. And then CLN will be 1. Okay, now we can do some copy and paste. And that's got to be 1. V. Okay, so CLN 1. Now this is, the second one is the yellow button. And then this one is going to be the red button. And this one will be the blue button. And so this one was 0 and 1. This one's going to be 1 and 2. This one is going to be 3. Oops. This one's going to be 2 and 3. And then over here, yeah, same deal. 0, 1, 2, and 3. Actually, no, I did something wrong there. I can tell I did something wrong. The seal, no. And, oh, except for I forgot that. The seal in piece here. All those are 3. Okay, so that takes care of that, and then we're going to have some outputs here. And so for the first one, sequence CLN of 0, it's going to turn on output 0. One. So 0 and not 1, and then 1 and not 2, and then 2 and not 3. All right, so first let's just download this program so we can see how it works. Sorry about that. I had to stop for a water break. Didn't realize I wasn't downloading.
It's participation.
Okay, well, we're in run mode, and our light is not lighting up, so I have something wrong. Let's go in here and figure out what's going on. All right, what do I got going on? We're in run mode. Oh, well, okay, well, and then again, it's going to do exactly what you say, but I sat there and copied pasted. This is output 0, output 0, output 0, and output 0. So yeah, that's not going to work. So let me go offline and fix that. Hey, and again, you guys ought to catch me on these things because when we are having a promotion in the chat, which is probably a good time to mention that, is that if you participate in the chat, you are in a drawing to get 10% off a PLC trainer or one of the PLC tools, simulators, and testers. And yeah, it'd be really helpful because we just sat here and stared at a machine that wasn't working. So y'all could have pointed that out. It would save us a little time.
15 birthdays.
Okay, now we have a green light. Now this should work exactly the same. So I press the green button, the yellow light comes on. I press the yellow button, the red light comes on. I press the red button. Oh, I didn't put the timer in there. So we got to fix that because immediately when I press the red button, it goes to the blue, and I press the blue and it goes back to the green. So let's go and put the timer in and just, I don't want to shortcut this one too much. Now, I got to tell you already, and you notice I didn't spend a lot of time on the ceiling because after thinking about this is one that was brought up in the last live stream as an option, and I don't think this is a good option. But let's go through it and give it a fair shot. Is right here, I forgot to put in the TON timer. So we'll drag that output energize, and And we'll bring down a TON. Well, Mustang, hey, something, we learn from our mistakes, though. So I get excited about mistakes. I call them learning opportunities. I don't want to make too many that are just like, all right, you're wasting a lot of time now, though. So yeah, feel free to reach out and be like, hey, you forgot this. So let's see, a 1 second timer there. And then we're going to bring this down. And that will be TON. Okay, that should take care of that. So let's download this. Oh, well, okay, you didn't even see what I did there, but I added a timer. I wish somebody again. I get some Michael just brought me some caffeine because, yeah, I'm slowing down a little bit. So he's like, yeah, you need to put a little pep in your step. So, yeah, you didn't even see what I was doing there, but let me just show you, since you didn't see it, oops, get back in there, is mainly I added this timer right here. So and this is the same as all the others we've had. Mainly this red button, we want to be pressed for 1 second before we move on to the next step. So I'm going to download this program. Well, it seems to be taking a really long time to download. Well, while we're waiting on that, what all projects is everybody in on right now? Is anybody got any fun projects? I'm always looking to see what everybody's doing. It's always, it's just fun hearing about different things. Sometimes you get in your own, your kind of little narrow niche and you don't, get to see other things that are going on. All right. Well, actually, we failed to connect here. Let's go ahead and put this on. Let's save. Failed to connect, which seems really weird because we were just connected. So I guess this is one situation where we just try it again. It sure acts like it's not doing anything. Man, we aren't. Oh my God. Hey. So I don't know where I did it. But we have a learning opportunity here. As if you have watched any of my videos, I always tell you when the one thing about connected components workbench, and I think they could work this a little better, although there is a warning there, but it's not really clear, is when you create a new program, it enables DHCP by default. And if I go here to my controller properties, and I go to my Ethernet configuration, I just downloaded a PLC with DHCP enabled. Hey, Michael, can you get me the SIM IPE over there? It's right over there on that to your layup. So in this case, there's a couple ways you could do it. Is one, if you had a DHCP server handy, then you could do it that way. It's kind of a pain with Rockwell's Boot P DHCP server. I'll be honest, I almost never get that thing to work. But so we're going to use the PLC tools SIM IPE, which is actually one of our devices. And we're going to go to prepare address, and it probably is in there, but let's see, IP address list. There it is. So that's what it was on, 192.168.114. So I'm going to select it, and then I'm going to go to assign address, and we're going to use boot PDHCP. And it is this top port. And actually, for the Micro820, you do have to cycle power. It only does DHCP for like 1 minute. So I plug it in. Hey, congratulations. You just got somebody in the chat. Check it out. They just got promoted to a control system tech. Very good. Congratulations. Mustang is also studying for RS Logix 500, 5000 for future work. That is awesome. All right, now I'm going to set it to static. There you go. There's always a learning opportunity. And yeah, now everybody knows I don't make perfect videos. But we'll go through that. And now I should be able to oh no, look, I'm getting ready to do it again. I'm going to make sure I cancel now. I just hit the download button, but I didn't actually put that IP address in there. Actually, I'm going to do this. I'm going to ride this through. This is actually a video coming out in a week or so, but let me go ahead and show you what happened for one and how we can fix it. Is I'm going to download with project values, just like we've been doing. Oh, right. Laura's converting an old PLC 5 trainer to be used with a slick Micrologics and compact Logics. We'll send a picture of it. I always like to see different trainers that are out there. But okay, when we are naturally doing downloads, the next prompt is normally, do you want to put it in run mode? Except if your Ethernet configuration settings don't match. And it says here, downloading current Ethernet settings will result in a disconnection from controller. Continue with downloading of Ethernet settings. But I'm looking for the run mode prompt. I hit yes. So I'm going to click no here. And what that's going to do is it's still downloading my program, but it's not going to apply those Ethernet settings. And now it's going to say, do you want to put it in run mode? And we do. But now let's fix our Ethernet. And it doesn't show it right now. But if we'll click, actually, wait a second. It'll show it. I think it does. Oh, we got to go back to our controller up here, double click it. And now, if we click on Ethernet, is it still loading? There it goes. Just a little slow. I'm choking up a little bit on the computer too. But the settings in the project and controller are different. Update from controller. What this is going to do is pull out whatever the PLC configuration is. So in this case, I had it for DHCP, but I'm going to click the button now. And now, let's see, we're configured and it's got it in there. And now we can download next time. Rod's got an IP Explorer. Awesome. I mean, I tell you what, then, I don't like to get too salesy, but yeah, if you don't have one of these, it is absolutely a lifesaver. And yeah, can it configure? Let me get a record. Hey, Michael, actually, here's what. Is one, we can plug into a device. So I just unplugged the Micrologics, which remind me later, I just knocked myself offline. I'll be scratching my head and wondering why it doesn't work. And I plugged directly into a device. Then I can go to read unknown. And it's going to tell me that, one, there's its IP address. I don't know if I can get this to focus in. Usually I use a different camera for stuff like this. But this IP address is 192.168.114. It also gives its MAC address. It tells me that it's a 2080 LC20, 20 QBB, and also that it's version 12, which can be really important when you're trying to figure out what, especially Stu 5000, what version you need. Now, one other neat thing you can do, though, is let's say we're maybe we're trying to figure out what IP address we should set our PC at, or, what all is on this network, is you can actually plug it into an Ethernet switch. And I'm not sure what all is on this network. Most of the PLC labs shut off right now. But now if I go to read unknown, Then, all right, it's discovered 5 devices, 8 devices. See, I'm reading that top line right there. Hopefully that focus is okay. So there is that Micro820 again, but now I'm going to hit the up arrow. And it's also discovered, well, there's a second Micro820, which is actually in a control panel that you can barely see right there. This is this compact logic trainer. I set it back here just in case we had a specific question on it. There's the PowerFlux 525 drive right here. There's another PowerFlux 525 drive that I can't even think of where it is right now. What is that? This is the Panel View 800 right here. And there's another Panel View 800 up there. And yes, Mustang is just asking, is it compatible with other devices? Well, yeah, here's my, actually my PC desktop. So no, it's not just for Allen Bradley. It's not just for PLCs. We have people that buy them for like large scale camera systems, configuring cameras, trying to figure out what cameras are used. It can do printers. It can discover anything that uses any of the standards. Now, there are some things out there that are just crudely written. It doesn't work great with, but yeah, it's an outstanding device for things like that. Okay, but all right, we've gotten off on a rabbit trail. But while we're here, though, let me at least put a link down to that. Just let's see. Actually, here, just go to PLC Tools. Which, yeah, I mean, guys, you're in the running for a 10% coupon here at PLC Tools just by participating in the chat. So make sure you participate. But all right. Let's get back to where we were. All right, I unplugged. So we know that, okay, yeah, and I am knocked offline. So let me go back online here. Did I download that program? Yeah, I did, because we just updated, we updated the Ethernet settings. Let me get back on. But actually, okay, we had just added the timer. So now if I press the green button, it should go to the yellow light. If I press the yellow button, it should go to the red light. If I press the red button, it doesn't. But if I press and hold it for 1 second, it goes to the blue. And then the blue button takes it back to the green. So it does exactly the same thing. Now, my problem with this is overall, what step exactly is this in? And mainly, I don't think this is very clean to troubleshoot. Now, there's some things we can do to add to troubleshooting. So because let me give this a fair shot. One, I just like having a step number. Like all our previous ones, we have been able to look and say that we're on step 0, step 1. Well, in this case, we're on 0 but not 1, or are we on 0 but where are we? But we can make it a little easier. Is we can add a rung right here. And I am actually just going to copy this. And we'll paste that, 2 times? All right, 3 times? Somewhere around there. And we're going to make this number 1. And we're going to make this number 2. And we're going to make this number 3. And then, honestly, I'm trying to think, does Studio 5000, Connecting Components, does it have an NOP instruction? NOP. There you go, no operation. Now, if you're not familiar with a no operation, it's just that. It just does nothing. But it's going to let that rung be true. So I'm going to download this. So awkward silence every time we download. Michael says I need to smooth out my my plug for everybody to subscribe and like and do all the things. So how can I pitch that better? Throw that in chat because Michael has little cue cards he throws up at me. He's got this thing run really well back here. All I've got to do is manage to do some programming on CCW. He's doing the rest. But okay, we've got. Now, what happened there? Did I really just do that? No, I didn't do it again because we're good right here. here or writing to, well, I don't know what just happened there. Well, first, let's see. If I did that twice in a live stream, that'll be really bad. But okay, we'll get good practice of using the IPE. No, we're online. Let's just try it again, I guess.
Just remember in the stream to talk about to this thing.
All right. Well, I do not know what happened there, but we seem fine now. But mainly, okay, what I just added does help a little bit. Is right now wasn't quite online yet. It's almost there. But okay, right now we're in step, we'll call it sub-zero. And the reason, honestly, I wouldn't do it exactly this way, but what I find the reason a lot of people want to do the seal-in is they don't realize you can mix bit instructions and number instructions. So I left the opportunity to, use numbers out of this. But if I press the green button, then the yellow comes on, and now we can see that, all right, seal in 1. And so what people say is that, well, all you got to do is look across something like this, and you'll know exactly what step you're in. And this is similar to what I did in my first program, but I think I left a lot of opportunities out for troubleshooting. And also, it really becomes a bear if I want to insert another instruction in the middle. And mainly because really to do it, I have to shift all these down, and I'm not going to do that. I'm going to end up adding some crazy oddball bit in here to add another step in. So overall, I don't think that the seal-in still is a good way to do it. So I'm going to leave that at that. But there is a variation of it that I see, and that is the latch unlatch here, which is almost exactly the same thing. But in this case, we're going to, instead of sealing these in, we're going to do these latches. So let's just modify this. And this is a really easy modification. If we look at it compared to the seal-in, right now we're output energizing seal-in 0, seal-in 1, seal-in 2, and seal-in 3. And then we have this stuff here. In this case, we're taking that seal-in piece out and we're changing all those to latches. Now, maybe somebody in chat can help me with this, because I feel that I have never discovered something in CCW that makes this easy. As if I'm over here in Studio 5000, is if I want to change this to an output energize, I can double click on the symbol. Oh, come on now. Oh, I'm online. Well, that's okay. I'll go into an edit. I can double click here and I can bring up the dialog, and either I can drop down and I can select an output energize, or I can just type something else. Cancel out of that before I mess up. If I'm over here in Connected Components Workbench, I just feel I've really missed something all this time, because if it's a TON and I want to change it to a TOF, I can double click right here and I can just type TOF and I could change it. But if I double click here, I can't change it. I double click one, it brings up the variable selector. And I right click here, and I've never figured out that change instruction type. Is that what it's called in Studio 5000? Let's go back to an edit, and we right click here. Thought it was right here, but I am not seeing it. I thought there was an option right here to change instruction type, but all right. Maybe that was in RS500, but mainly we can double click on it, and I've never figured that out. So in this case, the only thing I know to do to change these to latches is to bring down a latch instruction. Why does it not let me bring it down even? Get there.
or
Swap.
get a spot.
Yeah, will you do that? Oh, you can't.
Okay.
Oh, let's see here.
Time to get
Do what, buddy? Hey, all right. We got somebody being a pain in the chat here.
the and you're just restricted.
All right. Oh, good grief, man. All right, there we go. Sorry about that, guys. Somebody's being a pain. All right. Now I got to think of where I was. Okay, but yeah, trying to put a latch into this. Well, why can I not get a latch to even come down now? What did I do? Latch. Oh, it's not. I'm gonna have to delete this first. Control X. But yeah, so this change instruction type here, it should be there, but I don't know. Why am I? There it goes. But all right. Can somebody tell me that? How do we do that? We should be able to change that somehow from an output energized to an output latch, but I've never figured out how. So delete that. Control E, and this will be number 1. And then delete that. Control V. This will be number 2. And then finally, we'll delete that. Control V. And that is number 3. All right, we are going to have to do a little... Oh, yeah, we're going to add one more wrong, but hold on, let me get... So now we can take all of these out. Oops, I just did something wrong. Control Z. I think I deleted... We got to delete a whole wrong. All right, so... If we go to our Studio 5000, the only thing this doesn't have is a way to reset. I am going to take a little bit of leeway here. Is I'm not going to stay bit completely because, I mean, at this point, why wouldn't you use a move to 0 if really the blue button is pressed? So we're going to change that last one from a latch to a move 0 to this whole thing here. So we go down here, right here, we're going to have a move. So I'm going to drag an instruction down, and this will be a move. And we are going to move a 0 to sequence CLN. All right, so this is a latch unlatch example. I'm pretty sure that's right. So let's download it. Oh. Oh. I think you should be able to fix those chats now. Okay. Sorry about that, guys. We're having a little bit of a troll in the chat. Oh. Okay, so we have a green light on, and we press the green button, it becomes a yellow light. We press the yellow button, it becomes a red light, and still that doesn't work unless we hold it for a full second, and the blue one takes it right back. So this does exactly the same thing as the seal-in, but this one I like even less. In fact, of all of them we're doing, I almost left this one out, except my goal here isn't to tell you how to do it the right way or the wrong way. These are things we're going to run into out there. But this is, if there's ever one that I would never do in a PLC program, it is this one right here. And the issue is, it's too easy to make this unorganized. That's really the statement I'll make about it. I mean, really, if we had it like this and it stayed super neat, and I mean, even that top row makes it really nice where we can see what's going on, it would be okay. But I rarely see them stay like this. They usually end up being a mess. So, but that is the two bit ways that you see, which you're going to bring us to, really, there's a couple more. And first, we have this bit shift left, and I was debating on skipping this one also, but it is one that several of you requested. So even now looking at it, I really don't like it. But okay, we can modify what we have for this bit shift left. This won't take too much. Let's stick with the program we're doing. And yeah, we can make this work pretty easy. So the bit shift left, what it's going to do is if we're looking at our tag and we look at the values in it and we actually open it up, let's just open any one of them up, that one up, then it has ones and zeros in it. The bit shift left is actually going to shift whatever is in 0 to 1, 1 to 2, 2 to 3, all the way through. What's kind of cool about it is it can even span different or multiple numbers. So you can do this through arrays, I think up to around 2,000. Now again, I don't particularly like this one either, but let's go ahead and run through it really fast. Let's go. All right, let's just take this back out. And then in the end, we're going to look. I'm going to take that one out. Oops. There. Maybe just get some of the sealing stuff out. And actually, all right, it may have taken more than I thought to modify this one. But all right, seal in 0. This will be seal in 1. This will be seal in 2. This will be seal in 3. Okay, and instead of a latch, we're going to bring down an instruction block. And honestly, here's where I've never actually used a bit shift left in connecting components, so we may be getting ready to learn something. But one cool thing about it is you can mouse over and see exactly what you need data type-wise, and also we can highlight and hit F1, and it'll take you exactly to the instructions with all the things you need to know. But all right, so in this case, our source is what do we want to ship? And actually, we have the sequence seal in, and it's kind of already nicely tied into it. But, and even that, we could change the name of it even. Let's go to controller variables. Let's go down and find sequence seal in. Oh, why can I not rename that one? I'm offline. Let's switch. That shouldn't matter, but I did just start using version 13, so let me see. I think that's exactly the same, so it's not going to be that. Why can I not rename? Okay. Well, that was weird. Why could I not rename that? Okay, so there may be an issue there. May need to look at that later. But all right, I'm going to make this sequence bit shift left. And then, I am going to switch back to the Logix theme. Yeah, they made a lot of improvements to the view this time in the Logix theme, but I have noticed a few things that I'm not sure exactly how it work yet. But all right, now we're going to put sequence BSL. Now this isn't going to exactly work though, because we mouse over. Notice that the SRC or source says any elementary, which means any bit that has, binary elements. But notice that 1.1 by it. That means it's an array. And arrays can be a little confusing on how actually to specify in, I'm really curious now, in connected components workbench. Okay, well, that's strange. Now I can rename this. I don't know what was up. But up here, we have the dimension tab. And so if we wanted just a single dimension, we can put 1.1. And that's going to make a one-dimensional array. It's exactly the same size. Also, I think you can do this. Let's see. Can I do 2.2? Yes, you could actually have the array start at 2. I don't know why you would want to do that. CCW doesn't use a lot of the zeros. Usually the things do start at 1, so we'll put it like that. And so now, though, these are going to have bracket 1 bracket. Oops, I did something wrong. There we go. It's going to have to be in this format for it to work with the bit shift left. So we're going to just add this. And we'll do that to all of these. All right, this may have been easier to rewrite, but that's all right. We're going to get through it. And again, this is not actually all of these bit manipulation ways that we've done in this, the latch, the CLN, and this one, they would not be my preference on how to do this. But let's do enough of it that we can understand how to do it. So mainly, if we're in position 0, yep, okay. Now, so this now becomes also the 1. All right, now the offset is going to be 0 because we're going to start at bit 0. And the bit address is what we're actually going to load into it. And we're going to make that 0 because we're going to shift, bit address. Well, let's just jump back over here. What is that? Maybe I don't know. Location of bit shifted into source. Location of, well, maybe you have to create a bit for that. No, we can put false. There we go. Yeah. You have to remember that. So 0, that is a number. It is an integer. Fal in connected components workbench is a 0 binary number. And then our length, we're just going to make it the full double integer length of 32. And what that's going to do is it's going to shift all the bits each time that this happens. And what's the easier way? Just to copy and paste this? Yeah, so really we're going to delete what we have. Oh, no, we got that already, though. Well, let's just copy and paste one time, and then we'll figure it out. Control-C-V. And so this one will be, so we have step 0, we have step 1, and this will be the yellow button. And, okay, in this case, everything is there. We just need to copy this, put it right there, and delete that. And then finally, we are going to do this last one different. Let me make sure how I did this in Studio 5000 is, yeah, during that condition, or if it equals 0, then we're going to move a 1 into it. And we'll talk about why in a second. But all right, so we go back here. So yeah, in this case, so this part is here, but we're going to be bracket 1 bracket, and we're going to move a 1 into it. But we're also going to do it whenever Mustang, where are you at? What looks like function block and ladder? Oh, while we're waiting on Mustang on that, go ahead and put that in the chat. This will be equal. You're talking about the bit shift left? Well, and you'll find that there's not a tremendous difference between function block and ladder. I get people upset when I say that. But, the biggest difference is we could have reference points on function blocks that would shoot values into there. And here you have to actually put out names. That's really the big difference in those. All right, so then this will be this value. If it equals 0. Now, first, let's see if this even works. Oh, no, we got to make some more changes. We got to go over here. And, I should use the find for this. I've never used the find often is there a replace? Edit, view, device. There should be a replace, but I don't see. I was looking to see if there's an option for find and replace, but nope. So we're going to type these in. Oh, do you mean the instructions, Mustang? You're just not familiar with like the bit shift left or? Okay, oops, why is it not like that? I should like that. Oh, oops, that's a 1, not a 0. Hopefully I didn't do that any other times. But okay, that. Oh, but that needs to be that down. Hopefully. One, that. Two. And 3. That should make us a bit shift left sequencer. Let's see how that works. Michael, how are the statistics looking over there? Everything's still working right?
Yeah.
Yeah.
Yeah. We have 15 participants.
Okay. So now we're going to switch that back and let's do it. Well, first, let's just see if it works. Because honestly, this is one I have not tested at all. Because I don't think I've ever used a bit shift left in Connected Components Workbench. But all right, so we press the green button. Yellow light comes on. We press the yellow button. The red light comes on. We press the red light or red button. Nothing happens, but we hold it for 1 second. Blue light comes on. We press the blue button and it goes back. So it does work exactly the same. And now, though, this one's going to have the same issue for me that some of the others have, is if we go and look. Now, first, this is clean. I can kind of figure some of this out. But mainly, if I am not familiar with the bit shift left instruction, and that is I won't call it a specialty instruction to Studio 5000 or Ars Logix or Allen Bradley or any of that, but it is an instruction that's not necessarily in all of them. So if you're not familiar with it all, it can be a quick stumbling block. And so that's why I would not use this one. But okay. Now let's talk about some things that we would. So first we had some the basic counter. And I got to tell you, looking back, I'm not so sure that the counter is not one of the best ways to do this even today. I mean, that was my way I did it in my first PLC program. And I think it is pretty clean. I would probably go this route if I was doing a counter. After that, we did the CLM, we did the latch and unlatch, and we did the bit shift left, which are all ones that I've ran into that I've seen. I would not do any of them. I mean, I just don't think they're good ways of, I will call it reliably sequencing logic and ways that later people can troubleshoot. I mean, you may make it work, but I don't know that I would ever do it. Now, let's talk about ways that I probably would do it today. Is first, we have a move binary. So this is what we're going to do next. And I think we'll start this one from the ground up. We'll start with a new program. Somebody remind me, put my Ethernet settings in this time. And what we're going to do is we're going to create this program and talk about how it works, because this is an important thing to understand what is going on here. So one, when we're starting off, actually this bottom rung is what starts it off. We're moving a 1 into our sequencer. Actually, what is that? sequence move binary. Can I do that? Well, yeah. Oh, yeah, we're on fly with this PLC. Yeah, we can do anything we want. Let's go and monitor this. And it has a value of 1 in it. But if we open it up to the binary bits, 1 means that bit 0 has a 1 in it. So next, if we go there, it's moving. Where am I? Wrong place. Got too many programs open now. Next, what it's going to do is actually going to move a 2 in. But let's look at what happens when we move a 2 in. So this is looking for the green button. I'm going to go reach back here. And I'm going to switch 0. Oh, hold on. I got to make that worse. Let's see. This is sequence number 6. I actually have this where you can run different ones. So put it down here to sequence 6. All right. Now, if we switch 1, or what is the green button, notice that when it moves that value of 2, it actually shifts to bit number 1 having a 1 in it, and the rest of them being zeros. And then we look at the next one. When we hit the yellow button, it's going to move a 4 in. And if we watch it, when we hit what would be the yellow button, that it's shifting that 1 to the next position, or the 2's position. And then finally, we're going to move an 8 in. And that is going to move it to this 3's positions. So when we move these values, it makes it where we can use the bit locations to do the same thing we've done in the previous programs. Oops, we don't want to look at that one. That one's a headache. All right, now let's do this in Studio 5000. In Connecting Components Workbench, and talk about how it works. So I'm going to go offline, and we're just going to create a new Connected Components Workbench program. And while we're doing that, if you haven't already, then please like and subscribe this video. And also, we have, let's just navigate to one of these while we're waiting on Studio 5000. Is if you go to it, first you go to twcontrols.com, then you're going to see the subscribe there. Go ahead and subscribe to our newsletter. And up the top, you're going to find all of our lessons. All of our lessons are free, whether you buy our products or not. So you can learn about how to get started in automation, Studio 5000, Connected Components Workbench, HMIs. Here's the podcast right here that actually we're in right now. How to build UL508 control panels. There's an RS500 series, motors, drives, conveyor trainers, industrial wiring, PIDs. I mean, the list just goes on and on. And if you click on any of these videos, while we're just waiting on that, we'll just click on one of them. And then if you'll go in and hit the Watch on YouTube button, and I'm going to do this actually, because it's not going to give it to me because I am in the channel owner. But if you go normally, then right below here, you're going to see the subscribe button. If you will hit that subscribe button, we would much appreciate it. It'll let you know when we're putting out new videos. All right, let's get back to it. So here we are. We're going to click the new button. And we're just going to call this one, let's just call this sequence decimal. All right, and under controllers, Micro800, we're going to be selecting the 2080 LC20 20QBB. All right, and yes, most importantly, so I don't have to show you how the SIM IPE works again. We're going to go to configure IP address, and it's going to be 192.168.1. Whoops. 192, 168, 114, subnet of 255, 255, 255, 0. And we are going to create 2 new programs. So new ladder diagram, and we're going to create another one. And this first one, we're going to call our sequence. Oops. Sequence. And our second one will be our outputs. And then let's go ahead and open up our variables. And this time in our alias column, like we're supposed to, we will put a few descriptions in. So, well, I don't know why I've done it the other way every time, but this time I am going to put that this is the green light. I don't know why I was putting light on every other time, but green light, yellow light, red light, blue light, blue light, and then down here, we are going to have the green button, the yellow button, the red button, and finally the blue. Man, I'm struggling to type all of a sudden. Button. And then we need to create one variable here, and we're going to call this, excuse me, our sequence number, and it will be a dent. All right, let's open up our sequence, and this is going to start looking like Groundhog Day because all these have the same rough structure. It's really how we're tracking the sequence number. And so we're going to bring down an examine if closed, and we are going to look at that sequence. Actually, just double click the sequence number, and then we're going to add bit 0 to it right there. And then same as before, we're going to be looking for that green button on this first time. So we'll go to our IO, and we're going to look at the green button. And in this case, we're going to bring down an instruction block, and we're going to use an MOV move command. And we are going to move a value of 2 into the sequence number. And now we'll just copy that 3 times. And so if sequence number .1, then we're going to look at the yellow button, and we're going to double this every time. And we have a video that actually goes through how binary works, and that would be a good one to check out if you're not exactly sure what's going on there. This time we're going to move a value of 8, and then to start our sequence over, forgot that's the red button. And then when we're in step number 3, this time we're actually going to move a value of 1 back in. That's going to reset it. Also, I actually need an initial. We should talk a little more about that in another video, but we need to get a 1 in this initially. So we're going to put an EQU. So we'll bring down instruction block, EQU, and we're going to be looking for the sequence number to be equal to 0. All right, and then, outputs are going to look very similar to what we've done in all the other videos. Is we're going to let's bring down a rung, and then let's bring down, I still don't need that. Let's grab sequence number, 0, and that is going to output the green light. Leave that. We will copy and paste that 3 times. And then we're going to look for 1, 2, and 3. And that is going to do the yellow light, the red light, and I just realized one thing I forgot was that timer. So let's go to this red one here, and we'll add a branch around it. Oops. And we'll bring an instruction block down. TON. And again, we could name this. So in this case, we could make this the red button delay. Whoops, why does it not like that? Red button delay. Okay. Well, I don't know why I didn't like it the first time. And then we'll put this down, and at this point, we can look at the red button delay .q. All right, let's download this one. Did I put my Ethernet settings in this time? I believe I did. Let's see. Yes. So we should be good to go this time. So we're going to download this. All right. All right, now I got the warning on the Ethernet settings again, did it? What did I do wrong? We'll have to go look at that. Because, yeah, I definitely don't have to demo the IP again because I love demoing it, but I don't need to demo it because I made the same mistake twice. All right, coming back. And we're going to go there. Let's look at this Ethernet. All right, now one thing I haven't talked about, I mean, I get it. You want to make something graphical, so if you put this cute PLC here, but it's maybe the biggest pain in the rear thing, is you have this double up arrow here. You can use that and get this thing where you can actually read what is going on here. But okay, so apparently I still don't have my settings right. I bet it has it does. It had a gateway address. And that's what I forgot. There you go. So that fixes that. But okay, let's see if this works. So green light is on, we press green button. Yellow light is on, we press yellow button. And then that didn't work. That did not take a second. So let's figure out what's going on here. We go back to our sequence. Well, it didn't work. All right, what's wrong with this? Anybody in a chat seeing anything? What did I do? My mind's starting to fade here, so you're gonna have to help me out more. So let's see. Green button, yellow button. All right, and the delay. Why did it blow right past that delay? Oh, it's going to blow past that because look here, my set point is 0. So it was exactly 0 milliseconds of delay there. So we'll go offline. And yeah, right here, need to say T number 1S. And now we can download that, and that should fix it. Thank you, John. Yeah, you're right. No timer value. Oops. Oh, okay. We'll fix that later. And after a while of looking at this, and it can all start cross-selling. Like, this should work really fast. But yeah, if you put a 0 preset in there, then yeah, it's going to go right past it. Okay, so let's see how it works now. Oh, and again, I did that without showing y'all what I did. So yeah, what happened was right here, I had no timing in this. And that's why y'all couldn't figure out what was going on, because you were sitting there looking at me, staring at the screen. You weren't looking at the actual screen. But okay, so now if we switch back, I press the green button, and we get a yellow light. I press the yellow, and we get a red. Okay, now that works. And I press and hold it. All right, and we get a blue, and it goes back. And I would say that this or the final one is the way I would do machine sequencing today. Mainly because I think this is clean. You've got a really obvious, we're in sequence number step 1 right now. And all you gotta know is a little about binary to figure out, okay, well, step 0, that's where I've got to be. And I mean, mainly I press the green button and it takes me to step 2. And I press the red button and I hold it and it takes me, I press the yellow button, it takes me to step 3 or step 4, sorry. But they're sequential enough steps that I can find exactly what's going on. Now, there's a couple variants of this that you could do. And I do not, absolutely, positively do not like this next variant. But I do see it. And so if you're going to see it, then we need to talk about it. Is what you'll see people do is instead of using this move command, they want to show, I think they just want to show that they know a thing or two about math. That's all I can figure out. But instead of doing a move here, they'll do a multiply. And they will take the sequence number and they will multiply it by 2. Now think about it a second. First, you go to the bottom. We start out with sequence number 1. Okay, if all that's true and we multiply, we're going to end up with a 2. And if we do that again, we're going to end up with, 2, we multiply, we're going to end up with 4. And 4, we multiply, we're going to end up, you see, it's going to double. It does, they are right. It does work. But I don't think this is a good thing. But let's go ahead and go through this so we can see how it works. If my machine is really starting to choke, I don't think it likes streaming and running virtual machines at the same time. Now, what's kind of neat about it is you use the exact same thing. So see, sequence number times 2 sequence number. Here it is again, sequence number times 2 sequence number. And so I can just copy that. I don't have to do all that. Copy that, paste it right there, delete that. So this is a multiplication example of it. So let's download this so that we can see that it's going to do exactly the same thing.
Right back.
Trying to download with project values. All right, so now, first let's see, does it actually do the exact same thing? So we have a green light, I press the green button, yellow light, I press the yellow button, red light, that doesn't work, I press and hold it, it shifts on, goes back. So this does exactly the same thing. I mean, and my issue with it is the previous way, you just needed to understand slightly that integers are made up of binary bits. Now you need to understand that multiplying numbers by 2 will shift that bit. And I do not think that this is good. I do think that people do this just to show that they know how to do a bunch of neat math. But now let's go to the final one. And this, if I'm doing something today, this actually probably is the way I do it. Let's start fresh. Let's go ahead and create one more program here. And this one will be, what am I even calling this? Sequence move. Yeah, I'll just call it a sequence move. That'll work. And what we're going to create, first, let me get through all this while it's fresh in my mind, let me select the controller and get my Ethernet settings in. It's going to be 192, 168, 114, 255, 250. And then, there was a subnet. That's why it hasn't been matching up the other times. There we go. But if we go over here, this is what we're going to be doing this time. And overall, I think this is kind of almost like the counter method, but it adds a little flexibility. And, as you get doing this more, you find that you rarely make the perfect sequence or the perfect machine program off the bat. It takes a lot of modifications. And what I like about this version is it allows for modifications. So first, it's just a basic decimal number. So if the number equals, in this case, 10, and we press the green button, it's going to move 20 in. And here, 20, press the yellow button, it's going to move 30 in. So it's stepping it up, but it easily allows that, let's say I decide I needed something between the yellow button and the red button. Well, I can make it step 25. So that's what I like about doing this, is when you can kind of spread it out a little bit. And I think it's still easy to follow. So let's do this one. So we're going to make a sequence number. And the same thing. So let's go make a few variables. Actually, we need to create a few programs. So, a new ladder program. And actually, we're creating 2 of them. Okay, and this one will be sequence. And this one will be outputs. And then we're going to create a few variables. All right, so output 0 is still going to be the exact same it's been the whole time. Green, actually, we finally got it labeled right. Green light, yellow light, red light, and blue light. And then our inputs are going to be the green button, the yellow button, the red button, and the blue button. And then we're going to add, same thing as last time, we're going to have a sequence number. Well, if I can spell sequence, you can tell the stream is coming to an end when all of a sudden, I definitely am not spelling very well. That. All right. And bring down an instruction block, and this will be an EQU. And we're going to be looking at the sequence number to be 10. And then we're going to look for the green button. So, green button. And if that's true, Then we're going to use a move instruction, MOV, and we're going to move a value of 20 to this sequence number. And now we're going to copy and paste that. And in this case, if it equals 20, and we see the yellow button, then we're going to move 30 to it. And then if we see 30 and the red button, now we got to have that 1 second in there though. So we're going to need a branch here. Before I forget, that needs to be 40. And we're going to bring another instruction down. This will be a timer. And this will be red button delay. And then we'll bring down that. Look at the Q button. Or Q, you know what I mean. The Q thingy. And so John doesn't have to find it for me next time. We're going to put T number 1S there. And then we're going to have one final one. This one will be a little, actually, it's not even going to be different enough to matter. So we're going to copy and paste this. So actually, we'll copy this one that have the timer in it. Paste it here. Oops, paste it in the wrong place. And then if it equals 40, and we select the blue. In this case, we're going to put 10 back into it. That's going to be how we cycle back through this. So now we're going to need to put our outputs in. And we'll bring this down. EQU. And then it'll equal 10. Oops. I don't know how I got that down there. Take that out. Put that in. And we'll need a green light. So 10. 20 is going to be the yellow light. 30 is going to be a red light, and finally, 40 is going to be a blue light. You see the sheet. And all right, that's it. And guys, we are winding down here. Let's see how this one works. No, the other one on your computer.
Oh, the sheets. I was going to put them on the one.
Okay. So 14. And then download with project values. Well, uh-oh. Our final one, and yeah, there definitely is a problem because my green light's not on. What did I miss? Green light. Sequence number equals 0. Whoops. What did I do up here? Did I take it back to 10? I forgot. So there's 2 equals here. Did I do that? Let me see how I did this. Yeah. I forgot there's a bottom equals that if it's equal to 0, move 10 into it. And I have forgotten that. So last time, I think, actually no, because I'm going to show you a couple other things of why. Oops. Man, that's another time also we lost connection to the controller. We were going offline anyway, so hopefully it doesn't cause us a hitch. But we need a branch around that, and we're going to copy this. And we'll put it right there. Oops. There. That equals 0. And download. Yeah, Michael says the giveaway is happening soon, so stay tuned. You definitely don't want to miss out on that. All right, so we still don't have a green light. Oh, wait, we're not downloaded yet. Okay. Now. Oh, bad when you say now and you still don't have a green light. So I've done something wrong. Move 10. Oh, okay, copy and paste errors. All right, this is only going to be an issue one time, so I can't shortcut it. Man, guys, as much as I want to be done with this blue button should have been over here. So we're going to disconnect it one more time. That's why you got to take your time and make sure it's right. Yeah, I know I could use online edits, but a lot of you don't have a lot of you are using the free version, so I don't want to do anything that you can't do. So, all right. Try this again. And hopefully this time, when I hit the run button, we got a green light. Okay, so this one should work the same. Press the green button, yellow light comes on, press the yellow button, red light comes on, press the red button. Doesn't work. Gotta hold it for 1 second. Blue light comes on, press the blue button, and bam, we're back at the green light. Now, why do I like this one so much? So let's take just a few more minutes just to talk about it. Is mainly what happens on the others. Like, let's just pull one of them up. We got a few of them still open. Like the bit shift left here even. If all of a sudden I need to squeeze something in here, so I need to take and make .1 do something else. I've got to change this to .2. I got to change this to and I got to change this to .4. And I got to do the same thing everywhere that every one of these is used. I'll have to change it. Now, on this, it's not a big deal because we made a small program, but it's still going to be a tremendous amount of work. Whereas on this one, let's say that, what do I want to say? Let's say we want an intermediate step that requires, because we do have switch 1 we haven't used, that requires that switch 1 be turned. So where I want to put it, actually, I'm going to put it between the yellow and the red ones. So here's the yellow, and here is the red. So later on, we decide that we need switch 1 to be switched for this to happen. So I can go and just copy this wrong, make sure I'm on the right one, and now I can put 25 here. And I can change this to 25. And I have just inserted something in the middle of my sequence. I can select, was 8 switch 1? Well, what's 7? If 7 is, 7 is the blue button, 8 is switch 1. But yeah, let's take a moment. It should have a description on it. And so right there, I'll be switch. Oops, I want to spell that right over the last switch 1. And that's the one we're going to do. So now we can step there, but also let's talk about how we would add it on the outputs, because we've only had one condition. Let's just make it where during that step. So during this new step 25, I want to do. 25 will make all the lights turn on. How about that? So we go to our outputs, and right now, if it's equal to 10, the green light comes on. So we're just going to copy this, and then we're going to bring a branch down and paste that right there, and this will be 25. So now, highlight that, and we also want it on the yellow light, so we're going to hit a branch on that. And then we're going to hit a branch on this one. And we're going to hit a branch on this one. Okay, let's download this. I think Michael's getting hungry. He seems to be sighing a lot more over there. You got to feed him about every 2 hours, it seems like. And yeah, we're past this 2-hour mark, so he's starting to sigh. He looks like he's withering away and the wind's going to blow him away or something. All right. There we go. So now, let's talk about how this one works. So we have the green light. We press the green button, and the yellow light comes on. Now, we inserted something here, though. So now when I press the yellow light, all the lights came on. And then this still works exactly the same. Oh, wait. Oh, what's our condition? So, okay. I mean, I know it now. It just jogged my memory, but let's go see if we can figure out why this wouldn't run. Because before, I needed to do that next, and it doesn't work. And I said, what do? We sit here and keep pressing the button. Let's go in and make sure we can understand how to figure that out. So if we go here, and we come back in, then we can look at our sequence number. And we can see, okay, we're at sequence number 25. And one, I can look right here in our outputs and see we're at sequence 25. But now I know I can go to my sequence program, and I can look here and I can find where is it equal to 25. And okay, it's equal to 25 here, and I'm waiting on switch 1. So now I will go here and switch 1, and that takes us to our red light, which was our previous sequence. That still doesn't work unless we hold it for 1 second, and then finally press the blue button, and the green light comes back on. We start all over. So overall, this is absolutely the way that I think is the most versatile. I think it allows for a lot of flexibility. I think it makes it really easy for anyone, whatever brand PLC you're coming from, to understand. And also, we're using really basic instructions here that every PLC supports. So this would be my choice. But hey, what would be your choice? So what did we go through? Let's go over here to our Studio 5000. We can look one last time what we went through. So we had our basic counter, and I say this would be my second choice. And it's funny, this is what I did in my first program, 25 some years ago. And then we had this hybrid counter, this other version of it. And I think I would use it if it was a more complicated one, because mainly we can break it up. We don't have a bunch of branches. And then I would not use the seal-in. I mean, this hasn't grown on me any. So I don't think that one's a good one. I would not use the latch one here. I would not use the bit shift left, mainly because it's a very specific instruction to this brand. The move, it's right up there too. It would be top. It would be number 2 or number 3. I would not use this multiply. I think this is for people that are trying to brag about knowing how to do math. And then finally, yes, I believe this move is the most flexible one, and this probably is what I do, especially on something that I feel that we may end up needing to add some steps or modify. It just allows a lot of flexibility.
Next, let's learn about analog. Everything we've done so far has been discrete or digital or simply a 1 or a 0. And you can make a lot of basic machines operate just off of that. But as we get into more complex machines or we get into process control, we're going to start needing to use analog instrumentation or measuring a value instead of simply knowing if it's on or off. So we're going to learn how to program it. Before we do, most importantly, we're going to learn about how to wire various types of analog devices and how to scale them. For this one, the thing we need to know is first, let's just go ahead and bring the wiring diagram up. Now, this says wiring diagram right here. And if we click on it, then we are going to go up to, where is it at? Right here. We have the IF2, which I guess I jumped ahead there. I just went to Rockwell's site right before I hit the live button, search for the 2080 IF2, which is your analog input module in your trainer. And yeah, it says wiring diagram right there. And on page 5, there is our 2080 IF2. And it's showing that we have a I'm sorry, where am I even at? Here's where all of a sudden it's like, there it is. It's showing VI0, which is input 0 voltage, or, struggling with my highlighter, or CI0. That's going to be current. And that's what we're going to be talking about today is current, because 4 to 20 milliamps is probably the more common signal that you'll see out in the field. Now, we said it's a 2-wire or 4-wire, so along with that, we definitely need something to finish our current loop, and it's going to be the common terminal over here. Now, well, this is not knocking Rockwell's manual. This is every single manual. It's pretty much all the details you get about the 2-wire or the 4-wire part. So in addition to that, we need to know a little bit about the terms that are used. And so here's an excerpt out of our our student guide when you come to our class. And so 2-wire, current loop, passively powered, externally powered. These are really terms that are used interchangeably. And 4-wire, current source, actively powered, internally powered. Those are also terms that are used interchangeably. When I say that, you may go to one manual, let's say for your analog input, it may specify a 2-wire setup. And you may have a sensor that talks about a current loop, and you may have an isolator that talks about needing passively powered. Those are thrown around. They mean the exact same thing. Now, if they were using a 2-wire, that means we need an external power supply, typically 24 volt, and we feed the positive power to the positive of our 2-wire sensor. And then you go from the negative of that sensor to the positive of some PLC input. Now notice here, even to this one, I have it labeled as positive, but over here, we didn't actually have a terminal labeled as positive. Well, for the most part, and I hate to make a hard rule, but with few exceptions, the analog input, in this case, CI-0, is going to be your positive wire, and then your common will be the negative wire. So we would go to the CI0, and then we would come out of it, and most importantly, we have to finish that loop up. We have to come back around to the common of our power supply. Well, they were actually going to do the 4-wire just because it's slightly cleaner for this video setup, and we've got tons of videos in the weeds of 2 wires versus 4 wires. And so we're going to use our SIM ALP2 for that. And I grab it, and let's go ahead and power it up and go to current source mode. Then if we look down here, at the bottom in current source mode, it says our black post is going to be the common, and the red post is going to be the PLC input. And what that means is our red post is going to be the PLC input, which is CI0, and our black post will be the common, which is it is common. Black will be common. Now, PID-wise, look at our rows here. We have A row and we have B row. So what that's saying is B2, which will be the second one over, that's going to be our red. And then our common will be B3, which is the one directly to the right of it. So I'm just going to go ahead. I have it color coded here. I have a red wire coming off of the red post, black wire off the black post. And I'm going to put the red on B2, be the red. And then our common will be B3.
All right, and then we have a meter, and on our meter, whoops, actually, let me see if I probably can't even zoom in enough for you to see this, but it says pin 1 is input plus, and pin 2 is input minus. And so we need to wire that meter to our analog output. Now, if Rockwell is super friendly, then they'll just make it where I can change this IF2 to an OF2. I hope that works. Sweet. Okay. Now, if it hadn't worked, I would have just hit the search button. I could have typed 2080 OF2, which is that second plug-in module. And we can go to its wiring diagram. And if we go up to, here, then what it's saying is C0-0, which is going to be current analog output 0, is going to be on B2. Now, there's not an easy correlation to the common, but all these commons are, they're common. So we can take any of the A pins here, and we can put our minus analog on, and then we will put our plus analog onto B2. Now, to make it a little bit easier so that you don't have to watch me wrestle the trainer around, I've already color-coded the wires, and I have them over here. And so I have it where pin 1 on the meter that's up on the trainer is our red wire, and pin 2 is our black wire. So I'm going to take the black wire, and I am going to connect it to A2, which will be right there. And then in front of it, we have B2. There's where the analog output goes. So we'll put it there. And then we're going to go ahead and power up my trainer. And we're ready to start configuring some items in connected components. Now, I jumped ahead there because I didn't actually talk about what these thingies here are. But so the base unit here, this is the Micro850. It has 3 plug-in modules, and that's what these things on the front are. They're called plug-in modules. And so you would pop this blank cover loose, and you would snap that in. So your trainer ships with a 2-channel analog input, 2080 IF2, and a 2-channel analog output, 2080 OF2. And then you have one spare slot if you decide to add something to your tray. Now, you can also add modules to the right of this. Obviously, I can't right now because I have the power flex right here. But these modules that you add here are called expansion modules. So plug-in modules, expansion modules. And then let's go ahead and go into Connected Components Workbench. And let's start with a new program. And I'm just going to call this my analog video. Oh, I'm sorry, Jeff Kuiper. All right, so now I'm going to pause while I'm waiting on Connected Components Workbench and realize that there were a couple things in the chat that I probably should have nailed down. So let's just hit this really quick. Jeremiah, glad you're here ready to go. Hey, Mary Bruce. Hey, good to see you. Doug Baker, good morning. Jeff Kuiper, good morning. Hey, Ricardo. And all right, Jeff, I assume it was this PDF was a little bit small. And yeah, sorry about that. Yeah, there you go. There's a nice zoom in of what I was talking about. And you can just look at that one really quick. And then let me go ahead and grab that other one, because I'm sure that's the one you were looking at, because I think it's actually slightly smaller. Yeah, so let me put an I there. And then we'll get its wiring diagram. And yes, sorry, folks, I should have hit that zoom button. But what we did in the end is we connected B2, which is CI0, to the red post on our analog simulator. And we connected B3 to the black post, which is the common on the analog input. And then over here on this one, I just coincidentally used A3. I did not need to use A3. That is going to terminal 2 on our meter. And we are I connected it to B. Could I connect to the right place? Yes, I did. I connected it to A2, that's terminal 2 on our meter, and then B2, that is the current output. So, all right, after we got that done, we're going to go to controllers, and we have a Micro850, and we have an L 50E if you have one of our newer controllers, but look at yours because we switched to these about a year ago, and we have a 2080 L50E 24QBB. We're going to select that and add to project. And most importantly, because it bites me all the time, is before we do anything, we're going to select Ethernet right here, and we are going to enter the IP address of our PLC. And your PLC trainer is 192, 168, 110, and you have a subnet of 255, 255, 255, 0. Now, the trainer I'm using this morning is actually 44, and I'm doing some networking videos right now, and I do need a gateway on mine, so I am going to enter a gateway, but this is completely unnecessary on yours. And now we need to add our modules. So down here we have plugin modules, and we also have expansion modules. And the first time I tried to do this, it was so intuitive I couldn't figure it out. Oops, well, I accidentally did it that time. But I was clicking here and trying to figure all this out, and I couldn't figure it out. All you got to do is right-click the empty slot, and they're grouped really nicely. We have an analog module, and we have a 2080 IF2. Boom, we're done. It is that simple. They come in enabled, and they come in on current mode, so you're going to be good to go there. And then in our second slide, we have an analog module, and we have a 2080 OF2, and it comes in almost ready to go. Notice right here, output state disabled. We need to enable the output state on the analog output. So there's one little difference there. Notice this one's ready. This one, just got to hit that one drop down. All right, and it's ready to do some programming. So let's right-click programs, add, and, honestly, normally I would do most of my analog exercises in structured text, but since this is supposed to be the fast track and you're probably just learning ladder in your class, we're going to do a ladder diagram, and we'll open it up. And then we're going to bring down an instruction block. So bring it down and double click on it and start typing SC. And then right down here, we have a scaler. And this scales a real number with no output limiting. So we're going to select that. And we're going to start just putting in our values. So here's what we do a little bit wrong, and it stumps us, is first we need to we want to scale our analog input. No, first of all, before we even get there, notice you can't read these. What we want to do is we want to right-click on this white area over here to the right of our ladder and hit Properties. Oops. And apparently I had one of these undocked, so now you can watch me struggle for a while to figure out how to get those. Oh, wow, that never happens the first time. So apparently, let me do that again. But if you're dragging that around, then yeah, I ended up, well, now it works perfectly. I don't know why I struggle so much with that normally. But anyway, we want to click here, and all I did was right-click Properties. I would have got it here. And we have a cell width. Now, don't go crazy with the cell width. Like if I throw a 60 in here, notice that makes that entirely too large. And now we're going to be rolling back and forth for way the heck too much. But, if I put that on, let's say 30, oops, I meant to say 40 and a 40, then now I can read it. And that gets us where we need to be. Now, for our input, we're trying to scale our analog input. So I want to go find that analog input, and all of your all of your I/O starts with _ I/O. So that brings us into the I/O area. And so DI is for our digital input. Those are the ones we worked with in the previous video for our buttons and our switches. And then we have DO, that's what we use for our lights. And then we have, since we've added our plugin modules, we have an analog input and we have an analog output. And we want to select AI00. And we see right away we get a little triangle here. And if I hit the right spot on that, it says mismatch between assigned expression result, unit, and target of real. So it's saying that this is incompatible with this instruction. So with Connected Components Workbench, we have a data conversion block, and it is called literally any two, and then you specify what you want. So we need a real number over here. So I'm going to type, actually, let's widen this column up a little bit. That way you'll be able to read it as I do. We're going to type any, and then we have two, and that brings up all these. So here's how you convert any number to any other data type. And we need a real number here. So I'm going to select a real number. And then this, we actually want to put right here, because that's the value that we need to convert to a real. Now, we need to make an intermediate tag. Honestly, here's another reason I like to do this in structured text is if I was in structured text, I could just put this number, any two. You just end up with a lot of clicky, intermediate steps in this. But for this one, we are going to put our analog in. Actually, already I can tell you that's going to be too long. Oh, I mean, just for your reading purposes, I'm going to make this AN for analog in. And I'm just going to call it raw. And then I'm going to double click on the bottom of it because that'll bring up our creation dialog. And we want to look at this, but since it's an any2 real, it knows it needs to be a real number. And all we got to do is click the OK button and we're good to go. And now we can take that tag and we can paste it right there. Now, I'd probably say tag way too much in connected components because in Studio 5000, they are called tags, but in connected components, they're actually called variables. Tags and variables, in my eyes, mean the same thing. Okay, now we could put fixed numbers here, and typically, I don't know, I'll say 50-50 time. I see you either put fixed numbers or you have tags. So that we can understand what we're doing, I'm going to use tags here. So I'm going to make this our AN, and this will be our min raw. And just double click on the bottom of that, and it knows it needs to be a real. Now, another way I can do it, in fact, I'm just going to copy this out. That way I have the text roughly the same in this, is instead of me typing it and then double click, you can just double click on the bottom and it gives you a blank space, and then we can paste that in, and this will be our max raw, and it knows it needs to be a real. And then this one, we want to be the AM because it's still the analog input. And then I don't like that Studio 5000 calls this the EU, but EUs for engineering units, I kind of feel it's the output of the thing. But just to kind of make it similar, we're going to call it our EU. Our UN, EU. And then this one, we'll do similar. In fact, let me copy it because half the time I end up having a ton of tag inconsistencies in mind. Is we're going to paste that in and we'll call that our max EU. And so this now will be our scaled analog value. So I'm going to call that I'm going to spell this one out just because analog input scale. That way it's clear what it is. And since we're doing it on that, it knows it needs to be a real. Oops. Okay, why are you not wanting me to do that? Well, did I create it? Oh, I don't know what I did wrong. I did some fat finger there, but whoopsies. Okay, now for our analog output, we want to do almost the same thing, except we need to do the exact opposite. So let's go ahead and bring a new rung down. And let's copy and paste. So we're going to copy that. And we're going to paste it in. Because first, let's go ahead and take care of the easy. These are all going to be our out. So we can just replace our and in with and out through here. And yes, we're getting little yellow triangles. Whoops. We're getting yellow triangles as we go, but that's okay. I'll fix all those and if I can get this one to go, there we go. I'll fix all those in just a second. And now, I'm just going to double click on the bottom of them. And all you do is click the OK button. And what that's doing is just creating those tags for us. All right. Now, in this case, though, these are going to be swapped because we want to take a tag that we can understand and turn it into some type of value that our plugin module can interpret. So I'm going to right click and copy this one, and we'll paste it there to get us started. But this will be our analog output scale. And notice this will be a recall. And then on this side, similarly, we're going to have that data mismatch issue, but I'm going to use the same thing. So in fact, let me just copy this one and we're going to paste it there. And we'll call this our analog out raw. And we double click on it, and it has to be a reel for this instruction. All right, I keep doing something wrong. Somebody's going to tell me what I did wrong. That's twice I did. Okay. So now we need to get it to the analog output tag associated with that plugin module. But same deal. It's going to be the wrong type. And it says here that this is an unsigned integer. Now, if we actually want to go look at that, we can double click on our global variables. And here are those values. And right here we have IO, P1, and they're all unsigned integers. So we're going to use that same any2 instruction, but we need to make it one of these. So let's go ahead and bring down an instruction block, and we'll double click on it. And let's type any2, and let me go ahead and widen this column up for you. And we want this unsigned integer. There. So now we'll take the analog raw and copy it, and we'll paste it in. And now we'll go find the underscore IO and go down and find the, which I guess I didn't actually, I skipped over this one piece earlier. I kind of said that's the digital inputs, that's the digital outputs. And earlier we did talk about this, but EM was for the embedded module. And the embedded module is anything that is really wired to these top terminal blocks or these bottom terminal blocks. And in our case, the P1 is for plugin module 1, P2 is for plugin module 2. And we want to put this on that analog output. Okay, now that gets us enough that we can start playing with this online and mainly start figuring out what all these numbers right here need to be. So let's go ahead and download this program. We're getting a 21 in, and we're getting an NAN out. Now, the reason you're getting NAN out right now is because we have all these zeros here. And in this math that this is doing, we're ending up with a divide by 0, but they do a good job at handling that error. And it just says NAN there. So what I want you to do now is take your analog simulator or whatever device you may have to generate a signal. And yeah, I'll put a link to this down in the description. And we're going to select current source mode. And I'm going to bring this up to 4 milliamp. And then if we look at our screen, it's showing a value of 13,065, which is kind of like, do what? And so now let's go ahead and bring it on up to 20 milliamp. And we can see here it's continuing on up. Oops, accidentally let off the button. And now we're like 65,483. And I see these values in your program where you're just like, man, just please let my analog work. And if you make this analog work, then I promise I will never buy one again. You end up buying one again. This may be the most difficult part to figure out in studio, or when we're not in Studio 5000, in analog, because we've got to figure out what the world is being scaled here. Now, see this says Micro800 plugin module user manual, and hopefully this won't be so when you actually do this. This is not the Micro800 plugin user module, plugin manager. This is the Connected Components Workbench manual. This manual that kind of looks like somebody pasted it in later. This is the plugin module user manual. And so if we open it up, then let's just do a find for that IF2. And we'll find a few of them here. And man, the right module now. Oh, actually, I wanted that installation module. That's right. This one I should have mentioned earlier. It gives you some slightly better descriptions, I believe. No, it doesn't. This one does not give you any better descriptions on how to wire this. In fact, I think I like the manual that I needed a little better. But we want to go back to the wiring diagram, even though, I'm glad they called it a wiring diagram. It gave me what I needed really quickly, but also it's the specifications here. And in almost every analog situation, this is what you have to figure out, and it can be insanely difficult, is the input current range. We're running a 4 to 20 milliamp signal. The current range on is 0 to 20 milliamps. Now, some of them, the current range will be 4 to 20 milliamps. Some of them may be 3.2 to 21.5. There's a lot of different ranges, but this is kind of the magic number that you have to find that, I don't know, every analog thing that I run into, it seems like, let me go trudge and find this. So that is our engineering range on our module. And if we go over here, that means that these I want from 4 milliamp. And actually, no, let me go ahead and just close that out. And then our max will be 20 milliamp. And I know a lot of you saw it right beneath, but that way we can see how we can navigate really easy. So then we have to figure out this raw number. And like this little funkiness here, and it's kind of bouncing. But first of all, we know our analog minimum, it was near 0. And so now we got to figure out this maximum. Now, if you do any binary, you'll know this number right away. But honestly, a lot of people just know this magic number. In fact, my son was here earlier. We were talking about math. My kids were doing binary before they were in kindergarten. They probably still can tell me this number right now if they weren't in class. But I'm just going to bump this analog simulator up a little bit because its range is actually above 20. So we can go with up. Got a low battery warning. I might have to jump up here and run grab a battery probably. But I can bring this up to 20.1, which is out of this module's range. And now it's 65,535. So that's that maximum number, which is 20 milliamp. And notice it's saying infinity over here. That's because we still have a 0 there. We still can't quite do that math. But if I enter that maximum number of 65,535, then now it shows 20 milliamp. And let's just bring this down. Well, I'm bring it down to, let's say, 12 milliamp. And when we get there, my battery is dying. So, oops, I made a mistake here. So, now thanks. Upstream, awesome job. Man, I've never had that happen before. Why can't the rest of you do this? I'm like, hey, can y'all help me out with this? And look, I said my batteries were dying, and you notice a couple batteries show up. So I changed the batteries out, and I just spotted error while I was doing that. Okay, so now we'll power it back up. But I just saw an error because I sat there and told you, right, and I entered the wrong number. Let's go and understand why. I did it. Let's talk it out. So I'm going to go back to current source mode, and let's just put it on 4 milliamp. And notice at 4 milliamp, my value is wrong. And I have my raw values right. The range is 0 to 65,535. But when we looked at that manual, I still have it highlighted. The current range is 0 to 20 milliamp. So this number should not have been 4. This number should have been 0. And we're at 4 milliamp, and it shows 3.987, which is really darn accurate. So if I bring this on up, we see it going up as well. I'm going to stop around 12 milliamp. Whoops. There we go. And it's showing 11.987. And we bring it on up to 20. And it shows 19.98. So that gets our analog input scaled into 4 to 20 milliamp. Now, do not assume that our analog output scaling will be the same as our analog input scaling. Because, normally the other video trainers right here, but actually I have it stuck over there so I can't grab it. But on our Studio 5000 lessons, if you go through those, then we have an IE2C, a 1734 IE2C. Its range is double the range of the analog output sitting right beside of it, the 1734 OE2C. And so there's going to be resolutions. There's going to be a lot of things. I think sometimes it was just the engineers like, yeah, those numbers look good. Give it a full send on the manual. But look in each manual and figure out what that range is. It'll make your life a lot easier. So let's go back to our manual. We have the OF2 manual up here. We're going to click back on wiring diagram. And let's go down to that specifications. And yes, coincidentally on this one, our output current range is 0 to 20 milliamp. And in this case of the Micro800, in fact, I have to give hard props to Connected Components Workbench. They do a lot better job at sticking with the same raw range compared to some of the others. So go over here, and our raw in will be 0. Our raw min, our raw max will be 65,535. And then our output, I just told you wrong, guys. Our input is what we're putting into it. I'll put 4 to 20 milliamps here. Our input max, which is raw max, or max raw, it is going to be 20. Your analog, your engineering units, that's where the 65,535 is going to go. And so now, if I put 4 milliamp in here, that's 40. That would be bad. Put 4 there. Then we're getting some funky number out, but more importantly, we're showing 4 milliamp on our meter now. And if I put 20 milliamp into our raw, then our meter is now showing 40 milliamp. So that takes care of the basic scaling. Okay, now let's do a really basic instruction just to tie these together. And I am going to do it offline. One, because honestly, I'm not a big fan of the run mode change. A lot of you are running the free software, so you don't have this option. So I'm going to click where it says connected. And then we are going to tie, to start with, why do I have 2 properties? That's where I was dragging earlier. So we're going to tie these 2 together. And so I'm going to drag a rung right in between. You don't have to do it in between them, but just me talking this out, this probably will make our life easier. And we're going to bring an instruction block down. And, I should try to think about the future on this. So yes. Now for what I am talking about doing right here, we could go up here and we could type MOV, and we can bring a move instruction down. And we could move this value to here and tie the analog input scale to the analog output scale. But let's say we needed to do a ratio. Let's say that, okay, this is 4 to 20 milliamp, but I only want to get 4 to 10 or something out. We might need a little bit of a ratio here. So I could change this to a multiply instruction. And mainly, I'm going to make input to a 1. Now, arguably, Actually, let me leave that. I made the mistake. You're going to make the mistake too. Now, arguably, this just turns into a move instruction because this times 1 is going to be the same as moving that to that. And let's grab this analog input scale, right click and copy that. And then we'll right click and we'll paste it there. And then we want our analog output scale, right click and we'll copy that. And then we'll come over here and we're going to right click and we're going to paste there. And I'm going to hit the build button. That is the, right, you have disconnected and then we have a verify program and then we have a build button. I never noticed the verify program button. I always use the build button. What does this do? Does this just do the program? Is that like super faster? Let's try it. No, we're still building. I think they do the same thing. But, I'm surprised. Okay, and yes. So notice we have an error expecting a real variable type or constant. If we double click on it, then it's telling us right here we have an issue. These all have to be the same data type. It does not care what data type they are, but they have to be the same. And that does include constants. So this number is a real number. This number is a real number. This has to be a real number. Now, to make 1 a real number, we just change it to 1.0. And now, if I hit the verify button, I'm really curious now. I'm about to look up the difference between verify and build. That seems slightly faster. Okay, I'm not sure. I'll have to look that one up or play with it. All right, so we're ready to download this program. First, we have an NAN right now. I need to cut this mic down. I see one reason I don't always shove that mic over there is I can't see part of my screen because the mic's in the way. Need to do a bunch of rearrange, apparently. Okay, but why is it not a number? Because right now our analog simulator is sitting at 0. And this goes to kind of, oh man, I made a mistake. We need to go ahead and talk about this one too. It was even on my mind. You guys who are watching this later just made the same mistake. If you're following along, you also made this mistake. Is notice all our numbers went back to 0. It downloaded, what it was when we were creating them. So we're going to put those back in. So all our mens were 0. The biggest thing we needed to know was I still clicked them in. Our maximum raw value on our analog input was 65,535. And our maximum engineering unit was 20. And then on this side, our maximum raw value is 20. And our maximum EU is 65,535. And I will try to remember right after we talk about this to show you how to fix that. Okay, so now we're showing roughly nothing out. And our meter is at least dead right now because it is loop powered. So I'm going to power up our analog simulator and go into current source mode. And now, mainly we can look right here. Here's both of our scaled values. They're both sitting at 0. And that's going to start bringing that one up. And yeah, we've got, let's bring it up to about 12 milliamp. So we're at 12 milliamp. This says 11.98. This says 11.98. And yes, our meter is showing 12 milliamp. So we've just done a linear scaling or a 1-to-1 scaling between the analog simulator and that. And, we don't talk about this often. Might as well, since that way I don't have to sit here and hold the fingers on the button, is while you're in current source or any of the simulation modes, if you click the OK button, it actually brings up a menu. And we can do a sweep step or a custom profile. I'm going to do a sweep cycle. And I'm just going to run it at its default. And that's going to make it run up and down. And then, take it over here. We can see that, it pretty well runs right up and down with it. Now, also at any point during this, I can hit the pause button. That'll pause it. I can hit the OK button. That'll pause it. Hit it again, it lets off of it. And while you're in this, if you want to know exactly what's been going on, we can hit the OK or hit the down arrow or the up arrow. And that toggles between a graph of what's going on and the actual values. Now, we're going to use that in just a second because the next thing we're going to do is probably the most common thing you ask me to program is a lift station. So we're going to make our green light pump 1, and we're going to make our yellow pump 2. And I'm going to turn that off for now. And so first, we need to fix where we lost those values when we re-downloaded it. Oh man, I think I'm blaring you now, but I can't get this mic out of the way. Let me just bump that back. That way maybe I'm not screaming so hard at you. Yeah, because I'm getting warnings that I'm blowing your speakers up. There. How'd it sound? Now that we're an hour into the video, well, we'll check our sound finally. Okay, so let's talk about what happened there is since, when you download a program, there is an option to download the values that are in it. But since we had created all those tags, they create with values of 0 in here. So what we want to do in Studio 5000, we would just hit the save button and we would get a prompt now and it would say, would you like to upload the tag values? Well, we don't get that. And you would think that you want to right click here or something, but there is no way to actually do this. So what we actually need to do now is we want to disconnect. And then you want to right click the Micro850. In fact, let me open up the variables just so you can see what is getting ready to happen. Right now, mainly you see these project and initial values. They don't have anything in them. So I'm going to right click the Micro850 and we are going to upload. So we're going to pull the program out of the PLC. And right here, it says upload with logical values. This is going to pull the actual tag values, which is going to include that 20 milliamp and that 65535 that I forgot to put in. God, I don't know what's up with my properties. I keep getting 2 properties back, but I probably drug something somewhere crazy. Okay, now if we open up our global variables again and we go down, well, we're online now, so we could actually see the analog values. But if we go offline, if we disconnect, and then we go right back to it. Now when we look at them, we have project values. So this is the values that were in there at that moment. So when we download them, we have our option to download with project values or not. We hit download with project values. That'll put those back in. But all right, now we're going to turn this into a lift station. So first of all, I said that we are going to use our green light as our, I would use green light as pump 1. So I'm going to label output 0 as pump 1. And I'm going to label output 1 as pump 2. With a space there. Yeah. Okay. And so now what we want to do is let's go over to our program. And I just added this. Actually, we can leave that. That'll give us a nice display. Yeah, we'll leave. And so now what we want to do is we want to bring a new rung down. And so we're going to make what's called a lift station. Now, there's 2 ways that, a pump can pump. It can empty a tank or it can fill a tank. So we're going to be emptying a tank. So what we're going to do is we're going to make it where if we're coming up and we hit, let's say 4 feet, pump 1 will kick on. And then it's going to drain until we get to 2.5 feet and turn off. And then it'll start filling up again. It hits 4 feet, it'll turn on. 2.5 feet, turns off. Now, what if we're getting too much water in it? We may need the second pump. So in that case, let's make it where if it reaches 5 feet, pump 2 turns on. And we still want to pump down to 2.5 feet. So that means this is going to be our lead pump. This is going to be our lag pump. And we have a start setting for our lead pump. We have a start setting for our lag pump. And then we have a stop setting saying we're empty. Let's go ahead and create those tags. So we can just open our global variables up and you scroll down to the bottom and let's make a lead start level. And let's make a lead stop. Something I'm bad about this. This is how I used to see my program. A lot of you complain that you can't read it when I don't put some dividers in there in the videos. So I'll change that. Lead _ start _ level. Oh, and since I was getting in a hurry anyway, now that I slow down, I see I was getting ready to make a mistake. So since it's the level and we know everything else in what we've done with this analog is real, when we do our greater thans, our compare instructions, we're going to want a real number here. So let's go ahead and change this from a Boolean to a real. And then we'll get a lag start level. And we'll make it a real. And let's get just simply a stop level. Because once our tank's empty, we're going to be happy. And we'll make it a real as well. Okay, so now the goal is to kind of talk out, what do you want it to do? Because I just said I wanted to start at a certain level and I wanted it to stop at a certain level. Well, I have a way to turn it on. And so that's what you have to think about when you're trying to figure out how to program these lift stations. So first of all, we know 100% we want it to run if it's above our lead start level. Now we're just going to work on the green light right now because the lag should be similar. So we want to go in here and bring a compare instruction. And all of our instructions in Studio 5000 are, you can just drag down an instruction block. Then you can also go through here and find them. In fact, what we're looking for is a compare. It's right there. But if you're not sure about the navigation, then we can go right here. And there's the compares. And I struggle a little bit with shapes, but I'm really trying hard to not go to the logics theme. I'm trying to stick in our default theme. Is Pac-Man to the left is going to be greater than. So we're going to put that in, and that will be our greater. And if you mouse over to controls, you test whether one value is greater than another. And we have our analog input scaled. Now, is this going to be a level? I want to rename that. And to rename it, all I'm going to do is double click on the bottom part. And we're going to just name this our level. And since we do it right there, notice it also changes it right here. And I could change this one, but this is really just going to be for our indication. Also, kind of an important thing is don't assume that, remember, this is 4 to 20 milliamps still. I'm just imagining that it is a tank level. You would need to adjust these values for your particular level sensor. But this is going to work great for what we're trying to do. So now I can go and I can just type level, and I can go find our level tag. And this is our lead pump. So I'm going to just type lead start level. So if it's greater than that, we are going to go to our favorites, and we are going to bring down a direct contact output energize. And let's go grab our green light. Now we could do the _ IO and go hunt. But when you enter a value into this alias, you can just simply type it. So instead of doing that, in fact, it found it because I wandered off and I was already on it. We'll take that back out. But instead of that, I can type green. Oops, why are you not? Oh, because it's not green. I made it pump. I can type pump, and there is pump 1. And so there's another way. Okay, a little bit more about the formatting on connected components. You see how this is crowded right here? Again, right-click in this little right area here and go into properties. It's going to be your friend. Is what we want to find is our cell height here. And if we put that on 30, and then we go down, that spreads it out. Now, I'm pretty happy with that, but maybe you're not. We could change that to 35. Now, the issue is that it is doing it everywhere, so it is making everything taller, but you'll have to figure out that adjustment for yourself on that. Okay, now that gets us running, and I think we can talk through the next piece because I started to download that, but no, I think we're okay. So if our level is greater than our start level, our pump's going to turn on. Now, The moment it pumps down and gets off that start level, that rung is going to go false, and if false output energized, goes and writes a 0, and that light's going to go right back off. And so it's going to start filling up again. And what you're going to have is that thing's going to sit there and just on, off, on, off, on, off, on, off. And that is going to burn up your contactor, burn up your motor. If it's a big pump, you got all that torsional force, you're going to start snapping pipes. So there's lots of things that can happen. So that's why we have this spread usually between the start and stop. It's just to give us some more life. Also, if it's wastewater or, some process, usually slow and steady wins the race. So you want to kick a pump on and move it through nice and slow. And when you're about out, then you'll shut it off and let it fill up again and kind of do it like that. So now we have the stop level. This is one that can be difficult because remember, we don't have a way to turn the pump off. We only have a way to turn the pump on, correct? So this is what I talked to the people in the classes. Sorry, we said 4 feet is our start, 2.5 is our stop. So at 0 feet, our pump should not be running. And we get up to 2.4 feet, our pump should not be running. Then we go up to 2.6 feet, our pump should not be running. Now we're going to go on up, and at 3.9 feet, our pump should not be running. Now when we hit 4 feet, we want our pump to start running. And now when it drops down to 3.9, we want that pump to stay running. And what I always ask everybody in class is, okay, what was different between the first time that we hit 3.9 and the second time we hit 3.9? And I will see 90% of the time you fixate on, well, the level's going down. Okay, maybe the level's going down, maybe the level's not going up. We don't know what's getting slugged in from maybe some other pump station or what. But the thing we do know is that our pump was already running. And this is what we call a seal-in. And this is the basic seal-in that when you go through our electrical section, we do a hardwired seal-in exercise. Arguably, this is the same thing. So it's a way that we can remember that something has happened. So we're going to bring a branch down because we want this to run if it's greater than our start level, or. And when you hear that or word come out of your mouth, that's when we want to put a branch in because there's some other reason we want to run this pump. And so first we're going to have another greater than. Now, instead of dragging an instruction block this time, I'm going to go to the compare just so you can see it does the same thing. And greater than is going to be Pac-Man to the left. We drag it down. And this will be our level again. Oop. That should have just been level. And this time, it is going to be our stop level. And so the other condition is that the pump is already running. Well, we know the pump is already running because this has a 1 in it. So then we'll bring down our go look for a 1. That's the direct contact. And we're going to look at this. And so we can just copy it, paste it, or we can just go right here and we can type pump. And there is 0 wrong with having outputs on your go look for 1 or you go look for 0 or any input instructions. To the PLC, this is just a box that holds our 1 or 0. It could care less whether it's an input or an output. So let's go ahead and put this in and let's see how it works. So go ahead and download that. And while that's downloaded, where are we at over here? Hopefully the sound is better now. Yep, okay. Well, 100% okay. Hey, we got Timothy Gates, the PLC professor in here. That's always outstanding. If you, Tim, go ahead and put a link to your channel there. So he has a excellent channel, and yes, I highly recommend going and check his out. From the beginning, CCW has been confusing regarding project value. Yeah, and and that is one. And I guess I didn't actually show this because I've been popping over to the chat every time. And then this is kind of what Tim was talking about here is, are we just doing a download? Are we just doing a download with project values? Well, if we want those values that we uploaded as logical values when we saved it, we do want to download with project values there. And yeah, that has been, actually two things, going back to somebody saying, I can't remember who, everything's a pain. There are two things that I really feel Rockwell, if they would just massage a slight bit, it would really help with adoption. One is this logical values thing. I mean, make it when I hit the save button, that I can upload logical values, or make it even, somehow that I can just upload logical values, and maybe it's there, maybe I just haven't discovered it. The other is, every PLC program since we've had Windows, you can go communications, and there's some variation of who active right here that could get you online, upload or download. And that is not there. We had to go over to File and Discover to do that. And it's like, I might be able to live with you calling it Discover, because at least it has a semi shape that like that. But can we move it over to the communications where it's at in every other one? I think those two right there are probably the biggest things that, people come to the class. Once you get into here, they're like, oh yeah, it looks exactly the same. But not done. Okay. Now we have a green light immediately on. In fact, I should have shown something else we could do. Since we're talking about tags, we're going to go offline and do that again. Great. I love when this happens. Great comment there, Tim. We're going to go back offline. And because when I should have shown you before, but I can show you enough here. Our green light was immediately on. That arguably could be a bad situation, because, well, it is a bad situation right now, but our analog simulator's off. And while, this is just a simulator in a real plant, that means our level's 0. We're running our pump dry right now. We're burning that pump up. And so what we could do is, if we go and just double click on not our level, because our start level, we're going to add some values that at least we thought were going to be the values we needed. Now we can tweak them after. We're not hard coding them, but whoops. All right. Not sure what I think something's slightly up on my mouse is the issue here. What did I just do? We just double clicked on this. And so, we want to change our lead start level. We need it to be 4. We feel that 4 is going to be what we need to be. And then our lag start level, we felt should be 5. And then our stop level, we felt should be 2.5. So we can put those in. Oops, I didn't. I got by it. I thought I just made a mistake, but I did. Start level, stop level. No, it didn't. Okay. Now let's go ahead and download that. And we'll download that with our project values. And let's see. TA, I had to deal with a Micrologics the other day. Wouldn't let me online edit, and I guess some versions force you to download a new program each time. So the it depends on the RS500 software you have. Some of them are offline only, or not offline only. They do not have online editing. And I'm getting a little rusty on this. The RS Logic's Micro Starter does not, but I think Micro does. But there's a bunch of different ones there. And some of them didn't allow for online edits. But okay, we're back in run mode, and now our green light's off, because if we look at our screen, it brought in those default values, or those project values that we thought were going to be right. So now our tank is empty, and we're showing our pump on. I'm going to power up my analog simulator, and we're going to go into current source mode. I'm going to start bringing that level up. Now, I got a long ways to go, because, why is our level? Oh, no, okay, that's right. Yeah, I made a mistake. Well, I didn't make a mistake. This is our footage level. So even though I'm at 1.4 milliamp, right now, we're just making that 1.4 feet. I probably should have done some work there, but I didn't want to get too muddy on that. Okay, so here, 3 is not greater than 5. So this is false right now. And we see the blue coming out, means it's false. Now, 3 is greater than 2.5. Hush, I need to disable that sometimes, and sometimes it's good. And you can't see me pointing at the screen. But so the lower greater than is true. The upper one is false, but this instruction looks for a 1 at pump 1, and it has a 0, so it is false right now. So now we'll bring it up to 5. And so now 5 is greater than 5. That's going to be true. And this output energize is going to go right on to our pump. And this instruction right here is looking for a 1 in our pump. So now our lower branch is also true. So when I drop it back down to 4.9, this is false. We can tell it's false because it's blue there. And the lower branch is still true. That's our CLN. And it is true because we're greater than 2.5. And then we'll bring it back down. And when we get to 2.4, then our pump will turn back off. And that's going to be your basic lift station. So, in fact, you can go ahead and we can just hit the OK button. Oh, I didn't think about this. I didn't do a good job thinking about that scaling. That's all right. We're going to get a sweep cycle. And yeah, I'm going to change my start value to 0. Actually, no, we're going to change it to 2.4. That way it's arguably almost like your lift station would be doing. So yeah, we're going to make our start value 2.4. And we are going to make our final value, we're going to make it 4. Is that'll simulate? Oh, okay, a plan. It's, yeah, we're going to make it 4 because that'll be 4 feet. And so now, even though you would never simulate a signal like this out in the real world, it's going to work for this. So now I'm going to hit the run cycle button, and we can, oops, I need to make one change because actually we need to go a little bit above that. I didn't think about that. Our start value needs to be, start value, I did put 2.4 there. I don't think I did on this one. Our final value needs to be 4.1. Now we get slightly above it. And now we can go up and run. And so it's coming up. And it's 4 feet. Oops. Oh. Hey, I put the wrong value in. And even I was saying earlier, I think I did something wrong. This is supposed to be 4 feet. So if we double click here, what did I do earlier? I see what I did. Now we're going to go ahead and run with this here. We're ready to do the lag one too. I knew something was wrong earlier. I accidentally selected the lag tag for this one. It's supposed to be the lead tag. But okay, just so we can see how this would work before we go offline, fix it, and add our lag pump, I'm going to go down here and make our final value 5.1 to simulate it going up. And then we'll go back to our run cycle. And so it goes up. Yeah. Well, why is that? All right. I think it actually is. Let's just make that go a little higher. I think we're just dealing with it, blowing past it. Now if we go up, there we go. Pump kicks on, goes down, off, starts back up, filling back up. And yeah, we can just hit the down arrow and we can kind of get a little simulation of it, pumping the down, going up, pumping down. All right, now let's fix that. Let's add our lag pump to it. So we'll go back over to our screen. And let me turn this off because that light flash is driving me insane already. And so we'll go ahead and disconnect. And yeah, I knew I'd done something wrong early. But yeah, that should have been how that one was. So I don't know what I've done to make a second properties happen here. We're just going to have 2 properties for the rest of this live stream. And so let's copy this run because it's nearly the same thing we want. And then we're going to paste right here. And this you already saw it work. This will be our lag start level. And then we are going to make this pump 1, or pump 2. And we'll need to change this to pump 2 because this one is what we're trying to remember. And we'll go ahead and download that. All right, somebody had an additional question. We're getting near the end of this, and I said, don't let me forget it. I forgot what it was. What was the question? Somebody throw in the chat while we're checking out how this will work. So what I'm going to do now is I'm going to go to that final value, and we're going to make it simulate us running a good, not running behind. That way we only need the lead pump. So I'm going to make this 4.5 milliamp. And then we're about done over here. Oh, and yeah, okay, Tim is right. The Micrologic's 1100 and 1400 are the only ones that can do the online editing. And all right, so we're back and run. And so we will run the cycle, get that in where you can see a little more. So run cycle, and we see going up. All right, a pump kicks on, goes off, comes up, goes off. All right, so that is really how your basic lift station will work until it gets a surge of water. So now we're gonna simulate it having a surge of water. Is we're gonna make our final value instead of 4.5, we're gonna make it 5.5. And we'll bring it up to run. So now it comes up, pump 1 kicks on, pump 2 kicks on. Now both of them together can get it caught up and they both kick off. Pump 1, pump 2, pump down, and they both kick off. So that is your basic lead lag lift station. Now, the next question a lot of you want to ask me, and I'll probably break this out in some video because I would like to spend a lot of time discussing more of the maintenance aspects. With a lot of you, I got to do a pump alternator. And I always ask, well, why do you want a pump alternator? And everybody's like, well, I need it to evenly wear out, so we get more life. I'm like, well, no, you didn't get more life. You just made them both break at the same time. No, I know, they shouldn't break at exactly the same time. But you'd be surprised the times that I've been on a lift station, we pull one pump out and it's like, yeah, this thing's toast. And we go to test it with the other, just running off the other pump, and it won't barely keep up because it's near toast. So I'm not going to do an alternator in this video. No, it was the limiting. Yeah, so analog, we have a limiting issue, and somebody was asking even earlier about, well, why do you like structured tech better? Let's talk about that one. I've got enough time, and yeah, we should talk about that. So the next issue is really our level right now. If I just simulate a level of 0, well, this is a 40 milliamp signal. Our level arguably should be 0. And I'm going to make some changes here just to make this realistic because, now to make a lot more. Now I do need the scaling they were going to talk about is okay. We have a roll analog in. Oops, I didn't need to go offline for this. I just need to upload the tag values when we're done with this. You typically would not scale your engineering units for 0 to 20 milliamps. I did that so we could learn about how the 4 to 20 milliamp scaling works. So typically, we would have some 4 to 20 milliamp value off of it. Now, we could do some funkiness here, but honestly, here's where structured text just makes life so much easier. But what I'm going to do is we're going to simulate a 4 milliamp signal. There. All right. And this is not the right value. But here's what I see a lot of you do is you would just take this and put in your analog minimum and call that the min. And then you would go ahead and do some scaling. Now, should I go ahead and do this math? Man, here's where if I had the pause button right now, I'd do the math. But and in fact, somebody really good at math can throw that value out really quick. So what we need to make a ratio because we want 4 divided by 20. It's going to be 0.2 times and 65,536. I know this. 13,107. And don't ask how this number came about. We have a whole analog series that talks about that piece. For this raw analog min, I'm going to make 13,107. And then somebody even talked about a differential pressure transmitter. So, you can measure tank level coming down with, say, an ultrasonic or, many types of sensors. But another way is if you stick a pressure sensor in the bottom of the tank, then you can measure the pressure. And for water, there is 2.31 feet per PSI. And a really common pressure sensor is 0 to 10 PSI. So if it's a 4 to 20 milliamp and we're getting 0 to 10 PSI, that's going to make our range 0 to 23.1 feet. And so we're going to put in 0 for our engineering minimum. We're going to make our maximum 23.1. Oops, that's a little large. We're going to make our maximum 23. Oh my goodness. 23.1. Oh my. Well, maybe we are reaching the end of the live stream. There we go. 23.1. Okay, now the issue is if I start bringing my level down, my tank level is going negative. I don't have a negative tank level. And if I bring it up to 20 milliamp, I'm going to have the same issue. So we come on up. The maximum of my sensor is 23.1. Whoop. What did I do wrong there? Oh. Well, isn't that just interesting? Why? Folks, I don't know why I'm struggling so much with this one number. I mean, I guess y'all are probably looking at it like, Tim, you put the wrong number there. 23.1. I guess I should have erased it all and tried again. There we go. Okay. So notice our maximum does work. Now, let's talk about why the maximum works is our range of this analog module was, oops, that's the output module. We don't want input module. The range of our analog out was 0 to 20 milliamp. So when we simulate a 20, make sure you see this, if we simulate a 22 milliamp signal, then it's still going to be pegged at 65,535. That's all we can get out of this module. And so it's showing 23.1. But since the other side of the range is the 0 milliamp, then when we bring it down to 0, whoops. I was zoning out, didn't realize I wasn't going anywhere. There we go. We see we're getting into this negative range, and that's because our analog in is in below 4. So what we want to do now is we want to do a limit instruction. And if we go offline, then we do have a limit instruction. So if we drag down the limit and we double click on it, we have a LI limit. So notice it says limit integer to a specific range. Now, I don't understand why. I can't even figure out why. If anything, I would make a limit instruction that could only do real numbers. I'm not sure why this instruction even exists, but this is what everybody wants to put in here. But if we can't do a real number, it's not going to work. Now, we also have a high-low limit alarm. And that's the other thing a lot of people try to use. And this just gives you flags if it's above and below. What we want to do is if it's less, in fact, I almost said the statement, if it is less than 4 milliamp, then make our level 0. We need an if then, and that really just lays itself into structured text. All right, so I mean, we're here. Let's go ahead and do it because I did say I would not do this in ladder logic earlier. So let's talk about how we would do this. Let's right-click our programs, add structured text routine. I'm not going to do the whole thing, but if we just, if we, the right button, if we highlight the scalar and hit help, you can go through and you can figure out that this can work in function blocks, ladder logic, and here would be the part for the scalar. Now, all I'm going to do is really concern myself with this output because that's where all of a sudden it's like, hey, ours is not working right. And so I'm going to imagine that this instruction's in here just that way I don't have to type all that right now since we've already done it this way. And I'm going to make this level, I'm going to change this tag right here to level without limit. So all I did was just change the name just to help our lives when we get what we're getting ready to do. And now we're going to open up the structured text and we're just going to act like we had the scalar instruction right there. Arguably, I may not even use the scalar instruction, but you can figure that piece out. And so we want to, we have our, in fact, let me just go and stick it in there. That way we see it. We have level without limit here. Okay, now, right now that limit can go way low. So we want to say if the level without limit is less than 0, we want to write 0 to it. And you can almost just type this out. And yeah, there are arguably not great documentation files on this, but it is one of those structured languages a lot of people know. I'm not super strong at it, but I'm going to put an if, and then we're going to go parentheses, and then it's what do we want to compare? So level without limit is less than 0. And remember your data type here. This is a real number. So this needs to be a real number. So that needs to be 0.0, close parentheses, then, and we're going to call it level. So level colon equals level without limit. All right, now level colon equals, that's how you write something to somewhere else. An equal sign is a compare instruction. So, oops, and I was just sitting here talking away about that. That's not what we want to do, though. If it is less than 0, we want to write 0.0 to level, semicolon, which I forget almost every time. All right, now, while we don't need the max, let's go ahead and talk through how we would do the max. So then we can say else if. So if we're going to do this, else if parentheses level without limit is greater than. I always struggle with these shapes. It's the only thing. It is that way, yes. Amanda, you know, I can tell them from the 80s, yeah. The Pac-Man's eating that one. That's the bigger one. If it's greater than 23.1, because that would be the maximum of that level sensor, then, or close parentheses, then level colon equals, and we want it to be 23.1 semicolon. Now we need one other little hitch in here, because in this case, I kind of made that other intermediate tag just so we could talk through this. So that we're going to imagine that scalar is up here, but so I don't have to write all those words, we're going to put level equals, actually, you know, since we did it this way, we should do it this way. Order of operation. We never want that high value to get into our level. So if level without limit is greater than that, we're going to do that. So that takes care if it's out of range. So then we want to do an else. Else just means everything that didn't hit those criteria above, level, to create the tag level. Really, I created the tag level. I did not create the tag level. Oops. We want level, and we want its data type to be a real. And so else level colon equals level without limit semicolon. And we're actually, we're actually going to have to do this in our next video in this series. So this is a good primer on that. So did I forget anything? I don't believe I forgot anything. Well, I did. That's all right. We'll go ahead and cancel this as soon as it comes up, because I changed that one to level without limit, but I didn't put the actual level tag back in. Oh, and we have errors because every time I forget a semicolon, it seems like. And I forgot the end if. And here's where, but these are frustrating, and I hear, I hate structured text because I can't figure this out. Well, yeah, no, we just need to practice it a whole lot more. So I've been working really hard trying to polish up my structured text skills. The one thing I did forget is we did all that so that we could have our lead lag. These need to be level now. So we're just going to type level there. All right, let's just copy and paste that. So this will be level. And we'll come down. Probably did that in the wrong order. I probably should have created that and then changed the one, but this is kind of all on the fly. All right, we'll download that. Okay, so now, if we go over, we're at our program, and let's see if we can get this where we can see our level without limit Well, if I've been smart, I'd have done that. But, here's a good time to talk about the SPI list. Now, I do believe the SPI list may be the one feature that is not available in the free connected components that I use a lot. Maybe somebody look at their free version if you have it open right now, tell me. But we have these SPI lists down here. And I want to look at this level without limit tag. And I want to look at this level tag down here. And I want to see this logic happening all at the same time. So what I can do is I can go to Device, SPI List, Create SPI List. And that's going to give me a little undocked window. I could dock it somewhere. In fact, yeah, let's just throw this one down here for now. That'll work. I might should have docked it on the right, but that's not a big deal. And we are going to go find the tag called level. And we're going to go, level. What did I do wrong there? Level. Well, works. What? Control A. Well, it really wants me to put that lag start tag in. I'm not sure why. Level. Okay, you got me. Why can I not put the level tag? Well, here, since that one exists now, let's try to put let me just type it. Level. Interesting. I hadn't had that happen before. Well, now, okay, apparently you can put two of them in this. Oh, well, it shouldn't matter. I did create a different program. Are these localized to programs? They're not. So I should be able to work that. All right, let's try the other way. You can right-click the tag, and we can add a SPI list. All right, you got me. I don't know why I cannot get that one tag in there, but we'll go ahead and delete that one out. I'll have to look at that later. And right-click, we're going to add that one to SPI list. Good grief, all that so that we can see these two values. And right now, I did something wrong. Oh, I forgot to do that upload tag values. All right, so our analog, it's back at the wrong values. This is 13,107. And this one here, if I can type it right this time, 23.1. And we're going to current source mode. And okay, our level without limit is now 0, and our level is 0. Our level without limit is minus 5.7. So now as I bring this up, we see that our level without limit is changing. We're going to stay at 0 because our tank can't get below 0. Now, we probably should do some alarm on if this is in the negative, because that does tell us, we should 100%. Teach troubleshooting. Why am I not talking about this? If our level is below 0, that tells us either our sensor's bad, one of our wires going to or from our sensor is bad, we have a blown fuse on the power wire going to it, our analog module's bad. Something in our circuit is bad. That's why we're in a negative. So we 100% should alarm. You should alarm. I'm not going to alarm on this live stream here, because you guys know enough now that you could create that alarm. But now when I bring it up to 4, it'll start picking up and it'll run right with the level. So yeah, there's how we could add that limit to our program.
Okay, this next section is, in my opinion, the most important section. And also, it's a section that most schools completely ignore. And that is, how do you troubleshoot machines? If you didn't know it, we actually have a training center here. We do not teach how to program PLCs in this training center. We teach how to troubleshoot PLC-controlled machines. And so I'm going to give you some incredibly important nuggets here. There's not going to be a lot of action on your part, but these are important. This is important for troubleshooting machines, but this is also important for those of you who are programming PLCs to, as we're programming, to be thinking about these items and how will someone look at our program and figure out what's wrong with it.
Hey friends, today we're going to be talking about troubleshooting PLC controlled machines. And specifically, we're going to talk about why it's so hard to make videos on troubleshooting PLC controlled machines, why you can't find good machines to teach troubleshooting, why we shouldn't mainly, or why we may not should trust our HMIs, how we should react when it's a mechanical problem, why operators are so invaluable when troubleshooting machines, and finally, what are the repeatable steps to troubleshoot most problems? And notice I said repeatable, not the fastest, because if we can come up with a repeatable method, we can gain speed. But we put out a riddle yesterday asking, okay, how would you troubleshoot machines? And the answers were, honestly, the answers were not surprising. I know every riddle I have highlighted someone who gave the great answer, and there were no wrong answers. I made sure I was clear on that. But really, two people came really close to what I thought was a good answer. Well, actually, two of you nailed it right on the head, but you've been to my class, so you don't count. I'm very proud of you for remembering how to troubleshoot machines, but yeah, that was a little bit of cheating. Now, we have a different view for this because, we are going to be talking about this machine trainer. Well, in fact, if you haven't seen my class, I'll zoom out a little bit. Here's actually our classroom where we teach about troubleshooting. And this machine right here is the main machine that we use to troubleshoot. And so number one that I get from a lot of you is, can you zoom into the classroom? And my answer is always no. And even last week, someone's like, no, I'll pay full price. I just can't, my company won't approve my travel. And I'm like, no, it doesn't work that way because, gosh, and then you never prep right. Actually, wait, this one, I'm going to drive my screen over a little bit. And if you look here at this trainer, if I can figure out where to point, there's no wires on it. And the reason there's no wires on it is you have to actually wire these PLCs up and you have to find out, it didn't work. In fact, I don't think I've ever had anyone wiring work right the first time. So literally you've got to open up the manuals. You got to be able to figure out the manuals. You got to figure out, how to wire it. And then when it doesn't work, I'm just like, why doesn't it work? And everybody's like, I don't know. And I'm like, why did you put the positive wire there? And the answer always is, that's what we always do. I'm like, okay, but why do we do that? And so it's really difficult for you to zoom into something and see that. And you get your wire hooked up, and 15 minutes later, because you didn't get on the terminal screw good, all of a sudden it falls out. And you're like, it worked a little bit ago. Now it's not working. I'm like, why is that? And you don't realize it, but you're gaining a lot of troubleshooting skills in that little bit of time. So that's why it's really hard to teach troubleshooting online. Even this video, I'm going to give you some really good fundamentals to follow. But if you don't practice, then really they're not going to sink in at all. But also, really, this is why I tell you all the time, get it, use the simulators to figure out whether you're really interested in learning this, but get yourself some hardware as soon as you can, because so many of y'all are stuck in the software part of it. And also when you go to hook up a wire out in the field, you get your first, real job or project, you can't do it. So you need practice on those pieces. Now, this machine right here, actually, if, we invite schools. In fact, somebody this morning had put a comment, why don't you do a train the trainer? We train educators all the time. We work with educators, and they always ask, why can't we get this machine right here? How much does it cost? And I always tell them it's not for sale. And people are like, why don't you sell that machine? Because it's not about the machine. It's about putting you into a situation where you feel like you're right at the job site. And so that's what I'm going to try to walk you through today. Is actually walk you through our expectation exercise that we do with this. Now, a couple things is I didn't comment on many of your posts. I did push a few of you on, hey, how you really thinking through this, but I didn't comment on many of them. But there were some repetitive things that are about the same as, I hear when people come here is, I ask, how do you troubleshoot a machine? Well, I go check the HMI and see what it says. Now, here's the pitfall of doing that is most HMIs, honestly, even my first HMI, when I said I added diagnostics to it, it had the IO states, told you the e-stop was pressed, some real basic things. The idea that in 5 years, that linear rail was going to be worn out and was going to drop down and was going to start nicking the sensor and cause an erratic issue just never really occurred to me. So while we do want HMIs, we do want good written programs, that cannot be our only troubleshooting, is to walk up to the HMI and figure out what happens. Now, the other interesting one is you're going to find that I'm getting ready to tell you to do the exact opposite of what everyone out there said to do during this. And we'll get to that in a second. But first, so what do we do if we, because the other one is a lot of you said, well, I would study on the drawings and the program for a while and get real familiar with it. Well, the machine is down. Do you know how much downtime is per minute? In fact, I just did that, and small business manufacturing downtime. And we're talking companies that are probably just a little larger than, Amber and me. It is $150 to $450 a minute. So while, yes, we want to be as familiar with a machine as possible, we can't really tell someone, well, okay, let me come back tomorrow after I've had time to review. We've got to have some strategy about how we can go through an unfamiliar machine, which kind of brings us to this machine. This is the unfamiliar machine. And we don't do a lot of videos on this one because if I do videos on it, then it becomes the familiar machine because, before you come to my class, most of you have watched a bunch of my videos. But I am going to give you a peek inside the program and kind of how we work through it. But this machine here on Wednesday, you have to fully reverse engineer because we need documents, we need drawings, we need a program with descriptions. Well, there are no drawings for this, there are no program descriptions, and there is no user manual. So literally, they have to walk up and figure out even how to start this thing. And I'm going to give you a little peek into it because it doesn't take that much to figure out how to do it. We hit the green buttons, motor turns on, little valve opens up, little thing turns there. And we're just blowing a ping pong ball up. We're actually doing PID equations, all types of stuff. So there's a lot of troubleshooting abilities in this machine. But how do we troubleshoot it if we just get a call? Because a lot of us, we do field work, and we get a call from a customer. They're like, hey, I got a machine down here. Can you come help me? Well, okay, that's probably all the info we get. Which brings us to the really golden rule of troubleshooting is go ask the operator what it's doing. And it's funny, I know when people come to the class, because, by the time you're in my actual classroom, you've got some experience. You've probably butted your head against the wall. You've butted your head against operators, management, everything else. They're like, well, what's the first thing, you do? Should you talk to the operator? Oh, they've always gone to lunch by the time I get there. Well, send them off break. Go figure out what the machine is not doing. And you really need to become good friends with the operator because really, if you're good friends with the operator, they'll give you more in. If you seem like the guy that's talking down to them all the time, they're going to give you a lot less input. And this doesn't just go for troubleshooting. This goes for if you're making machine upgrades. I've made upgrades on machines and, I get there and I put them in and the operator's like, this is never going to work. I'm like, well, this is what management told us to do. And you guys put that in, one guy put that in the comment the other week. It's like, well, I get paid no matter what. I'm like, yeah, you get paid no matter what. But, if you are the one that goes and talks to the operator and says, hey, this is what we're planning on doing. And then the operator tells you, no, that won't work. And you go back and say, hey, I know we need to adjust this way. The industry's actually going to be much happier with your job. And you're going to get paid either way. But do you know what happens next time? They're like, hey, call Tim and get him to go talk to such and such and see how to upgrade this. Hell, we didn't even have to get a quote that time. We were automatically in. So talk to these operators, figure out what's going on. And the other one that I don't want to address before we get into how to troubleshoot is a lot of you said, well, it's usually a mechanical problem. And technically, Roy actually put it best on this one. He said, in my time of maintenance, I found it to be 75% of problems to be mechanical, including hydraulic and pneumatic, 15% to be electrical, and 5% to be program related, and 5% other. And here's the thing. If you walk up and you say, it looks like a mechanical problem, do you think they're really going to call you back? You're going to become that programmer or that technician or whatever you want to call yourself, that they're like, well, if it's a necessary evil, call Tim. But in no other circumstance should we even call him. Now, if you go out there and you troubleshoot, and okay, you're right, it's going to be mechanical. But, the HMI actually is going to say motor overloading. Who else are they going to call? Hey, Tim, I got a motor overloading. Can you come look at it? Well, yeah, the motor is fine. We know the bearings are locked up. But then you go out there and you find the bearings, get bearings out, and be like, hey, here's the two bad bearings. I mean, you just saved the mechanical technician so much time. They're going to value you. The manager's going to value again. And then it's going to get to the point they call you. Hey, Tim, go check out what this is. And so it's going to help you build a better relationship. All right, now we're getting ready to get into how to do repeatable troubleshooting. But yeah, let me see. What does the chat say? Because I haven't even brought the chat up. Hey, Christian, very nice to see you. Hello from Chile. Kevin Burke, good to see you. Glad you're looking forward to it. Philip McBride, yes, operators invaluable. Absolutely right. See, Bevan, yeah, I agree that operators know the machine. Yeah, and they do. Now, and that's, so let's just wait, because we're going to go to that in a second. See, Arc Living, HMI is about like a kid. Well, and here's the thing. You're right, Arc Living. And it's not the necessarily. Now, in a lot of cases, it is the programmer's fault. But I think most programmers at the level they're at have no idea how to truly troubleshoot an unfamiliar machine. And that's the key, because a lot of you did put in, well, I wrote this program and I put all this stuff in. But okay, how would you go troubleshoot someone else's machine? And that's the mindset you really have to put yourself in to write good programs. Because, we always say we help you become a better technician. Our training is for technicians. Now, we do get engineers in here. We actually get manufacturers of equipment in here that have to support PLCs. But they're not good candidates for our class until they realize, we got to support the technicians. I need to learn how to write better programs. At that point, they are a fit for our class. Before that, they're not really a fit. Excuse me. All right, Mark, are there any instances where the machine is missing a schematic? Almost always. And that's the funny part. When I put this post up, I'm not knocking. Yeah, I am slightly knocking. I can't lie. I am slightly knocking because it is experience levels. There's a lot of you are like, well, we always have diagrams. You have not been beat up enough in the field. There's not a single person that walks into this class when we go on Wednesday. What is it? Step 3. You can't even remember what step it is. But one of the steps is figure out what's wired to each input and output. And everybody's like, well, it's just another day at work. Because yeah, it happens all the time. We don't have wiring diagrams. The diagrams are old. Somebody did a retrofit. They didn't upgrade them. Somebody redlined some wiring diagrams and they got lost and we've had to go pull wiring diagrams that were on file that weren't ever marked up. It's common for us not to have that. See, Levi, let's see, nearly every machine in our plant is missing prints, usually the Micro800s with very few files. Yep. People who say, I used to try to but encourage people, if you're out there saying, well, I'll get paid anyway, you're not gonna ever, until you get past that point. I just wish you could realize how much one greater your career could be if you could get past that point. My mom's here. Hey, Mom. Let's see. Jace, I remember software for troubleshooting. It was odd to simulate an issue, but we're warning you out. Yeah, and you're right. And, simulation is very difficult. Yeah, and prints are very helpful. But okay, this is the expectation exercise right here that we do with the technicians. Zoom in a little bit here so we can get close on it. And I always start this off asking the technicians, did your boss send you here to learn how to guess? And of course, they all shake their head no. Now, out in the field next week, I told them, I want you to use the best guess possible. But this week, we want to think through the problem. And really, that's all they don't realize. It's the whole, and I know I'm dating myself by talking about The Karate Kid. Still one of the best movies ever. But the whole wax on, wax off philosophy, that's all we're doing here. Is we're really teaching them how to think through problem. And when all of a sudden on Thursday, and we're flipping switches on this, which I did mention, there are 40 switches on the side of this. There's actually ultimately about 130, 140 combination situation of breakdowns that we can simulate with it. But when we start flipping these switches, all of a sudden they realize, oh man, I can troubleshoot. I didn't have them come in on Monday. I've never seen the inside of a PLC. Teaching PLC program is easy. If somebody is really wanting to learn how to troubleshoot, I can walk them through that. But again, this is the expectation exercise. So I always ask, did you learn here how to press a button? Does anybody need to learn how to guess and press a button? Do you need to learn, how to do, any guesswork? And they're always like, no. So I said, okay, I'm going to press the E stop. And we walk up the machine. What are we going to do? And inevitably, about 50% of the time, one of the guys like, well, I always check the E-stop when I first get to the machine. I'm like, your boss did not send you here to learn how to twist an E-stop. And so the first thing is, what does the operator tell you is happening? And so I'm going to hit my button. And of course, it doesn't work. Now, here is the key to troubleshooting that honestly, only 2 people, besides my 2 technicians who've already been here, yes, I give you kudos, I am proud of you. Only 2 of you are really nailed down is what is the next step when it's not working? And here's what I tell them during this expectation exercise. Find the action item that it's not doing and start with it. Now, it's funny how really at this moment during the expectation exercise, it always still goes the way that every one of you is thinking out there. I ask them, well, what should we go check? And they'll be like, well, I think we probably need to check the green buttons. I'm like, do they do action? And they're always like, well, yeah, they start the machine. I'm like, no, they do not start the machine. PLC reads the buttons. Those are input. If it was an action item, the PLC would be magically making those buttons move. So what is that action item? Now, there's 3 action items. We've got our intake damper, we got our butterfly, and there's a fan right here. Now, here's the trick to doing it this way compared to guessing at the buttons. If you choose the wrong one, it'll lead you to the right one. Because I'm not gonna use anybody's post on this because I was really appreciative of how open everybody was about it. But one person said, and I'm paraphrasing, well, I would check this button and make sure it's working, and then I would have to go check this one, and then I have to check this one. It's pretty much a wild goose chase at that point, but usually I can work my way through it. And for a lot of us, that is how we're doing it. And even a machine this small, because I counted it up this morning. If you go off of input, there's 46 possibilities that could be preventing this machine from starting. And the issue is, if we check the green button and it works, then have we learned anything about the other 45 conditions? Have we narrowed anything down, or did we just figure out one and we're back at square one? Yeah, we're back at square one. Now, if we start at the action item, let's just pick this valve. Can you see the valve? Yes. So this red valve right here needs to open up. If we pick that valve, then we know for sure that valve's not working. If we go and we find that valve, we're going to be able to work our way back and figure out why it's not working. Now, here's where there's 3 sayings that people say, I say all the time in this class. And let me go ahead and switch over to my screen. Gosh, guys, I have my screens all in the wrong places because we're over here now. Screen, there we go. And so, this is the program right here. And immediately everybody wants to go and they want to open up a main routine. And I always ask them, why are you doing that? And they're always like, well, that's where I always start out at. And here goes to my famous 2 sayings that everybody says I have to have a shirt for is, take your hand off the mouse, quit scrolling. Because if we open up that program the way we just did, it's our only option is to scroll and only use our eyes to find the problem. Now, if we want to know what a value is in the PLC, and this is a foreign concept still for a lot of you watching this video at this moment, that output is a value. It is a 0 or a 1. It is not on or off. On or off are some other type of terms. Those are not in PLCs. We're looking for a 1 or a 0. If we're looking for a 1 or a 0, 1, 2, 3, 4, 5, or any value, a string, a word, dog, cat, kangaroo, giraffe, whatever, we want to start in the controller tags. You want to start in fact, I have never found a situation And again, we're talking about repeatability. Oh, well, I always just go to the input because it's always this one. I get that you can guess. But if we always follow these steps, we will repeatedly get the result. And then if we practice these steps, we can gain the speed. And so, yeah, we're going to go to our controller tags. So, if I can find my mouse, I'm going to get there, guys. Where's my mouse? Anybody see it on the screen? I really got to get my screen. There we go. We're going to open the controller tags. And then you're going to take your hand off the mouse. And that's it. You see already, because even here I'm getting worked up about it, because the next thing everybody wants to do right away is they want to start scrolling. Well, again, you're at the mercy of your eyes now to find this tag. Now, here's where it gets difficult on my programmers and my people converting from the software market, because you guys lecture me all the time because I make sure I sound it out with all of you what the tag is. And sure enough, somebody always says, well, if you make aliases, you could find that a lot easier. Here's the issue with relying on alias. Now, I love aliases. Aliases are great for a lot of things. If you don't know what an alias is, it's a way that we can name a tag without having to know the funky tag name that actually gets us to the wire. Now, here's a trick, and why you can't do that when you're troubleshooting is when they reverse engineer this, which the reverse engineering is the same as if we walked up to it. What are they going to call this red thing? Whoops, didn't do the zooms. What are they going to call this red? Because it's really interesting. This is, depending on the group, it can be called the butterfly valve. It can be called the red rotary valve. It's been called the intake damper. It's been called the exhaust damper because nobody knows yet which way this actually operates, but it gets called all different things. So nobody is going to be able to take your alias that you're sure is perfectly named and find it. Right now, all we know is this thing is wired to the PLC. And I can't tell you that, and this is, technicians, this clicks fairly quick with them. This is where all of a sudden you can see the software guys really struggle a little bit. I'm not picking on the software guys because actually we convert a lot of people in software engineering to our industry. They see the light and they realize, oh, if I learned this hardware stuff, I could actually do this. Really cool. But what does the tag name start with if it's touching the PLC? That is the one question that you guys struggle. It's going to start with low. And we have videos about the address and really specifically, so I'm just going to talk about the compact logics. In the case of the L18, the base is going to be local :1. And then, am I trying to tell that valve to open, or am I trying to read its position? We're trying to tell it to open, so it's going to be an O. So before we even think about scrolling, we should be going up to our filter here and type local :O. Whoops. And right there, local :O, data. And yes, this is the unfamiliar machine, so I have removed most of the documentation, but I did leave the butterfly valve in so that we could see it. Now, here is the interesting part for the ones that just love to scroll. And this is why everybody says I need a shirt to, tell you to quit scrolling. Because I will watch them at this point on Thursday, and almost always their mouse starts heading over here back to the main routine. And I'll tell them, take your hand off the mouse. And they're like, what are you trying to do? And again, they'll be like, well, I need to get the program open so I can go find it. Well, no. That's why we have my third rule, because, we take our hand off the mouse, we quit scrolling, and then we right-click and we're going to get options. And this is going to give you, Studio 5000 does an outstanding job of giving you options for exactly where you are. If you want to know where something is used in a program, then we're going to go to the cross-reference. And this leads us to the next one that most of you would probably agree with, is most of you are going to be looking at these XICs and XIOs right now. And it's the most common thing I get when you guys email me asking me, hey, can I come to your class and try to learn how to troubleshoot better? Is you're like, I don't know which XIO and XIC to go to. It's always a struggle. Well, the answer is neither. Because right now we want to know what is controlling the motor. And for that, we have this destructive column over here. And I really wish this was called read-write and we just had R's and W's, that would be a lot easier, I feel. But destructive means, can this instruction write to this tag value? And so we're going to double click on the destructive column. That's going to sort it one way, but double click on it again if we had a bunch of them. That's going to put all of our Y's together. And also, but do not put in my comments, go ahead and take your hand off the keyboard, because I know some of you are ready to do it. Oh, you're going to duplicate output. You can't do that. We had this PLC riddle several riddles ago. You can't have duplicate outputs on large programs. You will have duplicate outputs. So in this case, we're going to go to the first one. We're not going to think really hard. And yes, there it is. And just to make your life easy, I did label input 9. So now we would know local :1:0.data.9. We need to go troubleshoot that. Now, let's go ahead and walk through it one more step. Because, okay, let's say this was really complicated. I made sure to pick a rung that was fairly simple. When you get into the weeds, here's where my instruction style works better than most people's, or what you're taught. And what a lot of you come to me telling me is, in fact, I wish I should, I shouldn't use this for a PLC. I can't use it for a PLC riddle if I tell you, but I got a new PLC riddle, just came up with it. But a lot of you are going to tell me that this is a normally open instruction, or you're going to tell me it's an examine on, or if you're from some of the older logic, it'll be an examine if closed. This isn't. This is a go look for a 1. And the reason is because it's going to be looking for a 1, and in this case, it actually is an alias called SS. And if we mouse over, it has a value of 1 in it. So it looks for a 1, it has a 1, so it is true. Do not always trust the green on the screen. When insanity starts kicking in or your mind is spinning, start mousing over these and doing your truths. So then we can mouse over this one. This one is looking for a 1. We mouse over it, it has a 0, so it is false. So this is one issue. And then this one is looking for a 0, and it has a 0, so it is true. This one looks for a 0. It has a 0, so it's false. And this one looks for a 1. It has a 0, so it is false. So we have 2 conditions, and yes, we know that this one's it. But I want to go ahead and talk to you. I'm going to take you a little further through the run. That way we can just kind of understand how to narrow this down. So we're going to right-click it, and we're going to go to the cross-reference. And I can't tell you, here's one of those other times where I tell you, take your hand off the mouse, is people get here and they see this and immediately they want to go back to the main routine where they were and start wandering around. And here they go. They're going to start scrolling and they're screwed at that moment. Take your hand off the mouse. Quit scrolling. I'm not telling you this to be bossy. I'm telling you this because, anytime you do that, you're going to get lost. We know this is probably the culprit. It took us to this cross-reference and we really didn't like it. And here's the thing is, we may not like it, but it definitely is the culprit of our issue. So we've got to be able to just focus in and take them one at a time and eliminate all of them. And there's going to be one that's left that is the problem. And so, we're going to go back. And again, we're looking for something that writes. And where'd my mouse go? So we're at the destructive column. And we can take that a step further, though, because now we're looking for something that writes a what. And now we can move over here. We look, we needed a 1. Well, you don't know what this is if you haven't been into structured text much, but I bet you can take a wild guess what an equal 0 is. This is going to go right as 0. We have an OTL, and if you've watched any of my videos, that is not a latch instruction. Latches and unlatches do not exist in PLCs. This instruction, when it is true, will go right a 1. And when it's false, it does nothing. This is an output unlatch. It goes and writes a 0 when it's true. It does nothing when it's false. And same with that one, that one, that one, that one, that one, and that one. So before we even went anywhere, before we freaked out and went back here, we've taken all of this and we brought it down to this is the only place we actually have to look. So that's just a little bit on how we kind of teach troubleshooting in this class. And like I said, this is not the fastest way to troubleshoot, but this is the most repeatable way. And as you get into more complicated problems, it is the only way. And that is what's going to get you to that next level, whether it be the next pay level or get you into the big custom that you're looking for. That's really the big thing. Let's see. Let me see. Where are we at on this? Let's see. I did arc living about the check engine code. Yeah, many instances are missing machine schematics. Let's see. Yeah. Where is my... Oh, hi, Michael. Good to see you. Let's see, Mark. If the machine is truly unfamiliar, I would recommend looking on the label of the enclosure with the contact info of the company that designed the panel. You might be able to get a copy of the logic prints, and you're absolutely right. And here's where we've got to swallow our pride. I don't care if it is your most fierce competitor that you really do not like. Go ahead and call it. One, y'all may find out you can at least go to lunch, catch up a little bit, talk about some things. But yeah, we're a small industry. And if a competitor called me and needed a drawing, I would send it to them right away. Now, in this case, this is set up. In fact, I didn't bring a book with me. The narrative is this is a machine. The company was out of business and there was no proper documentation done. And so, yeah, you're having to work your way all the way through it. See, Eric Seller, I always try to find out how was the machine working properly. And this is interesting. Here's why, you've got to really put faith in your operators. And I do see management not doing this enough. As I walked up one day, it was a machine that, I've worked on many times. Manager comes up and they're like, so Tim, how do you think we could adjust blah, blah, blah? And I'm like, I don't really know how this machine runs. And I'm like, we always call you when we need work on it. I'm like, yeah, but it's always broke. I'm like, go talk to the guy who runs the thing. I have no idea how this thing's supposed to run. That's not to fix it. So yeah, the operators are incredibly important to you. Dan Stafford, I did have two people say, make sure you back up the program before you start fixing it. Modifying it. And I was like, why do you need to modify the program? And actually, I'm going to pick on my dad. He has passed about a decade ago, but mechanical genius. And I never could figure it out. If he had a problem, he'd start adjusting the program. I'm like, the machine was running last week. What are you doing? Well, something's wrong with it. Nobody changed the program. So, don't get me wrong, we do need a backup of a program, but we don't need to actually modify. Which brings up another point, because I do have a lot of, I won't say it's usually, because actually the head maintenance technician is usually not the one. It's usually someone further in management will say, we don't really want our technicians, editing the code. Do you have any alternatives that, wouldn't have that part? And I'm like, well, what do you mean? Do you want them to be able to operate a voltmeter, talk on a cell phone to the programmer? What are you looking for? And here's the thing. If you're worried about a technician messing the code up, your absolute best idea is to get them as fluent as possible in the PLC programming and in the code. Because then they're going to understand it enough that it's not going to be this magical thing. Two things that I really will light a fire under me, especially if you do it by Friday, is toggling bits and forcing. There is no need to do either of those in a program. But when people aren't really familiar with it, that's the first thing I want to do. If I could just toggle this bit, I know this machine would run. Okay, why is the bit not on that? And they're always like, well, I don't know. I'm like, well, that's what you got to do. Fine. But if we have them fluent enough in the ladder logic, then they're going to be like, oh yeah, I just need to go figure out why that thing's not on. See it. They use the cross-reference to find the destructive bit all the time. Yeah, and honestly, there is, we talk a little bit more in detail about it when you come to our training. There are times to look at the notes, and it actually is dependent on what you cross-reference. So if we just go back to where we were, oh gosh, if y'all saw where my screens are at here, because this is obviously is not the normal spot, so my screens I kind of just got them over here enough for this live stream. But if we go back through this again, we know here we needed a 1 in this box to make that valve open. And that's why when we right-clicked and we cross-referenced here, we went to the Y column to figure it out. Whoops, I went to the wrong Y column. Okay, I accidentally did this. We might as well go through it. People talk all the time, oh, you can't have duplicate destructive bits. Well, yeah, you can often. It's called simulation code. And here's why I tell you to pay attention to these green bars. There's your only little bit of indicator that this rung is not being ran. But obviously, here's the other insanity indicator is that, yeah, those aren't matching up. But we go back there and we go to this one. Everything can get to that. But yeah, when you go to cross-reference this one, we are looking for a Y. Now, what I always tell people is we're always looking to do the opposite of the instruction that we went to. So this right here goes and looks for a 1. So it is a no in the destructive column. So if you cross-reference a no, if you're cross-referencing an instruction that can't write, you're looking for the opposite. That's how we ended up on the Ys. But anyway, destructive. Levi, I wish it was called something else. So yeah, you may have missed the beginning of it there. This column right here is whether something can write to it. And I really wish this was called the read-write column. And then these would all be W's because they could write. And these would all be R's because they couldn't, because they could only read. But yeah, so this column right here is the key to troubleshooting, really, is this one right here. Because really, I don't know how many's here, but there's 20-some things. And especially if most of you, with what you said, you're going to go start and look at these XICs and XIOs trying to find out what's wrong. And you almost never need to look at them. In this case, we only needed to look at this one right here, and we would have found the problem.
Wow, y'all have got this far. That is amazing. First of all, if you hadn't already hit that subscribe button, then please do that. And if you're this far, you got to like the video, right? So now let's talk about PIDs. And, a little bit about what a PID is, because we kind of throw that term around, and then some people try to get too technical in the math. What I always say about a PID is its goal is, first, we have 3 items, really. We have a process variable. That is, what are we reading out there, such as a tank level of pressure or whatever. We have a control variable. That's something we're adjusting, like a valve, a motor speed, or something. And then we have a set point. And a PID's goal is to make its process variable match the set point, and it's going to adjust our control variable to do it. Today, we're going to be talking about preparing to do our PID control. Note, I did not say we're actually doing the PID control. And I originally was going to do a long PID video one. That's probably going to be like 4 hours. And I was like, yeah, I don't know if I have the stamina for 4 hours. I don't know if you have the stamina to listen to me for 4 hours. But what I noticed, most people, when they're like, yeah, I need to do a PID, they immediately drag the PID instruction down. It's like, that's got to be the first thing. I'm like, nah, there's a little more that we've got to work on before we do that. What I want to do first is prepare our control variable and our process variable. And so the process variable is that thing out there that we want to be at a certain spot. So, if it's an oven, maybe the oven's set at 350. So we're going to measure the temperature. That part we're measuring is the process variable. And then we're going to use something to try to get it there. And that's the control variable. Now, in the case of our trainer for this, we're going to use our PowerFlex 525. That's going to be our output for our control variable. And then the encoder feed on our 3-phase motor, that is going to be our process variable. So we're going to need to scale both of those, and we're actually going to control both of those over Ethernet. So we do have quite a bit of prep to do here. So we're going to go ahead and start with Connected Components Workbench. There's a long, awkward silence. Michael is in the room telling me I have a long, awkward silence. So yeah, while we're at this long, awkward silence, why don't you go ahead and hit that subscribe button down there. We put out at least 2 videos a week, and I've been trying to do a live stream a week. I've not quite gotten there yet because I have class. Sometimes we're doing a training class. Also, this week wasn't stellar class. I don't know why I just closed Connected Components. I sat there and did it during the live stream. This week was my favorite class that we do every year. I was over at the high school trying to, show a little bit about what our industry is about. Okay, Connect Components is open, so now we're going to hit New, and I'm just going to call this my PID prep, and Create, and then we're going to go into Controllers, Micro800, and then an L50E, and I have a 2080 L50E 24QBB. We're going to select it and add to project. And then most importantly, before you do anything else, because I've had 2 of you contact me this week about this, is click on Ethernet here. And instead of obtaining IP address automatically via DHCP, I really wish this wasn't the default option, or they at least prompt you here. We want to configure an IP address. And your default trainer IP address is 192.168.1.10. And then we can just hit the tab key, and that would fill in the 255, 255, 255.0 subnet. Now, this trainer right here is actually on 192.168.20.101. So I'm going to put that in. And then we need to add our Ethernet modules. Now, if you have the 2080 LC50, I'm sorry, not LC50, if you have an L50E, then you can have a little indented area here called modules. And this is what we're going to use in this one. We haven't done any videos really with the PowerPlex doing it this way. For all of our other videos, we've been using the user-defined function block that works with all of them. But this is a special area just for the Micro850s that have an E on them. So I'm going to click the Add. And on my device type, we're going to select the PowerPlex 525 EE net. So I'm going to select it. And I'm just going to call this my drive. And its IP address is 192.168.120.102. Now, the default IP address here on your trainer is 1.12. I just should have entered that first. So yeah, if you're doing this on your PLC trainer, it's 1.12 like that. And this one is that. And by default, keying is disabled. And so since keying is disabled, we don't have to actually enter a major or minor revision here. We're just going to leave it all at the default. So go ahead and click OK. And then we're going to add another module because we need to add our IO link module. Now, our IO link is a generic module. And I'm just going to call it our IO link. And for the generic modules, we know some information about it. And one thing I really love about this Turk is how intuitive it is to figure out. So I'm just going to go to my Start menu, and I'm going to open up Microsoft Edge. And I'm going to enter the IP address of the IO link module. And your default IP address is 192.168.1.15. Now, this one is actually on 20.105. So I'm going to go there. And then I am going to go ahead and log in. Actually, you know what? I need to log in to see this. Let's just try it without logging in. So what I'm doing is I'm going over here to the documentation, and I'm going to the Ethernet IP memory map. And okay, you don't need to log in to actually get here. And right at the top here, we have our instance size for our input and our output. And this is the data you need. So we're going to go back over here. And, before we do anything, we have to understand the COM format. Because you do have to select what format do you want this in. Now, I'm going to leave this as much at the default as possible, just so that we can learn how to navigate the way it would be out of the box. And so it says size in words. That means 16-bit or an INT in connected components. So the first thing we want to do is drop down here and select INT. And then we're just going to fill in those assembly instances and sizes that we see over here. So 103, 103, 104, and 67. Here, 103, 103, 104, 67. Okay, now we have a ton more to do, but we have a ton more to do. We're getting ready to have a learning opportunity. I didn't enter the IP address. That is, for your trainer, it's going to be 192.168.1.15. The Micro820 trainer in the training center is 20.105. I'm going to click OK on it. And then now, as I was going to say, we have a lot more to do, but let's download this
and just talk about a few issues that you could have and how to see them and catch them before we're staring at data trying to figure out why it's not working. So I'm going to go ahead and download this program. And what we want to look for here is that they are running. So I'm going to pop the cover off the PowerFlex and unplug its Ethernet cable. And now let's say in code 203, and this will be the most common one you get, connection timed out. And that means chances are that you entered the wrong IP address here. Also on this one, you could get something like connection point invalid. That would mean that you entered either the wrong assembly instance and size, or probably more commonly, can I double click on this while we're live? Yeah. More commonly, this defaults to dent. You forgot to switch it to end. So it's probably one of those things. But we look good. I'm going to plug the PowerFlex back in. And then let's talk about the drive control. So first, what we're going to do is, depending on where you're at, and honestly where I've been with this, I'm going to reset this PowerFlex 525, the main operating parameters to it back to its default. So I am going to get the B flashing. I know it looks like a 6, but that's a B. I'm going to hit the up arrow. That's going to take me to the P's. Then I'm going to hit the enter key. That takes us into it. And we're going to go to P53. And I'm going to set P53 to 1. And don't worry, when you do this, you're going to get an error. It's perfectly fine. We get an F048 error there. I'm just going to hit the red button, get us back where we were. And mainly now I can hit the green button on the front of the drive. And it starts. And the dial on the front of the drive is actually controlling the speed. Okay, so now let's look and see what we have in here. So and I know a lot of people are like, well, you didn't put a program in it, Tim. Well, sure I did. I just downloaded this. This is a program. Now, yeah, we have the ladder and structured text and function block programs, but we can learn a lot before we ever even add any of that. We're going to open our global variables. And then we're going to go down and find, no, the wrong way. We're going to go up and find our drive. So here's our drive, and it has outputs. And one of them is really obvious. That is your commanded frequency. And if we hit the arrow by the logic command, very nicely, Rockwell has put in description for us. So this tells us how we're going to start, stop, and all that fun stuff. So go ahead, and no, it won't work, so don't worry that it doesn't work. Just so we see, we're going to try to put a 1 into the start, and nothing happens. And the reason for that is I've factory defaulted this to make it where it runs locally. So P46 and P47 are the two parameters that you'll almost always need to change in the PowerFlex 525. And so I'm going to go to P46. So I'm going to hit the select key. The B is flashing. I'm going to hit the up key to go to the P's. And now I'm going to go down to P46. And 1 means operate off these buttons. We're going to take it to 5. That means operate off of Ethernet. And now, if we go over here and we check box, my motor does start. And right now, though, the speed command is still coming over our little dial here. And if we go and look into our drive :I, we're actually getting feedback on what our output frequency is, and we get some drive status bits, and we can see what they are right here. We got some check boxes by some of them, such as ready, active, and yeah, command direction and things like that. All right, now uncheck the start and notice it does not stop. And that's because you also have a stop bit, and that gets us stopped. So we have to put a 1 in the start to make it start. We have to put a 1 in the stop to make it stop. All right, that's enough that let's go ahead and make ourselves a little, we should make an HOA for this. So we're going to go ahead and disconnect. And yeah, we're ready to create a program now. So let's right-click programs, add, and we're going to actually, we're going to do some of this in ladder and some of this in structured text. Let's start with ladder. and double click on Probe 1. And one thing I did for this, this is the video trainer, but actually I'll work all the way across because we have the getting started wiring. And that gets us input 4, input 5, input 6, input 7, input 8. Switch 4, if you work your way across, I'm going to use switch 4, and that is going to be wired to 12 and 13. Now, that is not in your getting started guide, so you are going to need to add these. And if you're not sure about that, go back and look at the getting started video. But we have those already wired. So I'm going to go to my global variables, and their tags are going to be IO, EM, DI 12. That's going to be hand. And then IO, EM, DI 13. I'm going to make auto. And we'll probably need them more in the next video, but that'll also give us a spot where we can run this motor without going and toggling bits. So now we'll go into Probe 1, and let's bring a go look for a 1 down. And since we just entered those aliases, I don't need to know that now. I can just type ant, and that's going to fill it in for me. And you notice how this hand is just way crowded right here? You can adjust that. Now you have to be really careful adjusting that. Kind of wish they would add an auto sizing feature to connecting components. But if you will click over here in the white space to the right of your rung, that's going to bring up the ladder container properties over here. And you have a height. So we have element, cell height. And right now it's at 25. And if I make that 30, I'll space that out a little bit. Now it spaces everything out though, so you can get really tall in here if you get carried away. But yeah, 30 seems really nice. So then we're going to bring an output energize down, and we're going to go find drive :O dot, and we have our logic. Whoops, one didn't go far enough. .1, that is our start command. Okay, now we have this reverse coil, and this is not available in all languages. But what this would do is if this rung was false, it would turn it on. Now, I kind of go for the more super universal instructions. So what I'm going to do is I'm going to bring another rung down, and I'm going to use an output energize, and we're going to go for the stop. And we'll just copy this because the exact same thing with a 0 at it. That is stop. Okay, now see how we're truncated here? Got some dots in the middle. That's the same thing. So we click here and we go up. We can make our cell width 35. Oh, still a little narrow. The words are a little long there. There we go. Well, that's still, yeah. Yeah, let's go and go for the, there we go. We'll go big here. So so the question then is, and this is a fun question in the class all the time, is what should we put here on the left side of the start? And usually everybody thinks, well, yeah, I need to put a go look for a 1 for this hand. And I'm always like, well, aren't we probably getting ready to add auto? And they're like, yeah. So they'll bring another one of these down and be like, yeah, we're going to go look for a 0 in auto and a 0 for hand. And they're like, well, I don't know how many systems you've looked at, but I thought when you're in auto, the thing could turn on and off at any time. And, usually they're like, oh, okay. And so what I always ask them, I should put an alias on that. That's all right. You should go back and put something on this. I'm not going to this because we're going to mainly just use this to toggle it. But what I ask them after that is, okay, when do we want the motor to stop? And they usually gravitate back to this, but you actually want the motor to stop whenever it's not starting. So literally, we're going to copy this, and we're going to paste it right there. All right, let's go ahead and download that and just make sure it works. And shout. I got it. So this is the first 5 o'clock stream up I think I've ever done. Y'all are much quieter in the 5 o'clock chat than we'll say the 1 p.m. chat. 1 p.m. the chat's blowing up. All we got is Max and Brandon and Michael now to hold us through during the download time.
And what that thing with that? Oh, well, no, it looks good there. All right. Now, every time you download, once you have a controlled area Ethernet, you're going to get error 73. That's just because you took it offline, and all you got to do is hit the red button. It's ready to go again. Okay, so now if we switch forward to the left, give a little zoom here, then we should see, and we do, let me escape this where you can see. And so, yeah, we got speed. Now we're still controlling speed here. That gives us a convenient place where we can run this motor now, though. All right, so now what we want to do is we're going to go ahead and disconnect. And next, actually, I said that, and now we need to see that first. Let's reconnect. Sorry about that. And now we want to get our speed. Hey, Brad, how you been? And Jeremiah. Oh, you're just listening, Jeremiah? Well, hopefully it's good stuff. Okay, so now what we want to do, we have the start-stop going over Ethernet. We want to change our speed now over to Ethernet. So let's go ahead and hit the select key in the middle. That'll get the B flashing. We're going to hit the up arrow. That'll get the P flashing. And we're going to hit the enter key. Let's go and get our number inside the P and find 47. And we want to take 47 to 15. That means Ethernet control. And now, be incredibly, as in, really big here. I forgot if I had to zoom on. Incredibly careful, because default, the speed is 0. So if we try to start this, you may hear that little high-pitched noise. I can hardly hear it. But if you run this at 0 speed, it still is applying voltage, and that you're applying heat when you apply voltage. And that fan will not cool itself if those blades are not turning. So now what we want to do is we want to go find that tag. So let's go back to our global variables. And actually, we could go global variables. We also have drive no logic here. So we could right click here and go to variable monitoring. That'll get us really close to where it is. Because, yeah, it's the frequency command here. And I always ask people in class, well, go figure out how to operate that. And I'll tell them, give me 30 hertz on it. And usually we enter 30 in. And so then I always tell them, pay attention to the display when you do it. So if we switch forward to the left, we're getting 0.3. And so we need to multiply that by 100. So if you want 30 hertz, we're going to need to put 3,000 there. And now, if we switch forward to the left, it will come up to 30 hertz. Okay. Now, I don't want to work in 0 to 6,000 range. And I don't think anybody does. And it's terrifying, the systems I see that are working in some crazy numbers like that. So what I want to do is I want to make our motor speed based on percent. And so now we will hit the disconnect button. Let's see. Tony, I haven't worked with CCW. Are you not able to do online edits with it? Well, a couple things on that, Tony. So first, yes, you probably saw it while I was online. We have a run mode change button, but that only works in Developer Edition, and I try to stick with only what the free version offers, since there is a free version of connected components. So, yeah, I could have made a run mode change, and I'll have to say it's not very fast. It's not like Studio, but I would say 90% of the people are using the free version that are watching this video, maybe even more. So I'm going to go offline every time on this. All right, so now we're going to bring on down a new rung. And we're going to bring down this instruction block here. Now, we could actually go find stuff, but I almost never use these tabs. This is a really cool feature they have. I can just drag down an instruction block. I can double click on it. And then as long as I know what I'm looking for, I can just type it up here. We're going to find an SCL. That is the scale instruction. We're going to double click on it. And so our input is what speed do we want to tell in 0 to 100%? We don't have that yet, so I'm going to put in our speed command. And notice you got a little
yellow triangle in there after you just type those words, and that's because you just typed words. It doesn't know what it is. And in this case, all you got to do is double click either on that triangle or anywhere in this bottom section, and that'll prompt you. And most of the time, it knows what data type you want. So I do want a real number because I want to be able to enter a decimal in. So I'm going to click OK. And then we have in raw max, in raw min. So this is the range that I want the speed command to be. And so I do want 0.0 and I do want 100.0. And then we have the EU min and max. See, that's the engineering units. And Rockwell, I still disagree with you on this one. This is not the NEU max and NEU min. This is what we're getting out of it. But it's the same way as studio. So I guess I'm wrong. But so our output units are the engineering units. So I want 6,000. That's going to be 60 hertz. And our min will be 0. Okay, now this is the very important one right here to think about, is this limiting. If you make limiting false, then it will scale past 6,000 or past 0. So we could end up with 6,500 or 665 hertz, or we could end up with a negative hertz. Now, I don't want to do that. I want to keep them in range. So on the limiting, I'm going to just type the word true. I didn't have to create true. This, if you mouse over it, it was looking for a Boolean tag. And so I can just type the word true and it's done. All right, now the next thing we have is our output. And so that is where you want to put it. Now, what I'm getting ready to do will not work, but it's always a good lesson, is you think you want to go here and we want to go find that drive :O, dot, and we want the frequency command. And we have a little yellow triangle here, though. Mismatch between assigned expression type, int, and target data type, real. So this is going to put a real number out. This is an INT, an int or a 16-bit int. And so here's where we need the any-to instructions that we learned about in the analog exercise. So we're going to drag down an instruction block and double click on it. And you can just start typing any, and that's going to bring up all these any instructions. And this is an easy way to convert data from one to another. And we needed our drive :O dot frequency command. It needs to be an int. So we're just going to take any-to int. And so this, we'll right click and we'll just cut that out. And we'll right click and paste it here. Okay, so now, whoops, I don't know how I ended up with that, but that was bad. Could have been bad, but all right. So I'm just going to call this my speed command scale. And then I'm going to double click in the bottom here. And that's going to bring it up as a real. And all we got to do is hit OK. And now I'll right click and copy that. And up here, I'll right click and paste that. And then let's go and hit the build button, just in case I did something crazy there. I don't think I did, but honestly, about 10% of the time, I still get this wrong. So we're going to hit the build button. And it says build started. Hopefully it's not. I think it said no errors there for a second, but maybe that was all right. So yes, build succeeded, no errors. We're good to go. So let's go ahead and download that. All right. So now we should be able to put a speed command in. In fact, I probably should have put a speed command in just so I didn't end up accidentally run this. So I'm going to put in 25. Now that will be 25%, and 25% of 60 is 1500 hertz or 15 hertz. And that's how we see the 1500 there. And now if we switch for to the left, where it was, then we're running 15 hertz. So that gets us through our input scaling. I mean, our output scaling, actually. That gets us through our drive speed scaling. Now, there's a lot more involved in the IO link scaling because, well, we do have a video series on IO link, but it's not in this fast track series. So we need to slow down a little bit and talk through some things and make some observations. So if we go over here and go ahead, close this out and double click on our global variables, and we hit the arrow by IO:I, well, we have a lot of them here, and I do a lot of scrolling, and anybody who's been in class knows how I feel about scrolling. So I want to know, where is this encoder at in this? And here's where, just can't say how good of a job Turk really has done in their documentation, right? Built into this module is, if we scroll down, we're still on the documentation Ethernet IP. If you scroll a little bit, here's all the mapping for this. So where our encoder is wired to channel 3, and that means somewhere around 50, we should have some data that we should be able to see changing as this motor rotates. So if I go down to 50, no doubt I have some numbers here. And if I switch my switch, those numbers are definitely changing. Outstanding. Okay, now we've got to take these numbers and turn them into something back. And we got a couple of ways we can do this. Is, first of all, I went ahead and got the Xer out. That'll help you a lot. Is, if we look at here is how that process data is mapped. So in one of those cells, we have the multi-turn count, but notice we also have a couple of warnings along with that multi-turn count. And then we have the multi-turn position. Now, let's look at the multi-turn position first. So the multi-turn position, first of all, let's take and just rotate the fan just a little bit and see which one's actually changing here. All right, and we see that top one is the one that's drastically changing. So that is our position on this particular rotation. Now, if we go back to the Turk webpage and go to main, we can also read the data here. So if I click on input and go to channel 3, well, you see I got some funky data here. And then it's like, okay, how do I line this funky data up with that funky data? Well, I need some real known. So we're going to click on this IOD. I struggle with this acronym. IODD configurator. And now we need to log in. So we're going to log into this. And then we're going to go to port 8. Actually, I'm going to unlink this thing just so that we can be like we were. There we go. So this is what it looks like out of the box. So we got port 4, we got some process data, and now if I rotate this, we see that funky stuff changing. So in order to get this into something we can interpret, we need this IODD file. And so I've gone ahead and downloaded this. Now, one really cool button is you have the web search button here. That I have not found a time that hasn't worked on a really common device yet. I've seen a few odd devices it doesn't work on, but it does a good job. But also, you can download it right off the internet. And I already went ahead and downloaded this. And I'm going to select the IODD file and click open. And mainly that turns it into where we can see the actual process data. So mostly we have a position, and right now our position is 36,279. And if we go over here, neither of these numbers are 36,279. And this can get super duper confusing. Now, in the longer IO link version of this video, I kind of go into the weeds of why this is happening. But the main thing is how Connected Components treats this negative sign compared to what this is actually doing. So if you have a 16-bit integer, Connected Components, it's got it as an INT, and the range of an INT is a negative 32,768 to a positive 32,767. Well, this is expecting an unsigned number, so it wants to go from 0 to 65,535. All right, So I don't want to get too far in the weeds of that. What I want to do is just talk us through how to fix it and then see what difference it makes. So all we're going to do is we're going to disconnect. And in the longer video, I have a more elegant way to do this, but honestly, I kind of think this is still the better way. Is what I want to do is I'm going to bring a new rung down, and we're going to go look for a 1 down, and I'm going to call I'm not calling this any, I'm going finding it. This is IOLI :I bracket 50.0, because that was the first number. And then we're going to bring this down, and I am going to call this what am I going to call it? I'm just going to call it, because I can't think right now, position _DINT. And then I'm going to double click down here. Now be careful right here. Notice it wants to make it a Boolean tag, which arguably is right, but I want this to be a DINT. So we are going to select not a derivative, a DINT. There we go. And what we're going to do with this, now we're going to go ahead and select .0.
Yeah.
And now what we're going to do is we're going to right click and we're going to copy this wrong. I'm going to paste it 15 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And the main thing to understand here is bit 15 of an INT, which is what this actually is. Whoops, where do I have it? Oh, I don't have it here, but is the sign bit. Now, if we move this bit by bit over, then that sign bit will be in bit 31, and that's going to make those numbers line up. Now, a lot of you are probably like, well, can't we use like the mask move and do this in one fell swoop? Well, in the other video, we talked about the mask move does not work, or it does not exist in Connect Components workbits, nor does the swap byte command, nor does the bit distribute. So I did make something to kind of crudely do this. Then I urge somebody else to go ahead and finish it up and put it in Rockwell sample download. But right now, there's not a lot to binarily work through data. So all I'm doing is I'm going to increment each one of these, both sides, make sure we don't skip any, because I probably will skip one anyway. Somebody throw it in the chat, they see me mess up. But we're just moving this straight over. We're going to increment all the way. We should land on 15 when I'm done here. So 6. Whoops. Like, how many typos can I make here? Yeah, this should be a faster way, but until somebody teaches me it, arguably I made a slightly faster way, but I think this probably is the cleaner way to understand. You out? All right, Michael is out, everyone. That means dinner will be soon. I won't be getting, my food's going to get cold. Save me some food, man. All right. I have more to go. So I probably could have just scrolled and found these faster and typed them in. Let's see. Oh, yeah. Why didn't I do that? Y'all sitting here like, man, this guy doesn't know how to use the scroll well. There we go. Oh, now I'm picking up speed. I'm right here at the end, but I'm getting it now. Well, apparently that's not very accurate for me. That 13, and then 14. Oops. And finally 15 goes to 15. Okay, now just so we can understand what this actually did, right above this, we're going to add another rung, and we're going to bring down an instruction block and double click on it. And we're just going to grab an equals, and we're going to put link :I bracket 50 bracket equals 0, and then bring down another instruction block, double click on it also, and let's bring down another equals, and what did I name that? Position dent. And so now we'll look at position dent be equal to 0, and then bring another instruction block down. And we're going to type in OP, and that is a no operation. So all I've done is made this where you can easily look at these two values. And let's go ahead and download that. Kind of going back to what you're saying too, maybe I'll show one with online edits, but honestly, I don't know. Yeah, I'm not real happy with the online edits because I put its workbench, but yeah, it was right. You see here, the run mode change button. If you hit it, and then you kind of have the accept, test, and assemble button after that. Okay. So now, oops, not quite done yet. So now, notice negative 29,257, but this is saying 36,279. But if we go over here, 36,279. So by getting rid of that sign, which really all I did was make this a 32-bit number, that way the sign bit would be down on bit 31. That gets these two worked out. Now that's the easy one. The other one's a little more difficult. So if we go back over here, notice the data is not perfectly lined up in this case because we actually have 3 diagnostic bits in 0, 1, and 2, and then 3 through 15 are a multi-turn count. So what we need to do is take bit 3 of the other number and put it into bit 0 of some new thing. So let's go ahead and see, am I going to do this? Oh, no, I'm not going to do this all. I am going to click on it so you can see it. If I click the run mode change button, and we would get something like this. And once you make a change, then you'd have test changes, accept changes, or you could discharge. I was going to turn that back off and disconnect. And yeah, we're going to go down here and let's just copy that bottom rung to get us started. So we're going to copy and we'll paste it in the same spot. And in this case, we want IO link 51 because that's where that multi-turn position was. But we want number 3 because that's the first bit because those first 3 you have some diagnostics in them. And then we want to put this into, let's call this our turn, DINT. And then we'll double click down here. And I am going to make this a DINT, a DINT. And then we'll click into it and we are going to grab .0. I mean, this one takes a lot more precision because notice 3 is going into 0. We're going to increment all the way down. But mainly we want to copy this rung. And now we're going to paste it. So this will be 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so now we can go up here. Whoops. Nope. Yeah, get ready to scroll up and change all the rest of them. So now we're going to grab 4. In fact, I'm going to work down the left side first. 4, 5, 6, 7, 8, whoops, 9, 10, 11, 12, 13. Oh, why am I one short? I messed up somewhere. Did somebody see where I messed up at? It's not wrong. 3 up. There it is. Oh man, right at the beginning. That's all right. We'll drag this one down. let my drag work. Oh, there we go. And we'll make this one 15. I'll get one chance to do that. After that, the other side of that are going to be wrong. Okay, so then on this side, we're going to increment the number. So we're starting at 0. This one we're going to grab 1. This one we're going to grab 2. This one we're going to grab 3. This one we're going to grab 4. This one we're going to grab 5. This one we're going to grab 6. 7. 8. 9. 10. 11. There should have been a 12th one, I think. Yeah. Oh, I got another wrong. There we go. 12. Okay. All right, now let's download that and see what it does. Oh, we didn't. Oops. I did not put that in here. Next time we'll put that in there. But for this time, we're going to right-click the position depth and variable monitoring. And its value, oops, that's the depth. We want the turn. The turn is at 4475. And if we click over here, 4475. Okay, so now this is what we want to do is we want to convert this into the multi-turn position. Your count, that is the whole number. The position is the decimal. So if I could slowly get this, let me see how lucky I can get. I'm not going to try really hard, but if I can get, there we go. So if I can, you notice if I bump this, if I could get lucky enough to bump it just slightly. All right, we're almost, there you go. All right, we're not quite getting there. But this number will go up to 65,535. That is the maximum of an unsigned int. And so if you take this number and divide it by 65,535, that'll give you the decimal part. Now, here's the perfect example. I didn't want to do this first part. Oops, where am I going here? I didn't want to do this first part in structured text because you really cringe when I do this, but ultimately this whole thing should be in structured text. And so what I want us to do is we're going to try to walk through this in structured text so that you can start seeing, well, one, how all three languages have advantages. And this one really is the clear one because even here we had the STL, we had to do the any2 int. We're going to do a lot of these any2s and we're going to have a lot of intermediate numbers in here. And if we just write this out in structured text, life's going to be easier. So let's hit disconnect. And let's go right-click Programs, Add Structured Text. And double-click on Pro 2. And so we're going to call this our, what are we going to call this? Our positions. That was good. Yeah, apparently I did position depth before, so this will be our position. And then we want to right-click position, variable selector. And since we did just float in the midair, it has no idea what you want to do. So I'm just going to make this a real number because I want that decimal place. So then position, and then we want a colon equals. And that kind of tells it whatever you do over here, put the result right here. And first, let's hit the basics. So we had over here our position depth. That was kind of the position around that. So we're going to right click and we're going to copy it. And we'll go over here. And let's paste position depth. And this is not going to work. Don't worry. This is what I want us to walk through this. So ultimately, we would like to divide that by 65,535. Semicolon at the end, which I always forget. And we're going to hit the build button on that. See, Brad, what happens in CCW if you set a dent equal to an int? It will not let you. You're going to run into the exact same issue that we're getting ready to have an error right here on. So that's one thing about CCW. It's insanely picky about its data types. So colon equals must precede a real expression. And since I made the position a real number, everything in here has to be a real number. Well, how do you make 65,535 real? You make it 65,535.0. Now, with position dent, if we want to make it real, we're going to have to use those any two instructions. And so I'm going to type any, and we're going to find the any to real. And then we're going to open parentheses, and we're going to put that around that. So that will take care of that. Now, we're not going to download this, but I want to make sure it works, make sure we have no typos. So I'm going to verify that one more time. Well, hello, 1984. Good to have you with us. You get Michael to spec me on a faster computer. I need a faster computer, Michael, if you're still out there. Okay, so build succeeded. Yes. Yeah, you could do an any to dent. Now, in this case, now for what we're specific, yeah, that would have worked fine. For this specific case, we need this decimal because whatever this number is divided by 65,535, this is going to be a decimal. In fact, this will never be, oh, let me take that back. If this happens to be 65,535, it'll equal 1. Everything else is a decimal. All right, now that is just the right side of our decimal. I want to put the left side of the decimal in here also. And so the left side of the decimal is turn is the turn dent. So turn dent plus that. Now, similarly, this is a double integer. If we want a real number over here, we got to use a real number over here. So we are going to put the any to, I'm up against that. If you'll leave a space there, it'll fill it in for you. Any to, we want to grab that real, and then parentheses, turn down. Then close parentheses on that. And let's go ahead and download that because, yeah, that is going to hopefully, we'll actually test it, but I believe that's going to give us our total position. Oh, I didn't. I keep forgetting to put that up where we can see it really easy. That's all right. There's only one value. We're getting ready to go right back offline to do another. Maybe I'll remember it this time. Okay, this time I'm going to double click on my global variables. And we'll just go down and, whoops, it's right there. And there's our position, 44.74595. So if I did everything right, if I'm getting ready to click over here on the edge, we should have 44.74 in the one. And shotgunning, that should be about 34,000 in the other. And so, so I'm a little off on my shotgun, but so yeah, there's the 44.74. That's the number of turns. And that divided by 6553 is going to be that. So now if I switch one to the left, it doesn't run because I do not have a speed command. So we're going to put the speed command at 25%. And now if we run it, then this number is steadily going up. Okay, now that still is not good enough for our PID. And I think a lot of us get stuck right here because most of your exercises on PIDs are showing an analog in, an analog out. Well, in this case, we have an Ethernet out, but we managed to work that one out. But here, we're getting just a continuous measurement, but we need the rate of this thing. How fast is it turning? And so now there's a couple different ways we could do this, and we did a video kind of showing tons of different ways to do sample rates. I want to do the most basic sample rate here because, well, I think it's all we need for this. But depending on how this video is going, I may play with some different sample rates at the end of it. So we're going to disconnect. And while it's on my mind, this time I'm going to go over here. And in fact, we don't need this one anymore. I'm going to type position. And, whoops, that will still need to be there, but now it needs to be 0.0. And in this one, it doesn't exist yet. We're going to put our speed feedback. And we're getting ready to go figure this one out. So I'm going to double click down the bottom. It does need to be a real. So we're going to type in REAL, real. And now we need to go work this out. So honestly, I should know. So we have videos on how to do a sample rate timer in Ladder, and I'm going to go through exactly how to do that. So we're going to bring down a new rung, and I'm going to bring down an output instruction, and we're going to type TON. And typically, now this is one bad habit I see in a lot of your connected components workbench programs is you double click on the TON and you go to town. Now, what you don't realize happened in there is you just created a tag called TON_1. Now, when we're troubleshooting a machine, TON_1 is not going to help us. So we want to double click back on that. And you don't realize, but down here there's an instance. Name this something relevant. So I'm going to name this our sample rate. We know what it is. And now we're going to put our go look for a 0 in front of it, and it'll be really easy to find our sample rate. Whoops. Well, it would have been easy if I spelt it right. Dot Q. The Q bit is the dumb bit from Studio 5000. And we have videos kind of talking through this. And we're going to make this T number 1S. That means 1 second. That's one thing the connected components got right. We don't need to know milliseconds. We don't need to do calculations of hours. Actually, I'm going to change this up. Just in case there's a question and we want to play with the sample rate, I'm going to make this our sample rate, PRE. And I'm going to double click on it. And since it's connected to this, it's going to come up as a time. And in the project value, I'm going to put T number 1S. That's going to download it with that 1 second. And while I'm at it, I should have done that up here. So we don't burn our motor up. I'm going to go in the speed command. That project value, I'm going to put 25, just so it has a number, that way we don't burn anything up. Okay. So that means that this Q bit will be true for 1 scan every 1 second. So now we're going to go back over to our structured text, because I still firmly believe that this is a place where structured text works best, is we're going to use an if statement. So I'm going to put if, and then parentheses, sample rate. Oops. Oh, okay. This is a good learning opportunity. Notice we do not have that sample rate timer. When you create tags like we just did there, they go in as local variables. So if I double click on Prog1's local variable, there's my sample rate and there's the SCL because I didn't name it. We're just going to right click, cut that out. We're going to double click on our global variables, go to the bottom, right click, paste. That'll make the global variable, they're accessible anywhere in here. And we can go right back here. And now when we type sample rate, we have sample rate dot Q. So if sample rate Q, then, and in our then we're going to put, did I call that speed feedback? Speed? Yes, there it is. Speed feedback, colon, equals, and now we got to figure out what it equals. So what we're going to do is it equals position, we have that, minus previous position. Now we don't have that. It doesn't exist. That's why I had to type it out. Now this is a real, so we're going to make this a real also. So right click, previous position, and make instead a type a real. And we'll click OK. So every 1 second, we're going to subtract position from the previous position. And we are going to say that previous position, colon, equals position. Then to finish our statement up, we're going to put an end if semicolon. And let's go ahead and hit the verify button because I hit the download button. Now you got to sit here and watch me awkwardly wait for this to, I meant to hit the build button because I was going to say it. There you go. It's very easy to make mistakes when you are doing structured text while you're learning. And so, I have an error anyway. And that's what I was going for, was actually this button. That's the build button. It would have told me. So expecting a real data type, variable or constant. Where did I go wrong on that? Oh, speed feedback. Here you go. See, and here's where connecting components that's what I mean by just ridiculously picky. 0 will not work. We need 0.0. There we go. That'll fix that one. But all I wanted to do was hit the build button, not the download button. Anyway, so I'm going to hit it again just so let's see what result you should get. All right. And we got no errors. And no, we have no errors. And so we're going to go back to Prog 2. So what this is doing is if sample rate Q, this will be true 1 scan per second, then speed feedback equals position minus previous position. And then we're moving our current position to the previous position. So this is going to get the amount of change during that 1 second. So that's going to give us revolutions per second. And arguably, we could just run it like that, but just to get it kind of in more of what we're used to seeing, I want that in minutes. And to do that, all we're going to do is put times 60.0. All right. Now we need to go back to 4th grade. I don't even know when it was, but sometime back in probably elementary school, maybe middle school for some of us, we learned about order of operation. And so if we just put this in like this, then it is going to take our previous position times 60, then subtract it from our position. That's not what we want. We want to subtract position from previous position, then multiply that by 60. And so here's where we're going to need some parentheses. Did we get that right? And that should get us there. And this time I did remember to put these up here where we can see them. And let's go ahead and download that and see how that works. Okay, so now if we go over to Prog 1, then we have a position, our speed is 0 right now, and our speed command, our speed command is 25. So since I'm going to actually run this a little longer, I'm going to drop it down. That way the fan doesn't blow into the mic. I'm going to put it at 10%. And now if we switch forward to the left, then we are now getting our RPM. And get that out of the way. Now we're capturing our RPM. So that gets us where we can have our speed command out of our PID That's going to be in percent. And then we're going to get our feedback in RPM. We're arguably all ready to set up our PID now and learn how to auto-tune it. But along with that, we're going to need to probably see a graphical interface or a trend of what this data looks like. And so this has been an interesting one in the last 24 hours. As I posted that, hey, we're gonna talk about trending in Ignition because it doesn't work in Rockwell Automation's Connected Components Workbench. And so right after that, Randy Davis sent me an email and said, well, yeah, they put an add-on back in, so now it does work. So if you didn't know, trending was added to Connected Components Workbench version 11. And it worked fine to 21. And then in version 22, it just disappeared. And so I got thinking about it. It's like, well, do I want to just spin that around or do we want to stick with Ignition? Well, one, I went on there this morning and it was unavailable. So we are sticking with Ignition for that. But also, there were some really key advantages that, especially since we're starting to talk about PIDs and mainly start talking about things that we may need to troubleshoot years down the road and may need a good baseline. There are reasons that we probably want to do a little more long-term trend. And use Ignition, we can trend it to some type of SQL database or somewhere where we can come back and retrieve it later. The other really cool thing about doing it this way is we don't actually have to have the software to trend this. Now, it's not a big deal in the Connected Components Workbench because it is free. But if I was using Studio 5000 or TI Portal, then I can actually set up a trend to do some troubleshooting without actually having the software present. So a lot of good things there. And so if going back to our courses section, actually, let me show you one other thing. Now, depending on when you actually watch this live stream, if you go down to the bottom of our courses.twcontrols.com, there are some lessons in development. And so these are ones that we're kind of working to develop. Sometimes we're trying to see if y'all are interested in something, but eventually they usually get integrated into whatever lesson they fit with. So right now we're developing a series on into exactly how to download and install Ignition, and that'll get you to where we're talking about today. And so the first thing we want to do is in Microsoft Edge, in fact, close that out so we start fresh. We want to type localhost 8088. And that's going to take you to the configuration of Inductive Automation's Ignition. And the first thing you're going to see right here is we got an orange banner here and it says 2 hours went by. Not to worry, click to reset for 2 more. And so one I really love about Ignition is they let you get a full test drive of this for 2 hours. And when you want to try it again, you just got to reset it and do it again. So I'm going to sign in. And then it says reset trial. We'll click the reset, and that gives us 2 hours to play with this and learn about trending. And so then we're going to go to config over here. And then we're going to scroll down on the left side and we're going to find OPC UA and then device connections. And we're going to hit create new device. And this is a recent add to Inductive Automation's Ignition. So depending on how old your version is, you may need to download this driver, but now they have the Allen Bradley Micro800 driver. So we're going to click it and we're going to click next. And then we're going to give it a name. I'm just going to call mine the Micro850. And then your default IP address on your trainer is 192.168.1.10. Well, my PLC trainer that I'm using in this video is set up at 20.101. So you don't need to make this change, but I'm just going to change that to 20.101. And then we'll click Create New Device. And one thing I really love about Ignition is right away we know, is our connection good or connection bad? In fact, I'm going to go ahead and unplug our PLC. And if we give it about 30 seconds here, we should see this say something like faulted or reconnecting. I can't remember exactly what it says. back in. And that gets us going again. Whoops, I just realized, you gotta love when all of a sudden you decide to do your sound check. I just looked down and saw, well, no, we're using the right mic, so hopefully you've been able to hear me. Okay. So that's all we actually need to do over here. For the rest of it, we're going to go to the Start menu, and we're going to type Designer, and we're going to see the Designer Launcher. And we set this up when we were downloading and doing our first tag. So if you just walk through those lessons, you'll see how we get to here, and we're going to hit Open Designer. And then the login will be the same as you did before. Be HMI and HMI for me. And I'm just going to create a new project. And I will call this my PID trend. Oops, and just like Studio 5000, you cannot have spaces and tag names. So we'll do that, and we're not going to worry about anything else here. All right, and then back over here, just so we have some data, we're going to go and try to trend our speed command and our speed feedback because, I'm offline because I pulled the Ethernet cable. Okay, I was like, why am I offline? But so those will be two good enough ones so we can see what we need to see today. And so I'm going to go here and I'm going to make a new window and I'm just going to call mine main. It will be a main window. We're going to hit create. And then in the middle here on the left side, you're going to see the tag browser. And we're going to hit the plus sign by the tag browser. And we're going to browse devices. And then we'll open up the Ignition OPC UA server. Devices. Now there's the Micro850 I just added. And then we have controller global. And in here, we're going to grab our speed command, and actually I can hold the control key down and I can click speed feedback also. And we're going to put both of those over with this middle button here. And we're going to click OK. And immediately we're actually getting live data. So my speed command right now is 25 and my speed feedback is 0. And if I switch forward to the left, then we see our speed feedback start going up. And so right away, from a troubleshooting perspective, if I didn't have the software, I can gain a lot of insights just off that little move right there. But now what I'm going to do is I'm going to highlight both of these, and I'm just going to drag them over into my screen. You'll see your screen kind of turn yellow. And when you drop it, it looks like you did a right click, but it actually is popping up a menu option for you. And I'm going to make numeric labels for both. So we're probably not going to use these, but just so we can see them. So then, actually, well, if I'm going to drop them on the screen, then I probably should put a label by them. So up here, I'm going to grab a text field. We're going to drag it over, and I'm going to call this one, and I'm going to call this one on the text, I'm going to call it the speed command. Widen it up just a little bit. And actually, I'm going to make it a little while we're at it. That way that'll line up with that one. And then we're just going to right click and copy it and right click and paste it. So I have 2 copies of it. And we're going to call this one our speed feed. Oops, why can I not find the text now? There it is, speed feedback. Arguably, those will probably just be up there just in case we don't feel like the data we're getting ready to do is working. So now, on our right side in our component palette, let's scroll down and let's find our easy chart. And let's drag that easy chart over here. And we'll go ahead and make it as wide as what we have. There we go. And I'm going to kind of try to do this in the order that at least I find most people do it in. It's not 100% the correct order. is first, I know I want to trim these two right here. So I'm going to grab both of those. I'm just going to drop it right here. And right away, we can see our speed command and our speed feedback. And if we switch our switch, then nothing is happening here. Although we can see we definitely have data. And what's happening is this is pulling data out of our SQL database, but we didn't actually configure these to have what we call history. So we're going to do is on our speed command, let's double click on it and go to your history area right here. And then we're going to enable history. Now, one thing I kind of wish they'd do is this is not going to work right now. And usually you hit OK and then you scratch your head for a while. Is right underneath it, we have to tell it what storage provider do you want to use. Now, if you install Ignition in the order that we did in our Introduction to Ignition video, then it'll come with this sample SQLite database. Now, probably long-term, this is not a good database to use. You probably want, a database probably that IT sets up for you in some type of MySQL or Microsoft SQL server or something. And this is really good for just learning about it. So we're going to click OK to that. And so now we have a little clock right here by it. And that means that we are getting history off of it. And then we're going to double click on our speed feedback, go to history, and we'll enable it on it and also do that. All right. Now, the next thing is, in fact, I'm going to go ahead and hit the play button here. As you see, we have a solid line and nothing's happening. And right now you have to drag the slider to where you actually want to see stuff at. And by default on our easy, let's go ahead and hit the stop button up here and highlight it. By default over here, the chart mode is historical. And I mean, that allows you to pretty much do that. Drag it where you want and look at certain timestamps. But what I want to do is I want the real time. And now we can see that our time is actually ticking away at the bottom here. And if I switch forward to the left, which makes it run, then we're going to see our speed start. But notice how all of a sudden that red line just went haywire when we did that. It was nice and up here, and now it's down here. And that's because by default, this is going to set up for auto range because it doesn't know what range you want. Now, auto range can be useful sometimes, especially when you don't know what speed you're on. In fact, we'll probably use it in just a second. But when we're wanting to really look at two data values, we probably want these ranges to be fixed. Now, the next issue is we can see that the ranges of these two numbers are significantly different. So we really need two different scales on top of that because our speed command is in percent. Pretty much we're 0 to 100%. And this, we don't know the range of. I don't think we actually did that in the last video. So first, we're going to figure out the range of that. Is we're going to come here and for our speed command, let's put 100. And notice we get a pop-up right away because we are not in read-write mode. So it asks, do you want to enable read-write or do we want to write once? Well, just so you know where it is, we're going to hit cancel on this. And it's going to tell us, yeah, our communications was off. If we go up to project, here's where you switch between those. So by default, read-only is enabled. We're going to make this read-write. And now we can go right here and we can put 100 in. And now if I switch for to the left, let's see how high our speed feedback goes. So it should be right at about 3,600 RPM. And yeah, we're running, about 3510. So we really want the range of this blue line to be 0 to 3,600, but we want the range of the red line to be 0 to 100. So let's double click on our easy chart. And then over here we have axis. Let's click the axis tab. And here's the default axis, which defaults to 0 to 100, which is perfect for our speed command. But it also has this auto range checkbox. So let's uncheck that and then click OK. And now we can see that, all right, this shot out of sight of our range. Well, this one does look right. Now, you're going to look at this line right now. We're going to talk about why this line's doing what it's doing in just a second. Let's go ahead and fix this blue line first. So double click on your easy chart. And then let's get our axis and let's add another one. So we're just going to hit the plus sign on the axis tab. And I'm going to call this my motor speed. We're going to uncheck the auto range, and we're going to make its upper bound 3600. And now let's get back to the pins tab. And one, it can be a little confusing because if I double click on the name, I can't really do anything. If I double click on the tag, I can't do anything. And there is a button over I could use, but if you'll double click on the preview, that'll bring up its data. And mainly right now we have on our speed feedback default axis. We want to change that to motor speed. We click OK, and we click OK. All right, now that gets both of our charts working really nice. Now, if you stare at this a while, you're going to see that this line is never actually getting to where it is supposed to be. And I feel there should be another way to fix this. And actually, when we extract the data, which I did just rename the video before you got on. I don't know if you saw it, but we're actually going to extract this to Microsoft Excel. The data works fine in Microsoft Excel, but the issue is how our history is set up by default. So if we double click on our speed command on our tag browser and we go back down to our history, then the sample mode is on change. Now, arguably, I'm going to say that there's no exception for logging to a database on change is the best way to do it, because a lot of people are like, well, let's just make everything periodic, and they'll want to sample it 1 second. Well, especially a speed set point, it can never change. Or let's say on our PID, our desired value may never change. So there's no needing writing it and just filling up data every second so we can put it on change. Now, the issue is it knew when I set it at 25, and it knows what its current value is. And it's just drawing a line between those two spots. So on this particular graph, the way it is, it doesn't look right. Now, I haven't had time to really look at different ways to render it, but I figure it's a good opportunity for us to talk about the different sample modes. So instead of on change, I'm going to change it to periodic. And I'm just going to make it 1 second because that'll be plenty good for what we're doing. And click OK. And now, oops. Has it really been 2 hours? Why did my trial say it expired? Well, I have no idea. That'll think 2 hours went by. I'm not sure what I did. I think 20 minutes went by, but apparently I did something interesting there. But okay, now it knows exactly where it's supposed to be. And if we take and we change our commanded speed to 25, and then, whoops, I made it 25,100. If we try that again, we make the commanded speed 25, then it'll immediately drop down and we can see the actual data. Also, okay, well, since I did that little mess up there, now we know for sure that it was way out of sight for that little bit of range. But our goal in the end on a PID, for the most part, is to make some type of feedback match some type of command. And so right now, if I switch forward to the left to make it run, then we're going to see our blue line come up. And we're going to see that it's going to kind of park a little bit shy of where it needs to be. I think I can zoom in on that. Which button is it to zoom in? There we go. So yeah, if you hold your control button, you can actually zoom in on this graph right here. Or I mean on this tongue-tied already, on the screen. We can see that, yeah, this is kind of our goal. Is, hey, we have a steady state error. So we're going to be needing to examine these pieces right here. And that's going to get us to where we need to be for PID video. Now, while we're here, though, let's talk about a couple other things. It'd be really nice sometimes to take this data and look at it in Excel or something. So what I'm going to do is you have a save button right here, and we're going to click save. Whoops. Now you have to hit the play button so right now it's set up to let us edit it. To get it where all the doodads actually work, we have to hit the play button here. Now we can hit the save button, and that'll pop it up. And I'm going to put this, actually, let me put it where I can pop it out into, that's what's overwrite that one. So then what we can do is if I open up Google Drive, and I'm going to go File, Import, and I'm going to go Upload, Browse, and let's grab that chart. And we'll import that data. And so this gives us our actual values that we were seeing in that trend. Now, one thing while you're here, at first when you look at this, you're going to be like, well, it only gave me the date. But if we click on it, we see it's actually got the date and the time down to the second. It just did not actually get us this in our format. So I'm going to highlight the A column, and then let's go Format, Number. And right here, we can say that we want, what do we want? We probably want this one right here. And actually, you could do a custom date time, but this right here will get us what we need tonight. So now we know down to the second. Actually, this probably has to, let's go look at it. Let's go Format, and Number, and let's do a custom date time. How far can we get? Yeah, so we can actually get down to the millisecond here. Let's see if it actually, yes, okay, so here you go. This is data down to the seconds. We have the date. This is hour, minute, millisecond that it actually took this data down. And then we have our actual data. And so now what we can do is we can highlight all that. And across the chart, across the top here, we have a chart, insert chart. We're going to click it. And voila, right away, we got we have a really weird spot here. Why do I have a weird spot here? I wasn't expecting that. Remember, it was at 100, and I was trying to change it to 25, and I accidentally put these crazy values in here. All right, that was an accident. I'm just going to delete those rows out. And now if we go back up, and it looks a little better now. So now we can, examine this data and do whatever you might want to do with it in Google Sheets, Microsoft Excel, or anything like that. And it's funny, actually, I have to tell about another one. Several people have complained, we just want to know about the PID. Why do you keep telling us about everything but the PID? Well, all these things are important. And even in my class, somebody will I want to learn about a PID. And, I'll just sit down and be quiet for a second. And the first thing to do is they drag the PID instruction down. I'm like, well, what are you doing that for? It's like, well, we want to learn about the PID. I'm like, yeah, I know, but we got to do some prep first. So really the last few have been getting our data, being the process and control variable, ready for the PID. And the next thing we really need to talk about is the update rate. Like, how often do you want this PID to update? And I asked this question, and usually people are like, as fast as possible. And that's usually not the case. Now, there are some that can be super fast, but if, in our case, we have both of these controlled over Ethernet. So if we'll go look at it. Actually, let's go and look at it now. Our update rate, our RPI, which is how often this is updated, is 20 milliseconds on the drive and 20 milliseconds on the I/O link. So right there, and I don't know, some people argue whether you count that as 20 milliseconds or you add them together in 40 milliseconds. Anyway it goes, if we make a PID that's updating every millisecond, we're not going to get an actual response to whatever that PID is doing for 20 times of it doing it. So
I'm not going to get into what the update rate should be, because one really cool thing about this setup is we're going to be able to play with it a little bit, because we also have Excel and ESOL on the drive. You get all types of external variables that can be in there. But for ours, what I want to do is I'm just going to arbitrarily make it 500 or no, 200 milliseconds. And yeah, there's no science behind that, because really I just want us to understand how to do the PID so that we can learn about it. Now, we could put this into our main program and do some stuff and make it fire every so often, but usually you're going to see these, well, especially in Studio, it would be a periodic task. But in this, we're going to make a program that will fire every X amount of seconds. And so if we double click on the Micro850 at the top, we have an interrupt section. And right here, we can configure a program as an interrupt. So a little bit about the way the Micro800 scans is we have programs in here. Well, right now it's hitting program 1, then program 2, program 1 and program 2. And it's pretty much doing that just back and forth. And let's go ahead, let's go and rename these a little bit, just so for our slight sanity. I'm going to call this I'm going to call it our main, because I couldn't think of what to call it on the fly. This one right here is our encoder rate. Oops. Can't have spaces in names. I ought to know that. One of these days I'll learn that. There we go. And now let's make another one. So I'm going to right click, programs, add. And since we've done structured text and ladder in this series, this time we're going to use a function block diagram, which is arguably what I see most PIDs done in. And I'm going to call this my PID. Oops. And yeah, there are some kickers to the name. Since PID is an actual instruction, you can't use that. So we're going to call this our PID control. There we go. Okay. So the way this will work right now is it's going to run the main program, encoder rate program, PID program, and repeat. And it's just doing that back and forth. In fact, let's go look and see how fast it is doing that. We're going to open our controller variables. And then if we go down here, I got to go back online to do that. So we will not do that. I'll try to remember to do that later. But it's doing it incredibly fast as possible. But when we say as fast as possible, that's not necessarily consistent. So sometimes maybe it's 1 millisecond, sometimes it's 5 milliseconds. So with that variable there, it's going to be really hard to operate a PID. So now what we're going to do is we are going to go back to the Micro850 in the left pane, and then those interrupts, we're going to click add, and then we are going to select a selectable timed interrupt. And so what this is going to do is it's going to run a specific program at a specific time. So we're going to select the PID control. And yeah, I'm going to make that 200. And then there's an auto start button here. And I am going to click it because I want this thing to run all the time. Now, pay attention here to the PID control when I click OK. So we end up with that little red thing. And I think it actually says something there, but I've never been able to actually read it. And so that means this one is going to run at the selectable time interrupt. Okay, so let's open it up. And yeah, so this one looks kind of like a piece of chart paper. And instead of us having the instructions across the top, we have our toolbox on the right side. And let's drag in an instruction block. And then we'll double click on it and start typing PID. And you're going to see two of them come up. We have one that is similar to the MicroLogic's PID, and then we have the one with the auto-tune, and we're going to be using the one with the auto-tune, the IPID controller. We'll select it. And if you recall from our earlier video, remember how in this one, we had to widen this up, and it made everything ridiculously wide when we did that? One really nice thing about working in function block diagram is I can select this, and I can individually widen out these blocks. Now, we don't want to go ridiculously wide, but get this to where you can read all these words right here. And then we're going to start bringing in variables to create some items. Now, if I drop it right here, notice it just drops. If you drop it close to where it needs to be, it actually puts the line in for you, which is really nice.
So we'll go ahead and drag some in. And actually to start with, because we'll end up taking a few of them out, but to start with, I'm going to drag one onto every single one, and then we can talk about what all we're going to do here. Okay. So first we have our process. The process is that value that we're wanting to not that we're wanting to control. It's the observable change in our PID. So if this was an oven, the process would be the temperature. The output would be the butterfly valve or whatever is turning heat on it to that oven. So in this case, we already, from our previous video, made, if I can get to the right tab, because we just renamed them. Now it's called the main tab. We have the speed feedback, and that is telling us our encoder speed. So we're going to put that in right here. So speed feedback. All right, then we have a set point. We have not determined our set point yet. I'm just going to, no, one thing I don't talk about a lot, but I probably should, is if you click the top of the box, it's going to be a drop down that you can select or you could type. If you double click on the bottom, it brings up the whole thing. So I'm going to call this our PID set point. And it will be a reel. All right, now we have the feedback. We're going to come back to the feedback in a little bit. For now, I'm just going to delete that block out because we need to spend some time on it. Next, we have auto. I'm going to call this PID auto. And then we have initialize. Call it PID initialize. Oh boy, now you're gonna laugh at my spelling. I think that's right. Then we have PID gains. Notice as we're doing this, it's knowing exactly the data type that we want as we go. PID gains. Oop. Okay, same deal. Since there is a PID gains data type, we can't use that. So singular, PID gain. Here we go. And then we're going to have PID Autotune. And we have our Autotune parameters. Call it PID. Oh, now I'm really brutalizing it. PID Autotune parameters. Okay, now on our output side, this is what do we actually want to control? Now, we haven't really talked about it yet, but if you notice, only this one, compared to especially if you've been in Studio 5000, this is all there is to this. So we do need to think a little bit about the future here is mainly, would we ever want to maybe have a manual control? So while I could point this directly to, where is it? Our speed command, I may not want to do that. I may want to, in fact, we should have a handoff auto here to control that. So we'll build that out in a little bit. But for now, we're going to call this our PID output. Oops, and I forgot, need to hit the bottom of that. And then we have our PID error. And our PID AT warning. And our PID out gains. All right, that gets those roughed out. Let me pop over here to the chat, see what we got going on. Vernon, you work at TMB2? Yeah, in Northwest Indiana, installing remote I/O on Mill 2. Well, that sounds like a lot of fun there. Oh, look at there, Amber Wilborne. She's in the chat.
she's at home today. I was like, I cannot cancel this live stream again because it's been canceled for snow, canceled for a power outage, and yeah, we're both actually sick. So I was like, no, I'm gonna go ahead and do it. Austin, Vinyl Max in Hamilton, Ohio, working on an RO system. Yeah, that's fun. Mike Mitchell, MM Creative Solutions. Mike Mitchell, MM, I'm guessing. Very cool. Small business up in Ohio. Multiple water and wastewater projects with the Micro800. Well, this one's right up. That's you. Hey, Brad, good to see you. Brad has been here a couple times. It's the version 20 of Studio, so we are actually getting ready to do this in Studio 5000. You'll look forward to that. We got Doug Baker at Purdue Farms and working on an ignition project. Well, very cool. Jane Drew, River, Campbell. Oh, British, welcome from Canada. And working in the industrial automation and controls in North Island College. Very cool. And hey there, MB. All right. So now that we have this part done, let's talk about this feedback, because that's the next really tricky thing. So what it wants you to do is take your PID output and bring it around to your feed. And let me see if I can at least get that wide now. No, don't do this because we need to talk about it. That's kind of what it's expecting you to do here. But when I say that what you see is what you get, this is all there is to this. So what is our output range that we're going to be working with? So if we go back to our main routine, we have 0 to 100%. That's really going to be our speed command that we're controlling this with. Well, this thing will keep on climbing and keep climbing and keep climbing to 65,000 something another. So we're going to need to limit it. Now, this is important. In fact, this right here is by far the biggest issue I see with anybody that says that their PID does not work the way they expect it to, is we need to talk about data types and how a simple misstep in your data type can cause you a lot of headache. So I even said it, we need to limit our value here. So if I drag an instruction block in and we double click on it and I start typing limit, we see limit integer to a specific range. An integer is a whole number. So our drive speed is 0 to 100%. That means we have 50, or we have 49, or we have 51. We don't have any decimals in between those. And here's where usually somebody starts typing right away. Well, my process is not that critical. It shouldn't matter. Well, yeah, you'd be surprised the times that it does matter. So I'll have somebody be like, yeah, it always seems to be searching. And I'm always like, okay, is it like kind of sinusoidal? How do we pronounce that word? Is it like kind of ramping up and down, or is it like up, down, up, down? They're like, it's up, down, up, down. And I'm like, 100%. I know somebody has dropped an integer somewhere in there and you're having a rounding error. So that drive wanted to run at 49.3%. But since somebody put an integer in there, it's going to jump between 49 and 50, 49 and 50. So I don't know why, but there is no way in Connecting Components Workbench to actually limit a real number. But it's a great learning opportunity because we need to make a user-defined function block. And we arguably need to define what a user-defined function block is. Because one thing that a lot of you have asked is, how do you create routines inside of these? Well, you arguably can't create routines that run separately. But we can create user-defined function blocks. So now, if you look through the truth table of it compared to Studio 5000, they're going to call these add-on instructions. Now, I would argue that an add-on instruction is just a really pretty spin subroutine. So this is what we're going to do. Is we're going to make a user-defined function block to fix this. So let's right-click, add, and here's one of those times I know some of you grumble, but this one's probably easiest to do in structured text. So let's make a structured text one, and we're going to call this our limit real. And let's double click on our local variables.
And so we want to put in our minimum. Well, actually, no. Our first thing would be our input. And it's going to be a real number. And then it's going to be an input to our function block. Then we're going to have our minimum. And it will be a real. And it'll also be an input into the function block. Then we're going to have a maximum. And it's going to be a real. And also be an input. And then finally, we're going to have our output. And that will be an output out of our function block. And then let's double click on the lim reel, and that's going to bring up a structured text program. And we're going to do some basic if-then statements. So if, miracle if I get my syntax right the first time, but we'll see how it works out here. Grab pop up out of the way. There we go. So if input, and notice since I added as a local variable, it's there. Input is, and first we're going to start with greater than the minimum, and input is, oops, and I always forget all my parentheses. I need a parentheses there. Yep. And input is less than, and somebody will get on me if I don't do it. This actually should probably be a less than equal to, because I know somebody's going to ask if I don't do this. So if it is less than or equal to the maximum, which arguably means that it's in range, then put colon equals input. So if it's in between the minimum and maximum, we're going to make the input equal to output. And then we'll put a semicolon there. And then we'll put an in if. And semicolon there. And then we're going to do it again. So now we'll do if. And this time we're going to say if it's too low. So if input is less than the minimum, and in this case, output will equal the minimum. Oops. I always forget those semicolons. Hopefully I'm getting these right. Then we'll do an end if, and a semicolon. And now, we almost have the same thing. Say I'm going to copy and paste these three. I have no idea what just happened there. That's just weird. There it goes. That was weird. Oh, it is angry for some reason. We're going to save that. And let's open it back up and see what that. Well, my computer is like choking hard here. Okay, well, I don't know why it's choking, but let's go right back in. There it goes. That was weird. And so if input is greater than the maximum, then output equals the maximum. And then we end up, and by some miracle, let's see, I'm going to go ahead and hit the build button up here because it seems like I always leave out a parentheses or something. Home function. Oh, well, yeah. Okay, well, that's exciting. This is the only error I have because it's what I drug in. So now, since we've made a limit real, if I double click back on this, and earlier when we typed limit, we had that limit integer. Now we have a limit real. And so now we'll take this line out.
Actually, we're going to take this and shove it over here because we want to limit that drive also. So we're going to put that there. And then this will be the output to this. Yeah, you got to love how sloppy my... Well, come on now, line up. There we go. As you can see, you got to love how sloppy my function blocks get to be, but that's just not even on me there. All right, then we're going to put this here. Whoops, you got to watch out for that, though. See how sometimes that auto connect can hurt you. Put that there. We'll delete this one. And so now our minimum is 0.0 and our maximum is 100.0. So this is going to clamp our value. Now, see how these are truncated? I don't like that. So I'm going to widen that out. There we go. That's going to limit this output between 0 and 100. And now we're going to bring that back around to the speed. Do a great job. So we're going to try to drag that around a little bit more. Got it. Okay, so we have a speed feedback. We have a PID set point we haven't really worked with yet. And then we have our PID output. Now, the PID output's just floating in midair. It doesn't actually do anything. So now let's work on our handoff auto a little bit, because we already have it, kind of. If we go over to our main program, we already have hand operating our drive run. That was this one. And we need auto to operate it too. So we're going to drop down a branch here. And actually, we can copy this. And we'll paste here. And then we'll grab 13. So that makes it where it'll run in hand or auto. Now, right now, we have speed command. I just cross-reference it. Actually used anywhere. So now what we need to do is we need to have it run at a hand speed when in hand and grab that PID speed when we're in auto. Now, a lot of people want to put it right here, but I kind of say define your rung based off what the output does. So this has to do with our drive run, not our drive speed. So I'm going to bring a new rung down. We'll just bring it down right here. And yeah, arguably have the exact same thing that we have up here. In fact, yeah, we can. Well, we're going to bring a new branch down. And we can copy this. And we can paste it right there. Oops, didn't quite get it right. And then we can copy this. And we can paste it right here. And then, yeah, we're going to want to move instruction. So in hand, in the end, we're going to want to move. And this will be our speed command. And on this side, this is going to be our hand speed. In this case, it defaults to a Boolean. We want that to be a real because we want to be able to put 49.2 in. There we go. All right, so then when we're in auto, we're going to want to move. Right? I don't think that works in connected components, does it? So Brad just asked, can you control drag in connected components? And it does not work. I was holding the control key there. It should work, but it doesn't work. Oh, we could go ahead and try something crazy like the shift key. Nope, same deal. No, so we're copying and pasting. So copy. And we're going to paste this here. Oops, even then I pasted it in the wrong spot. Okay, so now, auto, we do want that PID output. So that's going to be PID output. Let me clean some of this up. Got too many tabs open in my brain now. I'm probably going to open half of them right back up, but let me get these closed. Okay. All right, so that takes care of our speed feedback. We're going to come back and talk about our set point here in a little bit. But all right, we have the auto, we have the initialize, we have the gains and the auto tune. Now, really, we want to focus on the auto, initialize, and auto tune together. And I got to tell you that this is not something that was super abundantly clear in here. But if we go to Rockwell's knowledge base, and when this does have an access level of everyone, so you can get to this one, QA 22011, it kind of walks you through how to set this up. And hopefully it's what we're walking through. But the one thing that was not really clear was this initialize and the auto. Let me see if I can find it really fast. Oops, we're already into the auto tune procedure. Mainly, where is, I may not even be able to find it fast enough. Let me just control F for it. That would be the smart thing. All right, so they have it during the auto tune. Okay, in this one, it was not super clear. But pretty much when you start this PID, you want to start the initialize. Now, we also have an auto tune we're going to have to deal with. And so when we're doing the auto tune, we're going to need to turn the auto tune on also, and not the PID on it. So it's going to get really confusing really quick. So let's just start dragging some stuff into our main routine and see if we can talk it out. So actually, I'm going to put these at the very top because really we're talking about this auto right here. I'm going to copy it. So one of our modes is we're in auto and we are not, and we need a tag for this. We are not, let's see, we're going to call it auto tune mode. Auto tune mode. So if we're in auto and we're not in auto tune mode, that means that we are going to be running our PID normally. Now, I could do some really fancy logic to do this, but I know y'all shun me a lot of times for using, or say I should not teach anybody about a latch and an unlatch. This may be the one time that I'm not sure that there's a cleaner way. So what we're going to do is we're going to bring down the set bit, and we're going to set the PID auto. And then we're going to put a branch around that. Oh, I won't let me drop it right there. Sorry, we can click the shape, drop it over it. And then we're going to bring another set down. Actually, yes, we're going to bring another set down and we're going to set the PID initialize. And then let's bring another branch down. Actually, you don't need to. We can just right click right here. See if I can get in this one. There we go, right click. Well, come on now. Apparently I can't aim good enough. All right, we'll just drag it. There we go. I was trying to show you an easy way. Now, in this case, we do not want to auto-tune because we're not in auto-tune mode. So we are going to reset or go write a 0 to the PID auto-tune. Now, be really careful. We're getting a lot of autos and tunes and all types of things. So that's one mode. Now, the other mode is if we're in auto-tune. So we're going to copy, and we're going to paste this whole run because it's almost the same. This right here needs to be a go look for one. Now, I can't remember who showed it to me first, but now Brad talking about amazing features. If you did not know this one, if I highlight this and I hit the space bar, you can toggle through the different versions of this. So there, we want to go look for one there. And if we are in auto tune mode, we don't want this in auto. So I hit the space bar. That takes us to the reset. And then we need to be in auto. Oops. So we'll come around to the set. So that is the combination of these three when we're in auto. And then finally, we have when we're not in auto. I'm sorry, that was auto and auto tune mode. Finally, what we have when we're not in auto. So we're going to copy this run one more time. And we're going to paste it in. And in this case, we can take the auto tune out. I'm going to hit the space bar on this for our go look for a 0. And in that case, we want to reset all three of these bits. So first we're in auto or we're not in auto. Whoops, I did the wrong one there. It's all right, we'll drag that up. I think I did okay in the end. I just put it in the wrong spot. So we're in auto and we're not in auto tune mode. We're going to turn on our PID auto.
we're going to initialize our PID, and we're going to not have the auto tune on. The other is we're in auto tune mode. We switch it to auto. We're not going to be in auto. We are going to set our initialize, and we're going to set our PID auto tune. We're going to need that in just a second. And then finally, when we switch it out auto, we want to clear all those bits out. Okay. So that gets us through that. Let's go back over here. So that takes care of the auto. That takes care of the initialize. We're going to come back to the PID gains because we need to use the auto tune to do that. That gets us through this auto tune, and that gets us there. Now, we are not done nearly, but we are close enough that we are going to go ahead and download this and see what it does, because chances are this is roughly where you'll get to. And well, you probably have downloaded 4 or 5 times by now before you ever found this video. But this is probably where we get to, and then we start running into some issues that we need to understand. So let's go ahead and download that. Now, immediately, and you need to be really careful, especially if you have an application like mine where the motor running really slow can overheat it, is let's go back to our main and let's see what our speed commands are going to be now. So we have hand, we have auto. We know our PID output we got to work on. But also, since we created this hand speed, notice that it defaulted to 0. So we need to change that. And I'm going to put it at 25. And now, if we switch it over to hand, our motor does run. Now, if I switch it to auto, then I hear the motor enable, but we are not putting any real speed out. Now, it's still putting some voltage on it, and that will slowly overheat that motor. So now let's look at our PID and see what we have here. So we see, in fact, look, here's where all of a sudden it's like, what's going on? See, it's trying to climb a little bit here. Now, we feel like and I know everybody happy, we need to auto tune this. Half of you aren't sure, but you feel like you want to put a speed set point in here and watch this thing go. And so let's do that. I'm going to put 900 in here. And notice our output starts going up. And if you wait long enough, it'll go up forever. Now I'm going to switch it over to auto. I hear it very slowly running, but it's trying. Probably should have let it go up a little further. Or I should have put my set point a little slower, but we're going to wait here. Now, as absolutely brutal as this is to watch, the PID arguably is trying to do something here. Now I'm going to switch it off, and notice it's still kind of just climbing there. And so this is going to be an issue. Now, I know how to fix this, but I don't want to fix it yet because y'all probably won't have thought of how to fix it yet. And honestly, I haven't seen it documented how to fix this piece right here. But we know we want to auto-tune it. So let's go back over to Rockwell's knowledge base on this. And let's talk about mainly this section right here. So what it's saying here, okay, so we pretty much have gotten it to this point right here. The PID control is fully functional. Now, notice this gain proportional point, or it's 1/10 of a thou, and integral is 1/10 of a thou. And actually our derivative is 0. That's what we're dealing with right now. So that's what it's kind of doing there. So if we open it up, those numbers are way the heck down there near 0. So we've got to get some numbers into that. Now, don't just start throwing numbers into it. Most softwares have some type of auto-tune now, and that'll give us really close to where we need to be. And so now we need to do the auto-tune procedure. So first it says make our set point 0. So I'm going to click my set point. I'm going to make it 0. All right, next, it says make sure that auto mode is not checked, or that it is a 0. Well, that's kind of what I was doing with this logic over here. Right. So if I check, so right now this has a 0 in it. that's setting the auto mode. But if I have my auto tune mode to a 1, that will not let that auto happen. So I'm going to right click auto tune mode, and we're going to toggle that bit, and that's going to get it ready for that. And then it says set all of the gains to 0. Now, one little hitch to that, and I assume it's so that you don't get super frustrated trying to make your PID operate, is if we actually go over here and double click our PID gains, try to put a 0 in here, it puts a 0.01, or it puts a tenth of a thou back in it. So that's as close to 0 as we can get following their instructions. Okay, now this one right here gets a little tricky. So it says, set the parameters for the auto tune. And we have the load, which is the initial value. This is pretty much what is this thing going to run to start with? And then we have the deviation. Now it says in this case, it'll be calculated later. And then we have a step. And there's a lot of different philosophies on this step, and I really would prefer you kind of play with the step a little bit to learn what works best. And then we have the time that we're going to allow it to complete this auto-tune process. And then we have the AT reset. Leaving marked at end of auto-tune process, the output, the IPID reset. I really have read this and read this and read this and read this, and I can't really figure it out, but I can just tell you we need to check this box right here. So we're going to double click on our parameters, open them up. And yeah, so first we have our load, and I'm just going to put this at 25. That's just, oops, lost my mouse. I'm going to put this at 25 because really, part of our goal here is to get this to the point that we can play with enough to learn about these different parameters. All right, it's said to wait on the deviation. We'll wait. And then we have our step size. I'm going to throw 20 in for not a lot of scientific reason. And then for our dynamic set or auto-tune dynamic set, whatever that is, I'm going to put 600, and I'm putting that in just because Rock will put 600. That's 600 seconds, so that gives it 10 minutes. And y'all gonna get really bored if it takes 10 minutes. Hopefully it only takes about 10 seconds. And then, yeah, we're gonna check the AT reset bit. Okay, so that gets us through that. And then, take this back up. All right, so now it says set the tag PID initialize and auto tune. Now, we're not gonna do that yet because I want us to understand what we're doing here. At this time, the output of the IPID is set to the value in the load. So in their case, they had 50. I threw 25 just because 50 kind of makes the mic have a bad hiss on it. And then we need to monitor our process variable. Now, the process variable is this part on the left side, the speed feedback. And they're saying to observe its min and its max. Now, probably, if I was doing this a lot, I probably would write something to capture this min and max, but we'll eyeball it. That'll work. And then it says subtract the max from the min and divide by 2 and put that into that deviation parameter. Then you uncheck the initialize box. And we should see the AT warning go to a 1. We should see some things happening here. We hope. And most importantly, if everything is done, we should see the AT go to a 2. Okay. Let's see if I can remember that well enough to do this. So we already have our checkboxes set up because we're in auto tune mode. As soon as I switch forward to the right, which will be auto, that is going to set the initialize, that's going to set the auto tune, and that should get us running at our load, which is 25. So I'm going to switch forward to the left, to the right. Okay, then no doubt we have 25 on our output.
And now we're supposed to stare at this value, which is honestly slightly too small for me to even see. But I think I've seen 870 and I've seen roughly 890. Yeah, so we should write something so that we're not staring at this. I'm going to arbitrarily say 10, and that's very arbitrarily. So then I'm going to double click on the auto tune. And in that deviation, what we're saying is, hey, if this thing is steady running, it has a deviation of plus or minus 10. Okay, now it says to uncheck the initialize box, and hopefully we see this go to a 1, then we see it go 2, and then very important part, because you can get really caught up in the weeds of the numbers, is be listening, because after that, it's going to set your drive command speed back to 0. I talk to people in our class all the time. If you're applying 0 speed to a motor, it is still putting some voltage on that motor winding. And a fan cools itself by rotating. So you listen, make sure that you're not running this. But all right, so we're going to do it. We should see it go to a 1 here, and then hopefully shortly after a 2. So we're going to right-click the initialize. Oops. Oh, that's right. You can't toggle here, but all right. Now, okay, there's 2 ways to do this, and I'm going to do it the second way because I want you to be able to see it. I think this is developer only that you have add to SPI list. If you don't have developer, you can simply double click on it and you can uncheck the box. But I want y'all to clearly see what happens over here. So I am going to right click the initialize and I'm going to add it to a SPI list. Okay. And here's my checkbox. I uncheck it. Whoops. I did something wrong. Oh, whoopsies. I got a problem. And I see what it is. The whole point of the set and unset from earlier, only wanted these to write one time. I have a good look for a 1 here. This should be a pulse, or in Studio 5000, we would call it a one-shot. So a couple things. This is a good learning opportunity. I want to get everything out of it. So hold on. Don't go offline yet. Let's talk through this. Remember, we've added serval values here. Such as these are hand speed and other things. These values are not in your Connected Components Workbench program. They're only in the PLC. Now in Studio 5000, we can simply hit the Save button, and we would get a prompt saying, do you want to upload your data table values? That does not happen in Connected Components Workbench. So in this case, what we want to do is we want to disconnect. And we want to right-click the Micro850 in the left pane, and we want to upload that. And then we're going to upload with logical values. Strictly amps. Oh, Armstrong World. Okay, in Macon, Georgia. Servo-powered tipper conveyor. That sounds like a lot of fun. Well, they know everybody's there. They're pretty sophisticated PIDs there. Okay, upload succeeded. We're going to uncheck it. And yeah, I made a mistake earlier. And then here's where the cool space bar comes in. I've highlighted this. I'm going to hit the space bar and I'm looking for P. So let's go look for 0. This is going to be on when for one time when it goes true. Now, if you're not sure about these, all you have highlighted, hit the properties over here. See, it says pulse radiusing edge contact. That's what we want there. That's also what we want here. Now, this one needs to be the opposite. It's called an N. And I highlight that one. Oops. Then it's pulse falling edge contact. That's what those should be. I think it's just those 3. I kind of thought about this morning. I was like, I think this would work. All right, let me download that. Let's see. Ardash, can you please make this as a video also? Really appreciate if this content was provided as a video so we can read. Oh, yeah. So all of our live streams are available later on. So yeah, hit that subscribe button down there. And mainly then go to our channel page. And yeah, you can see all our past live streams. And so this is a series that we've been building. Actually, so
I've had a lot of schools ask, can you make one comprehensive offline project or offline video for us? Because some of ours, you don't have access to YouTube at schools. So first of all, why does schools not have access to YouTube? That make any sense. But so yeah, we're actually gonna make a combined one of all of these live streams that we've done on the Micro850. I think in the end it's 14 hours. I don't know why anybody want to listen to 14 hours of me, but yeah, so that'll even be available. All right, so now we'll put it back in the run mode. And since we went offline, and since we went offline and then we uploaded, when I go back into my PID control, then when I double click on my auto tune parameters, everything is there and ready. So still including my 10 and my deviation. So I don't need to do that again, but mainly my auto tune. Let's go check and make sure, but I am in auto tune mode still. And so the moment that I switch 4 to the right, well, that's the disadvantage of a live stream. Is now I got to figure out why. Oh, it worked perfectly fine. When you download, it does break the connection on the PowerFlex 525. And yeah, now we're ready. So let's try that again. Switch 4 to the right. And a couple things to be observed. And when I uncheck this initialize, if it works this time, you'll probably see this output value here change where it's observing how it changes when it does that. And hopefully, if I did everything right, you will see this go to a 1 and then to a 2. So now I'm going to uncheck the initialize button. And well, there it goes. So it went up to 45, it went down to 5, bounced a little bit more. Oh, that is something wrong because we don't have a 2. We'll give it a little bit of time here, but I'm going to guess that I missed something. Not an auto. We have auto tune. Yeah, so mainly we're looking for a 2 here to say that it finished. But yeah, if it isn't finished by now, it's not going to. What did I do wrong? Am I wrong about this checkbox? Does it need to be unchecked? Now I'm not remembering myself. Well, let's say, so it gains to 0. The checkbox was the one, even the first time I did it, it's like, I cannot understand what they're trying to say here. All right, let's try that again with the box unchecked. I swear in the end, I found out that was the issue, was I had to check the box. We'll let it get down to a stop. Actually, we don't need to let it get down to a stop or switch 4 to the right. There we are, uncheck the box. Hello, when this happens. All right, where did I go wrong? Well, let's just hit all the basics. I'll let that run while I do it. But we have it in a periodic task, or as a selectable time interrupt, and it's 200 milliseconds. That part's right. And my speed feedback is right. My set point is at 0. I'm looping in that, limiting it between 0 and 100. All right, I missed something though. That's false. That's false. Let's see. Now I did try this morning. Let me open up the program that I tried it in. Let's go see what I did wrong. See, R2A. Hi everyone, greetings from Costa Rica. Show all variables in panel view 800 is a headache. Show all variables. You mean like finding program tags versus controller tags? Or dash, let's see. I am a big fan of your content. It has really helped me out. I'm a control system integrator myself. Love your video. Great to have you here. Let's see. Well, apparently we're still opening over here. But yeah, that should have been it. I've missed something. Let's see here. We go to this one. And just see what I did wrong. Well, that looks pretty much exactly the same. Got a few words different, but no, that's pretty much what we have here. And let's see, what did I make this one? So now I did arbitrarily throw an interrupt rating in it. Let me no, I did 200 milliseconds there. We know it's running. Let's go see what I made the variables in this one's auto tuning. I have a way lower number in this one. Well, a higher number should make it easier, I thought. A lower number there, too. Okay, well, maybe we do need to do a little work there. Okay, let's try it. It's about all PID. Because I can't think of anything else. Speed feedback. Auto tune, gains. That should be it. All right, well. So let's see. I want that higher because, yeah, that'll blow y'all's eardrums out. But if I put that lower, I swear that makes it worse. You know, just because I got to try it. We're going to put 20 in that one. We switch it back to auto. We have the initialize. We have the auto tune. So I should be able to uncheck the PID initialize box. And it does not work. So, but all right, let's go back to this one check box. Because I swear this box right here is what I battled last time. I swear that thing's got to be checked. Switch it off. It's pretty steady. Huh. Oh, there it goes. Okay, well, now I want to put that back where it was. I swear it's that checkbox. That checkbox like whipped me the first time I did this. I want to put that back at 10 because that seems really high now. You switch it. You uncheck it. Okay, I cannot explain to you that checkbox. We're exactly back where we were. But mainly we got a 2 here, and that was the success we were looking for. But there is something really funky about that box. So apparently running it and checking and running it and unchecking, I have no idea. But okay. All that to get to this PID out gain. This now has its recommended gains in it. Now, coincidentally, since it groups it by gain PID, right above it, here's our current gains. And we probably could put some software code in to do this, but I'm just going to copy that. And I'm going to paste it. And then we're going to copy this one. Paste it. Then we're going to copy this one. Then we're going to paste it. There we go. Hey. One additional thing that we have to address. So now we want to put our set point back where we were. I want to put it back at 900. And I have not seen this documented anywhere. But this is what I came up with is we're at 900. Look at our output. It is just climbing and climbing and climbing. So now when we try to switch our PID on, it's going to start off wide open. Now, there was a lot of documentation that is completely gibberish about how this PID auto works, but it does not do what you think it does, such as switching between an auto and a manual mode. In fact, if we go and we look at, let me get that back up here. Yeah, let me search for auto. Of course, auto tune is going to be in here 50,000 times. Where's the auto? Oh, it's in here somewhere, but it's 100% gibberish, what they say it does. Or is it not in this one? Okay. Well, I was hoping it was in this one because this one is much easier to find stuff in, but that's all right. We got the manual here because I was like, need this. Over there it is, auto mode. Now, sure, your controller runs in normal mode. Well, you're going to have to define normal for me. False, derivative term is ignored, forcing the controller output to track the feedback within the controller limits and allowing controller to switch back to auto without bumping the output. What the frick? I have no idea what they mean. And yeah, when I looked it up, all I could find was a boatload of questions about the same thing. And so that is not what we want to do. Whoops. Now have I done this? Oh. I drug a screen to the wrong spot. Now I got to get all my screens back. There it is. Get that one back up there. So what I found is if the set point was at 0, output, so we're going to get that going. All right, let's just try it first so we can see exactly what I'm talking about here. I'm going to switch it to auto. Whoops, we're going to put it back at 900. And we switch it on. Whoops, you got to take it out of auto tune. Back to main. We're done with you, so we're going to toggle you back off. And now we go over here. See, it like went wide freaking open and then dropped back off. Now, if that set point started out at 0, then it seems to drop down. You see the output dropping now? It'll drop down to 0. So what I did, and again, I hope somebody corrects me and shows me a better way, is I made it so the PID set point is 0 when we're not running, and then I take it to the desired set point when we are running. So I'm going to disconnect, and we are going to open up our main program. And then, we already have some handoff auto logic right here. I'm just going to add another rung right beneath here. And in this case, actually, no, I was getting ready to repurpose a rung, but no, we don't want to repurpose a rung. If we are in auto. We are not in auto tune. Did I call that auto tune mode? Then I am going to move on our speed set point to our PID set point. Now, if we are not in auto, or we are in auto tune, then auto, or we're not in auto tune, to move. This is going to paste in the wrong place. It irritates me. Oops, undo. Never figure out how to paste right here. I want this to go right in here. Anybody know how to do that? Always ends up over there. We're going to move 0.0 into there. So this way, when we're in auto, our PID set point will go to whatever we want it to be. And we're not, we put it to 0. And this is the best way I've found to kind of make that PID stay calm down while we're doing it. Okay, let's see. Where am I at over here? Let's see. Strictly, if you're doing, I'm doing all this in CCW. We're getting ready to do this whole thing in Studio 5000. Let's see. Oh, I just missed that question. What the heck is a PID? Proportional integral derivative. It's used a lot in process control. So let's say we have a temperature burner system. We're trying to attain a temperature of something, have a combustion valve on it or something, so that we can adjust to try to keep something at a desired level. Let's see. How do we enter the KCTD and TI values? I'll show. All right. Well, I may have already done that. If not, we'll bounce right back there in a second. Let's see how this works out. So we are going to make sure I hit that first. So if we go back to our PID, then the PID gains is where that actually is. Yeah, and in your case, there's the proportional, the integral, and the derivative are right. Okay, now we're sitting at 0. We're going to put, we are going to make sure that because our auto tune is going to be back on. That's what I don't like. That then, and what else did I do wrong now? You got me again. Every time we download, it faults the drive because I lost my Ethernet connection. I actually sounded pretty darn good on it. Am I a manual or something? Let's see here. We're in auto. It's definitely varying. We can even, okay. All right. So that it could be surprising, but that actually seems like it auto-tuned incredibly well. So if you remember from our last live stream, the last piece of this is in ignition. I had you set up your speed command and your speed feedback. Now, one thing I've added is our speed set point. And our speed set point, read a value in it. So no, I don't believe this is actually working that well. Because where is our set point is currently 0. 900. Okay, we switch it. Oh, that switched to hand. I did, I think. Okay, so it is adjusting incredibly slowly is the issue we're having now. But why did they not set it to 0? I did something wrong with that. PID. Oh. All right, let me go back to this other program. I think I just flipped these around. Because, let's see, this one's a little bit different, but what did I do differently? Actually, mainly, oh yeah, I told you completely. Auto speed command, cross-reference U, right here. Where we're not in, I did it to the set point. I meant to do it to the auto speed command. It's supposed to be at 0 when we're not running. Oh, thank you for telling me. How long have I been not being able to see the screen? That's okay. I told you one thing wrong here. We're going to go back offline. Sorry about that. Amber's here. She'd already told me that. But I'm going to blame her. So yeah, I told you wrong here. I said change the speed, PID speed set point. Right here, we want to change. In fact, I'm just going to add another run because, yeah, that gets a little clunky there. Not running. It's the PID output. To 0. And Ardash, you don't like to see my face? Yeah, I got a heck of a delay today. I'm not sure what I've done, but yeah, I got a lot of things going on with the computer apparently. We're going to reset the drive this time. Right, there we go. Now we switch it. Oops, actually, I'm not even sure why it is trying to that. All right, I've still got something going on. I want it done at 900. There we go. Why is it staying fixed at? Oh, okay. No, the initial. Oh, I forgot the auto tune again. Like, why is that staying that way? But yeah, we're in auto tune mode. Turn that off. This is set point not going across. Oh, because yeah, I kind of botched that there at the end. Speed set point. PID. Where's PID set point? Did I take that out by accident? Oh, the speed set point. All right, I think I did just botch that. What did I just do? Cross-reference. All right, man. I think I just entered a value in the wrong spot or something. Thought I just entered 900 here. 900. Cold fog in my brain here. Now, let's see. So, switch it over. All right. So, we have a very slow response right now. But we are getting there. We're definitely going to have to do some work on that. Well, now let's see what this looks like. All right. So, we are climbing.
All right, very slow and steady. So this would definitely be an example of a slow responding PID. But eventually it will get there. But I already grabbed some other settings, so let's see how those work. Because over here, I closed that. Hopefully I didn't mess everything up because I had some settings I was going to paste. Oh, okay. Well, we're going to try the auto tune again then with the new settings and find out how it happens. So now I'm toggle you. And then we go back into here. Oh, there's what I did wrong. You remember I told y'all if you download it, I didn't have those. I was like, why is that running so slow? It doesn't have any of the auto tune parameters in. So you get to see me tune it again because I forgot to upload after that last change. It's all right there. So we are in auto tune mode. We switch over. We look good. We right click the initialize, add to SPI list. Oops, well, now I have it twice. Uncheck it. All right, and now we got that whole funky thing with this thing. I've got to figure, this is the one part I hope somebody can explain better to me. I really would love not to just check that box and uncheck that box and do it again. But I think that's the insanity piece that gets us there. Uncheck. We do it one more time as insanity. Maybe that is not it. I've got to figure this one piece here. Actually, of course, I did change the 20 last time. Maybe it is that my deviation is too tight. So somebody one day is going to have to explain to me, so we have an auto tune of two, that means we're successful. Somebody's going to have to explain to me this whole craziness with this AT reset parameter here. But yeah, that's why I end up fighting it every time. So if you're struggling to get that 2 up, try to auto tune it with this off and then auto tune it with it on again, as insane as that sounds. But okay, now we have our PID output gains, which embarrassingly I forgot to save. Hopefully they're about the same numbers. So we copy that. And that'll be our proportional. We copy this. That'll be our derivative, our integral. We copy this. That will be our derivative. Okay, so now we turn off our auto tune. Didn't mean to pin you. Oops. And then, actually, we should be able to do it from over here. We have a speed set point of 900. All right, so we got a little jaggediness here to work with, but all right. There's our first run of this thing. I know that was an incredible amount to go through to get here. But all right, let's talk a little bit about ignition here because at the end of the last video, I realized I didn't change this time span. This is way too long of a time span for us to really be looking at this. So what I want you to do is we're going to hit the play button up here. Drop this number down. Let's bring it down to a minute. That gets us where we can kind of see what all is going on here. And then even then, well, no, because now what I want to do is I want to change my set point. We want to see how this responds because, that's part of it. What is cool that you can get it to smoothly come up. We definitely got to do something about that little jagged peak. But what happens if we change our set point now? Now, did I make this so I could I didn't make it so I could change it in ignition. That's all right. To show how easy we can make it change in ignition, we're going to hit the stop button. And we are going to bring in a numeric text field. It's going to drop it in. We'll drop it right beside of it. That way it's happily labeled. And over here, here's our speed set point. We're going to grab it.
And we're just going to bring it over that yellow part. And now I should be able to change, oops, can I hit the play button? Now I should be able to change this one to 1800. Oops, and all right. So I don't have it set up for read-write right now. So I go to project, com read-write. I'll enter 1800. All right, you can see we still got the same kind of similar little overshot right there. But that gets us to where we can play with this now. So now what we want to do, now I'm getting ready to pass it over to you to do, is what we want to do, you want to do is, let's not make myths about what the P, the I, and the D are, because, I think in every PID video, I hear people say, well, P is your past, I is your present, D is your future. No. So what we want to do is we want to play with it and figure it out. So first of all, we have the auto tune. After we do that funky checkbox, in fact, let me go ahead and try it one time to make sure no insanity happens here. But if I was to take my auto tune, and it seems like after you do that one time, this works, but let's find out. I was to change my step size, I don't know, to 15. Then we go to enable our auto tune. Then we switch 4. And we uncheck it. Oh man, I got to figure out why there's fog here. Actually, this might be on me. Actually, all right, now here's where we do need to start. And here's part of it. You need to start understanding more about these. I dropped that step size down and probably made it where that deviation was not large enough. Let's make it 25. Then we'll go the opposite direction. Oops, I can't go to 25 because that would put me at 0. Oh, let's just put 22 in, just so we have a different number. Then we uncheck it. And let's just go see if those parameters look any different. They probably won't for that minute of a step size. We need to actually change our variation too. Well, actually, there is a slight difference in those numbers, but okay. Now let's just throw them in, just so we can see that it may be different, it may not be. I doubt that is enough to make a difference, but let's go over here now. Oops, I should have put that auto tune on the selector switch. Now we go over here. We switch it. Oh, yeah, it definitely did not like that. Now, one thing we tuned it for a much lower starting frequency. Probably should have had this up in the 50% range when we did it. But all right. Now, you want to know, what does the proportional, what is the integral, what does all that do? Then let's take them one at a time. Now, one at a time, I said, there's nothing worse, especially in a PID, than changing 20 things. But now let's get our gains. All right, we want to know, what does the proportional, how does it affect it? All right, now this is 0.03. What happens when we make it 0.01? And then we go over here. Whoops. So that was our previous graph. So we see it definitely had less of a curve over, less of an overshoot, taking longer to get there though. And yeah, it finally does get there. Oh, don't worry about that. That's a flaw in my program. I noticed that earlier. Okay, but the goal here was to get you set up where you could run a PID in the Micro820. I'd say I'm not a super fan of the PID in the Micro820. This is why, I find a lot of people, they end up rolling their own even, because it is just the calculation piece, and especially if you're coming from studio or something, it's like we have manual control, we have all these different things, all types of cool features. But the big thing now is, instead of
taking and saying, well, I think the proportional does this. What happens if you double proportional? What happens if you change the integral? And just start to observe and learn how the different ones change the different values. Wow, you folks have made it to the end of this video, and that is amazing. But it's only the beginning of your journey. You're still going to need to do a lot more practicing. There's a lot more items that you need to understand as far as practical applications and things that you will see out in a manufacturing facility. And so if you've made it this far, then hit that subscribe button, because I know you're going to be great for our industry. We put out one how-to video a week. And also, I've created this playlist right here that is going to have some really helpful tips to get you started. And also, there is a course down in the description that has more details on connecting a PID's workbench.